CTMU Q&A. Q. Chris, I'm not a mathematician or physicist by any stretch, but I am a curious person and would like to know more about the CTMU, cognitive theoretic model of the universe. I am particularly interested in the theological aspects. Can you please explain what the CTMU is all about in language that even I can understand? A. Thanks for your interest, but the truth is the CTMU isn't all that difficult for even a layperson to understand. So sit back, relax, kick off your shoes and open your mind. Scientific theories are mental constructs that have objective reality as their content. According to the scientific method, science puts objective content first, letting theories be determined by observation. But the phrase a theory of reality contains two key nouns, theory and reality, and science is really about both. Because all theories have certain necessary logical properties that are abstract and mathematical, and therefore independent of observation, it is these very properties that let us recognize and understand our world in conceptual terms. We could just as well start with these properties and see what they might tell us about objective reality. Just as scientific observation makes demands on theories, the logic of theories makes demands on scientific observation, and these demands tell us in a general way what we may observe about the universe. In other words, a comprehensive theory of reality is not just about observation, but about theories and their logical requirements. Since theories are mental constructs, and mental means of the mind, this can be rephrased as follows: mind and reality are linked in mutual dependence at the most basic level of understanding. This linkage of mind and reality is what a theory of everything is really about. The CTMU is such a theory. Instead of being a mathematical description of specific observations, like all established scientific theories, it is a meta-theory about the general relationship between theories and observations, i.e., about science or knowledge itself. Thus, it can credibly lay claim to the title of Mind and reality, the abstract and the concrete, the subjective and the objective, the internal and the external, are linked together in a certain way, and this linkage is the real substance of reality theory. Just as scientific observation determines theories, the logical requirements of theories to some extent determine scientific observation. Since reality always has the ability to surprise us, the task of scientific observation can never be completed with absolute certainty, and this means that a comprehensive theory of reality cannot be based on scientific observation alone. Instead, it must be based on the process of making scientific observations in general, and this process is based on the relationship of mind and reality. So the CTMU is essentially a theory of the relationship between mind and reality. In explaining this relationship, the CTMU shows that reality possesses a complex property akin to self-awareness. That is, just as the mind is real, reality is in some respects like a mind. But when we attempt to answer the obvious question whose mind, the answer turns out to be a mathematical and scientific definition of God. This implies that we all exist in what can be called the mind of God, and that our individual minds are parts of God's mind. They are not as powerful as God's mind, for they are only parts thereof, yet, they are directly connected to the greatest source of knowledge and power that exists. This connection of our minds to the mind of God, which is like the connection of parts to a whole, is what we sometimes call the soul or spirit, and it is the most crucial and essential part of being human. Thus, the attempt to formulate a comprehensive theory of reality, the CTMU, finally leads to spiritual understanding, producing a basis for the unification of science and theology. The traditional Cartesian divider between body and mind, science and spirituality, is penetrated by logical reasoning of a higher order than ordinary scientific reasoning, but no less scientific than any other kind of mathematical truth. Accordingly, it serves as the long-awaited gateway between science and humanism, a bridge of reason over what has long seemed an impassable gulf. Q. Hey Chris, what's your take on the theory of Max Tegmark, physicist at the Institute for Advanced Study at Princeton? He has a paper on the web which postulates that universes exist physically for all conceivable mathematical structures. Is it as wacky as he postulates? A. Since Max claims to be on the fast track to a toe of his own, I just thought I'd offer a few remarks about his approach, and point out a few of the ways in which it differs from that of the CTMU. Many of us are familiar with the anthropic principle of cosmology, the AP, and Everett's many worlds, MW, interpretation of quantum theory. These ideas have something in common. Each is an attempt to make a philosophical problem disappear by what amounts to Wittgensteinian semantic adjustment, i.e., by a convenient redefinition of certain key ingredients. Specifically, MW attempts to circumvent the quantum measurement problem, the decoherence of the quantum wave function, by redefining every quantum event as a divergence of universes, shifting the question what happens to the unrealized possible results of a measurement when one possibility is exclusively actualized, to why can we not perceive the actualizations of these other possible results, while the AP shifts the question why does the universe exist, to why is this particular universe perceived to exist. Both MW and the AP thus shift attention away from objective reality by focusing on the subjective perception of objective reality, thereby invoking the distinction between subjectivity and objectivity. What usually goes unstated is that mainstream physical and mathematical science have traditionally recognized only the objective side of this distinction, sweeping the other side under the rug whenever possible. Perhaps intuiting the MW-AP connection, Max Tegmark, formerly at the Institute of Advanced Studies at Princeton, has effectively combined these two ideas and tried to shift the focus back into the objective domain. First, noting that MW is usually considered to involve only those universes that share our laws of physics, but which differ in the initial and subsequent conditions to which those laws are applied, Tegmark extends MW to include other universes with other sets of physical laws, noting that since these sets of laws are mathematical in nature, they must correspond to mathematical structures, abstract structures that we can investigate right here in this universe. And that, he says, may explain why this universe is perceived to exist. The conditions for the evolution of perceptual entities may simply be the mean of a distribution generated by distinct physical nomologies corresponding to these mathematical structures. In other words, the conditions for the existence of self-aware substructures, perceptual life forms, may simply be the most likely conditions within the distribution of all possible universes. And since the latter distribution corresponds to the set of mathematical structures in this universe, the hypothesis can be tested right here by mathematical physicists. Of course, Tegmark's attempt at a toe leaves unanswered a number of deep philosophical questions. First, what good does it do to anthropically explain this universe in terms of an MW meta-universe unless one can explain where the meta-universe came from? What is supposed to prevent an informationally barren infinite regress of universes within meta-universes within meta-meta-universes, and so on? Second, what good is such a theory unless it contains the means to resolve outstanding paradoxes bedeviling physics and cosmology, paradoxes like quantum non-locality, ex nihilo cosmology, the arrow of time, and so forth? Third, what is the true relationship between mathematics and physics, that one can simply identify sets of physical laws with mathematical structures? It's fine to say that physics comes from mathematics, but then where does mathematics come from? Fourth, where are the mathematical tools for dealing with the apparently ultra-complex problem of computing the probability distribution of universes from the set of all mathematical structures, including those yet to be discovered? Fifth, what is the real relationship between subjective and objective reality, on which distinction both many worlds and the anthropic principle are ultimately based? Etc. Since one could go on for pages, it seems a little premature to be calling Tegmark's theory a toe, or even a reasonable toe precursor. And although I am not saying that his theory contains nothing of value, I'm a bit puzzled by the absence of any mention of certain obvious mathematical ingredients. For example, Topo's theory deals with topoi, or so-called mathematical universes consisting of mathematical categories, mapping algebras, equipped not only with the objects and morphisms possessed by categories in general, but special logics permitting the assignment of truth values to various superficially non-algebraic, for example physical, expressions involving the objects. Why would any toe purporting to equate physical universes to mathematical structures omit at least cursory mention of an existing theory that seems to be tailor-made for just such a hypothesis? This in itself suggests a certain amount of oversight. Tegmark may have a few good ideas knocking around upstairs, but on the basis of what his theory omits, one can't avoid the impression that he's merely skirting the boundary of a real toe. In contrast, the CTMU deals directly with the outstanding paradoxes and fundamental interrelationship of mathematics and physics. Unlike other toes, the CTMU does not purport to be a complete theory. There are too many physical details and undecidable mathematical theorems to be accounted for, enough to occupy whole future generations of mathematicians and scientists, and merely stating a hypothetical relationship among families of subatomic particles is only a small part of the explanatory task before us. Instead, the CTMU is merely designed to be consistent and comprehensive at a high level of generality, a level above that at which most other toes are prematurely aimed. The good news is that a new model of physical space-time, and thus a whole new context for addressing the usual round of quantum cosmological problems, has emerged from the CTMU's direct attack on deeper philosophical issues. Q. Einstein says that gravity is a result of mass energy causing a curvature in the four-dimensional space-time continuum. At the Planck scale, 10⁻³ centimeters, is space still continuous, or is space discontinuous? I have read books saying space-time may have holes or breaks in continuity. Are these holes related in any way to gravitons, or reverse time causality? Question from Russell Rearson. A mathematical space is continuous if it has a metric that withstands infinitesimal subdivision. To understand what this means, one must know what a metric is. Simplistically, a metric is just a general distance relationship defined on a space as follows: if A and B are 2 points in a space, and C is an arbitrary third point, then the distance between A and B is always less than or equal to the sum of the distances between A and C, and B and C. That is, where d, x, y, is the distance between 2 points x and y. D, A, B, equal d, A, C, plus d, B, C. If this relationship continues to hold no matter how close together the points A, B and C might be, then the space is continuous. On the other hand, where the distance concept is undefined below a certain threshold, metric continuity breaks down on that scale. Since the Planck limit is such a threshold, space is discontinuous below the Planck scale, implying, of course, that it is discontinuous, period. Not only is it granular in a slippery kind of way, but the grains in question are effectively without spatial extent. Because space and time are undefined below quantum limits, they no longer have extensionality or directionality. But if we interpret this to mean that anything, including causality, can flow in any direction whatsoever, then reverse causality is conceivable on sub-Planck scales. In fact, some theorists conjecture that on these scales, continuous space-time becomes a chaotic quantum foam in which distant parts of the universe are randomly connected by microscopic wormholes. That's pretty much the party line among physicists. Now let's bring philosophy to bear on the issue. At one time, space was considered to consist of ether, a quasi-material substance through which physical objects were thought to swim like fish through water. But since the introduction of Einstein's theory of relativity, nothing material remains of empty space, although it is permeated by fields and vacuum energy. These are merely contained by space and are not equivalent to space itself. Space has instead become a mathematical abstraction called a tensor field that confers relative attributes like location, direction, orientation, distance, linear and angular velocity, and geometry on physical objects and energy fields. Because empty space, as abstracted from its contents, cannot be observed and has no observable effect on anything, it is not physical in the usual sense. That which is immaterial is abstract. An abstraction is a mental process that abstracts or educes general relationships from observations. So from a philosophical viewpoint, saying that space is immaterial and therefore abstract amounts to saying that it is mental, that it is to some extent composed of mind rather than matter. Although this runs against the scientific grain, it is consistent with our dominant physical theories of the very large and the very small, namely relativity and quantum mechanics. In relativity, space and time are combined in an abstract manifold called spacetime whose points are physical events that can be resolved in terms of mutual behavioral transduction of material objects, a process fundamentally similar to mentation. And quantum mechanics characterizes matter in terms of abstract, immaterial wave functions that are physically actualized by interactions of an equally immaterial nature. What does this mean regarding the continuity of space-time? Simply that, like space-time itself, continuity and its quantum scale breakdown are essentially mental rather than material in character. As Berkeley observed centuries ago, reality is ultimately perceptual, and as we know from the subsequent debate between Hume and Kant, perception conforms to mental categories like space and time. So rather than being purely objective and physical in a materialistic sense, space has a subjective aspect reflecting the profoundly mental nature of our reality. Gravitons, though subject to some of the same reasoning, are another matter. Q. Does the CTMU allow for the existence of souls and reincarnation? A. From the CTMU, there emerge multiple levels of consciousness. Human temporal consciousness is the level with which we're familiar. Global, parallel, consciousness is that of the universe as a whole. The soul is the connection between the two, the embedment of the former in the latter. In the CTMU, reality is viewed as a profoundly self-contained, self-referential kind of language, and languages have syntaxes. Because self-reference is an abstract generalization of consciousness, consciousness is the attribute by virtue of which we possess self-awareness, conscious agents are sublanguages possessing their own cognitive syntaxes. Now, global consciousness is based on a complete cognitive syntax in which our own incomplete syntax can be embedded, and this makes human consciousness transparent to it. In contrast, our ability to access the global level is restricted due to our syntactic limitations. Thus, while we are transparent to the global syntax of the global conscious agency God, we cannot see everything that God can see. Whereas God perceives one total act of creation in a parallel distributed fashion, with everything in perfect superposition, we are localized in space-time and perceive reality only in a succession of locally creative moments. This parallelism has powerful implications. When a human being dies, his entire history remains embedded in the timeless level of consciousness, the deic level. In that sense, he or she is preserved by virtue of his or her soul. And since the universe is a self-refining entity, that which is teleologically valid in the informational construct called you may be locally reinjected or redistributed in space-time. In principle, this could be a recombinative process, with the essences of many people combining in a set of local injections or reincarnations. This could lead to strange effects, for example, a single person remembering simultaneous past lifetimes. In addition, an individual human sublanguage might be vectored into an alternate domain dynamically connected to its existence in space-time. In this scenario, the entity would emerge into an alternate reality based on the interaction between her local level of consciousness and the global level embedding it, i.e., based on the state of her soul as just defined. This may be the origin of beliefs regarding heaven, hell, purgatory, limbo, and other spiritual realms. Q. If I have interpreted you correctly, you maintain that the universe created itself. How did this come about? What existed before the universe and when did the universe create itself or come into being? Celia Jocelyn. A. You're asking three distinct but related questions about cosmology: how, when, and as what did the universe self-create? The universe can be described as a cybernetic system in which freedom and constraint are counterbalanced. The constraints function as structure, thus, the laws of physics are constraints which define the structure of space-time, whereas freedom is that which is bound or logically quantified by the constraints in question. Now, since there is no real time scale external to reality, there is no extrinsic point in time at which the moment of creation can be located, and this invalidates phrases like before reality existed and when reality created itself. So rather than asking when the universe came to be, or what existed before the universe was born, we must instead ask what would remain if the structural constraints defining the real universe were regressively suspended. First, time would gradually disappear, eliminating the when question entirely. And once time disappears completely, what remains is the answer to the what question, a realm of boundless potential characterized by a total lack of real constraint. In other words, the real universe timelessly emerges from a background of logically unquantified potential to which the concepts of space and time simply do not apply. Now let's attend to your how question. Within a realm of unbound potential like the one from which the universe emerges, everything is possible, and this implies that everything exists in the sense of possibility. Some possibilities are self-inconsistent and therefore ontological dead ends, they extinguish themselves in the very attempt to emerge into actuality. But other possibilities are self-consistent and potentially self-configuring by internally defined evolutionary processes. That is, they predicate their own emergence according to their own internal logics, providing their own means and answering their own hows. These possibilities, which are completely self-contained not only with respect to how, what, and when, but why, have a common structure called SCSPL, self-configuring self-processing language. An SCSPL answers its own why question with something called teleology, where SCSPL is God to whatever exists within it. Teleology amounts to the will of God. Q. Is there a reason for reality to exist? Specifically, some mathematical proof that would prove that a reality must exist? This would of course lead into the more common type of questions, like does this reality exist? Perhaps there's a mathematical or logical proof somewhere that shows that something must exist, reality by default, or that total non-existence can't exist by its very definition. Bill. A. See the above response to Celia. Q. I think I got clued in by an old Alan Watts text that said, I think, if you can agree that you are not separated from reality, then you must agree that your self-awareness is also reality's awareness of itself. This is of course continued to, if God exists and cannot be separated from reality, then your awareness is also his awareness of himself, etc. etc. I think this approximates some of what you have said, but doesn't require the upper-level math. Bill. A. If Watts said these things, then he anticipated the CTMU, loosely speaking, of course. But whereas Watts used conditional, if-then, formulations, similar statements are unconditionally supported by certain elements of mathematical structure that he omitted. Q. Given my own self-awareness and inability to separate from reality, I have no doubt that this reality does exist. The proof is in the pudding. So while I do not need proof that there is a reality, that I am part of that reality, and that my awareness is reality's awareness of itself, I do not know why all of this stuff exists, myself included. If there is a reason that reality must exist, then that would also be the reason that I exist. Which is probably what I am really wondering. Is the answer that giving myself a reason to exist is the reason for my existence? Bill. A. The first part of your why question is answered at the end of the above response to Celia. Since the meaning of life is a topic that has often been claimed by religion, we'll attempt to answer the second part with a bit of CTMU-style logical theology. Within each SCSPL system, subsystems sharing critical aspects of global structure will also manifest the self-configuration imperative of their inclusive SCSPL, that is, they exist for the purpose of self-actualization or self-configuration, and in self-configuring, contribute to the self-configuration of the SCSPL as a whole. Human beings are such subsystems. The purpose of their lives, and the meaning of their existences, is therefore to self-actualize in a way consistent with global self-actualization or teleology, i.e., in a way that maximizes global utility, including the utility of their fellow subsystems. Their existential justification is to help the universe, aka God, express its nature in a positive and self-beneficial way. If they do so, then their souls, or relationships to the overall system, God, attain a state of grace and partake of systemic timelessness, life eternal. If, on the other hand, they do not, if they give themselves over to habitual selfishness at the expense of others and the future of their species, then they are teleologically devalued and must repair their connections with the system in order to remain a viable part of it. And if they do even worse, intentionally scarring the teleological ledger with a massive net loss of global utility, then unless they pursue redemption with such sincerity that their intense desire for forgiveness literally purges their souls, they face spiritual interdiction for the sake of teleological integrity. Such is the economy of human existence. Much of what we have been taught by organized religions is based on the illogical literalization of metaphorical aspects of their respective doctrines. But this much of it is true: we can attain a state of grace, we can draw near to God and partake of His eternal nature, we can fall from God's grace, we can lose our souls for doing evil. In all cases, we are unequivocally answerable to the system that grants and sustains our existence, and doing right by that system and its contents, including other subsystems like ourselves, is why we exist. Sometimes, doing right simply means making the best of a bad situation without needlessly propagating one's own misfortune to others. The necessary sufferance and non-propagation of personal misfortune is also a source of grace. Further deontological insight requires an analysis of teleology and the extraction of its ethical implications. Now for a couple of qualifiers. Because we are free, the teleologically consistent meaning of our lives is to some extent ours to choose, and is thus partially invested in the search for meaning itself. So the answer to the last part of your question is yes. Determining the details of your specific teleologically consistent reason to exist is part of the reason for your existence. Secondly, because God is the cosmos and the human mind is a microcosm, we are to some extent our own judges. But this doesn't mean that we can summarily pardon ourselves for all of our sins, it simply means that we help to determine the system according to whose intrinsic criteria our value is ultimately determined. It is important for each of us to accept both of these ethical responsibilities. Q. Humor me, Chris. Why does this work, and why in God's name would someone do this? I'm sending it to you because you know everything. Thanks. Eleanor Mondale, Southampton, New York. It only takes about a minute, work this out as you read. Be sure you don't read the bottom until you've worked it out. This is not one of those waste of time things, it's fun. 1. First of all, pick the number of times a week that you would like to have chocolate. Try for more than once but less than 10. 2. Multiply this number by 2, just to be bold. 3. Add 5. 4. Sunday. 4. Multiply it by 50, being a bit stupid, I'll wait while you get the calculator. 5. If you have already had your birthday this year, add 1751. If you haven't, add 1750. 6. Now subtract the 4-digit year that you were born. If you remember, you should have a 3-digit number. The first digit of this was your original number, i.e., how many times you want to have chocolate each week. The next two numbers are your age. This is the only year, 2001, it will ever work. So spread it around while it lasts. Impressive, isn't it? One reason people find this amazing is that it seems to reveal a mysterious mathematical connection between your age and your appetite for chocolate. Otherwise, why would it yield your age even though all you're feeding in is the number of times per week you want to eat chocolate? Shouldn't the randomness of your appetite for chocolate mess up your age? How does your age get in there in the first place? It must happen when you subtract your year of birth. But shouldn't subtracting your year of birth destroy any information regarding your appetite for chocolate? No. The procedure is structured in such a way that the number you choose simply gets bumped up a couple of place values, where it can't cross wires with the basic age and birth year arithmetic. To see this, assume that you don't like chocolate and want to eat chocolate 0 times per week, i.e., that your chocoholic index is 0. Then what you start with is 0x2 plus 5, x50 equal 5x50 equal 250. Now subtract 250 from 2001. What do you get? Presto! 2001 to 250 equal 1751. That is, because 250 plus 1751 equal 2001. You're simply calculating the current year by adding 1751. So now we've got the current year, 2001. But what happens when you subtract your year of birth from the current year, provided you've already had your birthday? You get your age. That's how the age and birth year arithmetic was reverse engineered. Now what happens if you start upping your chocoholic index 1 binge at a time? If you up it from 0 to 1, you get 1x2 plus 5, 50 equal 350. Instead of 250, which means you're adding 350 to 250 equal 100 to your age. If you up it to 2, you get 2x2 plus 5, 50 equal 450. Which means you're adding 450 to 250 equal 200 to your age. And so on and so forth. Multiplying your chocoholic index by 2x 50 equal 100 simply moves it up to the 102 hundreds place, where it can't affect the 101 and 100 tens and ones places containing your age. It's a red herring. The author of this trick states that it can only be used this year, 2001. Is that true? Well, yes and no. It's true as long as we insist on adding the magic number 1751. But it's false in the sense that we can update or backdate the trick to any year we like by instead adding a number equal to that year minus 250. For example, next year we'd add 1752, while in the year 2101, we'd add 1851. What if you want to eat chocolate 10 or more times per week? No problem. But in that case, you end up with a number of more than 3 digits. The 101 and 100 places still contain your 2-digit age, while the higher places contain your 2, 3, or n-digit chocoholic index. Can we change this trick into a new one? Sure. Choose the number of fast food burgers you want to eat per day, your wimpy index, multiply it by 4, add 12, multiply the result by 25, add 1701, 1700. If you haven't had your birthday yet, subtract your year of birth, and marvel at the results. This is sufficiently close to the old trick that you should be able to see how to cook up as many such tricks as you like. Note that the product of the first and third numbers equals 100, that's the multiplier that bumps your wimpy index up 2 places, while the fourth number equals the current year minus the product of the second and third numbers. Why would someone do something like this? It's just a bit of mathematical legerdemain that probably has the person who cooked it up laughing himself, or herself, silly over how gullible, innumerate, and greedy for chocolate most of us are. Q. A couple of questions about the CTMU. Christopher Michael Langan said in his introduction following, thus, if D, S, contains superphysical components, they are embedded in S right along with their physical counterparts. Indeed, this convention is already in restricted use in string theory and M theory, where unseen higher dimensions get rolled up to sub-Planck diameter. If I understood it right, the superphysical component in string and M theory is called superphysical, because the model does not assume it to be part of the physical universe. Taking on that thought and considering the definition of the real universe in the CTMU, I have to doubt that the superphysical component is even part of the real universe. Does anyone know where my mistake in thought lies? A. As noted by Berkeley, we can know reality only through perception. So our theories of reality necessarily have a perceptual or observational basis. But as noted by Kant, the process of observation has substantial internal complexity. It is a relationship of subject and object with sensory, phenomenal, and cognitive, categorical, components. So reality is at once monic, because uniformly perceptual, and dualistic, because perception has 2 complementary aspects. Thus, the dual aspect monism of the CTMU. Now consider physics. Because physics is governed by the scientific method, it deals exclusively with phenomena. Thus, it effectively diverts attention away from the cognitive, categorical aspect of perceptual reality, without which neither phenomena nor scientific theories could exist. Because physics is irreducibly dualistic and takes the fundamental separation of mind and matter as axiomatic, it cannot provide us with a complete picture of reality. It can tell us only what lies outside the subjective observer, not within. By definition, reality must contain all that it needs to exist. Equivalently, anything on which the existence of reality depends is real by definition. If it were not, then reality would be based on non-reality and would itself be unreal, a semantic contradiction. So attempts to explain reality entirely in terms of physics are paradoxical. Reality contains not only the physical, but the abstract machinery of perception and cognition through which the physical is perceived and explained. Where this abstract machinery is what we mean by the superphysical, reality has physical and superphysical aspects. Physical and superphysical reality are respectively concrete and abstract, i.e. material and mental in nature. The question is, do we continue to try to objectivize the superphysical component of reality as do the theories of physics, strings, and membranes, thus regenerating the paradox? Or do we take the CTMU approach and resolve the paradox, admitting that the superphysical aspect of reality is mental in a generalized sense and describing all components of reality in terms of SCSPL, syntactic operators with subjective and objective aspects? My advice, we take the CTMU approach, relegating the scientific method to the phenomenal side of reality theory. After all, M-theory is beyond the empirical scope of the scientific method already, and recognizing that the universe is everywhere both subjective and objective, rational and empirical, mental and material. Anything else would lead to reductio ad absurdum. Q. Scientists understand how the universe was made. My question is, where did the matter, or the energy which eventually became the matter, come from to form the universe? Bob Ken Arsa, Glen Head, New York. A. By definition, there is nothing outside of reality that is real enough to contain reality. So reality is self-contained. A self-contained medium must provide that which is necessary to its own existence. So if energy is necessary for the existence of reality, reality must find that energy within itself. Because matter consists of energy according to Einstein's famous equation E=mc2, this applies to matter as well. That is, the universe, using its own energy, made its own matter. How could it do this? By configuring itself in such a way that the matter it made would be recognized as such by other matter. Q. What came first, the chicken or the egg? Those are your choices, either the chicken or the egg. Any other answer is wrong. John Horace. A. Contrary to popular belief, this age-old dilemma actually has a very straightforward solution. First, you must specify what kind of egg you mean. If you mean any kind of egg, then the egg came first, because chickens were preceded on the evolutionary timeline by, for example, egg-laying fish, insects and dinosaurs. If, on the other hand, you mean a chicken egg, then you must specify whether this means, A. An egg laid by a chicken, B. An egg containing a chicken, or, C. An egg laid by and containing a chicken. In cases A and C, the answer is by definition the chicken. If the answer were the egg, then the egg could not have been laid by a chicken. In case B, the usual and most interesting interpretation, the answer is the egg. This is because interspecies mutations separating a new species from its parent species occur in reproductive rather than somatic DNA, i.e. in germ cells rather than body cells. Germ cells include the sperm and egg cells produced in the reproductive tracts of male and female animals respectively. Since germ cells are merely produced, but not somatically expressed, by the parents of the organism, S, whose biological information they encode, their expression begins in the egg containing the offspring. So the egg contains a chicken, but was not laid by a chicken. See how easy that was. Q. My question is this: if you could answer the question, what is the mathematical difference between visible light and invisible light, i.e. ultraviolet rays, wouldn't this answer the question concerning the importance of further study into what is defined as physical? After all, how do you perceive ultraviolet rays, as a sunburn or plant growth? Therefore, although not visible, there indeed may be other energy forms that coexist right where we are, having an impact on us, without our knowing its source. It is not visibly physical, yet its effect on us is very physical. A. Visible and UV light differ in frequency, or number of waves transmitted or received per second. Because light always travels at the same speed, c = 300 km/sec, higher frequency means shorter waves. Lambda = c/frequency, where lambda = wavelength. I.e., more energetic, higher frequency light has a smaller wavelength than less energetic, lower frequency light. Unfortunately, the tiny light sensors in our retinas, called rods and cones, cannot detect short wavelength UV light. Your question seems to be this: how can we call UV light physical when we cannot directly detect it? The answer is twofold but simple. We can call it physical because of 1. Its perceptible physical effects on animals, plants, minerals, and detection devices, and 2. our need to acknowledge the full definitions and logical implications of our perceptions and concepts. Answer 2 is why reality is not merely physical in the concrete or material sense. In order to exist as a self-consistent perceptible entity, reality must ultimately make logical sense. Our perceptions of it must conform to a coherent cognitive syntax containing the rules of perception and cognition and incorporating logic. This syntax tells us that if light exists below the maximum visible frequency, then in the absence of any extra constraints, it can exist above it as well. Specifically, having identified the physical cause of light to be photon emission by subatomic oscillators called electrons, we are compelled to recognize the existence of light at whatever frequencies such oscillators may exhibit, right up through X and gamma radiation. The logical component of our cognitive syntax ultimately forces us to define and cross-relate all of the concepts in terms of which we apprehend reality, including light, in a logically consistent way. Q. Hello Chris. I saw you on TV and heard what you had to say about God. I have also read your description of the CTMU. I have had the same thoughts as to our existence in the mind of God. I think that the evidence of evolution that exists in the universe has to be linked with creation as a tool. I have only 11.75 years of school and not very high IQ, so please excuse the grammar, etc. Hi. You don't need to apologize for the 11.75 years of school. I don't have much more myself. Regarding evolution and creationism, the linkage is simple, since biblical accounts of the genesis of our world and species are true but metaphorical. Our task is to correctly decipher the metaphor in light of scientific evidence also given to us by God. Hence, the CTMU. Q. God said he would reveal his existence, reality, with numbers. Do you see yourself as part of this end-time promise? If God made such a promise, then one could say that the CTMU is at least a part of its fulfillment. This is because the number concept is actually far more general than most people think it is. At one time, a number was a positive integer. As the years passed, new kinds of number were discovered: zero, negative numbers, rational numbers or fractions, irrational numbers that cannot be expressed as fractions, complex numbers, and even transcendental and transfinite or infinite numbers. Noting that each kind of number is associated with an algebraic system like a number field, we finally realized that a number is any element of an algebraic system. Because the CTMU embodies an algebraic system called SCSPL, it too is numeric. And since this system is the basis of a proof of God's existence, the CTMU might be said to reveal the existence of God with numbers. Q. I have read your CTMU and some of the Q&A on the Ubiquity website regarding the CTMU and find it extremely fascinating. Much of the information resonated with many of the things I have been contemplating for the last year or so. I wanted to know if you had any further writings on the topic, especially related to the following areas. 1. The nature of the interaction, of the multiple levels of consciousness. 2. The nature of the connection with God via our souls. Or just in general, the nature of the soul. Is it a more complex syntax in which we are embedded that facilitates this communication with God? Are we all embedded in it? 3. The nature of morality. Do moral laws have a basis in reality, loosely speaking? That is, if moral laws are mental constructs, how do the mental constructs of higher levels of consciousness affect the lower levels? That is, how does what God thinks is right affect us, lower forms of consciousness? I realize that, to a degree, the above questions are really all the same, but if you have any essays or thoughts on these matters, I would love to hear them. I have more questions and thoughts, but I can save those for later. Yes, such writings exist, but they are, as yet, mostly unpublished. Don't worry, I'll get them out there somehow. As for your specific questions on morality, the following should suffice. In the CTMU, what God thinks is right is encapsulated by the teleological principle. This principle, a generalization of the cosmological anthropic principle, asserts that by logical necessity, there exists a deic analog of human volition called teleology. However, due to the fact that God's self-creative freedom is distributed over the universe, i.e., his mind, human volition arising within the universe is free to be locally out of sync with teleology. This requires a set of compensation mechanisms which ensure that teleology remains globally valid despite the localized failure of any individual or species to behave consistently with it. In part, these mechanisms determine the state of your relationship to God, i.e. your soul. If you are in harmony with teleology with the self-realization and self-expression of God, then your soul is in a state of grace. If you are not, then your soul is in danger of interdiction by teleological mechanisms built into the structure of the universe. Q. What does cognition have to do with physics or math? The laws of nature, physics, are not related with perception of those, I think. Animals use those laws better than human without having a single idea what gravity or electricity is. Math is abstract. The laws of nature are discovered, not invented. I study psychology, which from my point of view is not science for many reasons, maybe it will be someday. If theories are mental constructs, does that mean that gravity, not as a term, exists only as an abstract concept? A. Abstract laws are more general than the concrete, physical matter and field systems that obey them. If we divide reality into the concrete, and the abstract but non-concrete, math falls under the latter heading due to its generality. That is, concrete physical reality exemplifies mathematics, but mathematics is not confined to any particular physical model. Equivalently, the laws of physics are a mere subset of the laws of mathematics. So mathematics inhabits a higher, or alternatively, more basic, level of reality than the material world. Since the human mind can reason both inductively, from the specific to the general, and deductively, from the general to the specific, it spans both levels. Therefore, mathematics is mental as opposed to merely physical in nature. Because, as we have just noted, the laws of physics are a mere subset of the laws of mathematics, and because, as you write, the laws of nature are discovered, not invented, physical reality is ultimately mental in character as well. However, although this applies even to gravity, we are corporeally locked into a physical compartment of abstract mental reality within which we are not free to treat gravity as a mere concept. This helps explain why we can't fly by the power of thought alone. Q. In the book The Age of Spiritual Machines, Ray Kurzweil believes by 2029 humans will live among machines that convincingly claim they are self-aware. How does the CTMU deal with non-biologic consciousness? A. Kurzweil's prediction implies that within 3 decades from now, AI machines will be able to pass something called the Turing test, a hypothetical scenario devised by the mathematician and seminal computer scientist Alan Turing. To pass this test, a machine located behind a partition must convince a human interlocutor that it too is human, i.e. that it possesses human consciousness. Since the CTMU shows that a generalized form of self-awareness or consciousness distributes over every part of reality, any machine that exhibits self-awareness or explicitly claims to be conscious will to some extent be telling the truth. Indeed, if your toaster could make such a claim right now, it too would be telling the truth, although not in a fully human sense. On the other hand, it is not yet clear whether Kurzweil's AI-style machine consciousness, though ostensibly of a higher nature than that of your toaster, will be entirely human in character. CTMU and God. Q. Chris, what does your theory of reality, the cognitive theoretic model of the universe, CTMU, say about God? A. The CTMU says that God, as embodied by the universe, self-configures. To do this, he needs 2 things: 1. Active sensors, agents, internal proxies, who can recognize and affect the state of the universe from local internal vantages, 2. A stratified utility function allowing him and his agents to prefer one possible future over another. Human beings and other intelligent life forms are useful to God on both of these counts. Thus, the first criterion of his development is the possibility, and in fact the inevitability, of their existence. To understand this, consider an extraordinarily wise child responsible for the development and maintenance of its own body and physiology. Because the universe is in the process of self-configuration, we can liken it to a child. To meet this responsibility, the child requires internal sensors that provide information on exactly what is happening deep inside its growing body, preferably at the intracellular level, and that permit feedback. The child further requires that these sensors be able to register the utility of what they detect, whether it is good or bad from their own local perspectives. That way, the child can weigh the perceptions and utilities of all of its internal sensors to form overall developmental goals. In order to meet the self-configurative goals that it sets, as aggregates of the goals of its sensors, the child has the power to establish internal self-optimizative tendencies that affect the behavior of its internal agents, influencing them to perform such local operations and make such repairs as are necessary for the good of the whole child. To this end, they are equipped with global utility functions, consciences, that combine with intelligence to make them responsive to the welfare of the whole organism, as opposed to their own individual welfares. For want of a better name, we can use the term soul to describe the channel through which individual and global utility functions are put in consistent mutual contact. This channel permits the sensors to make more informed, more global, and more valid judgments about what is good and what is bad, and gives them the internal strength to do what is good, even if it means sacrificing individual utility, because global utility is an aggregate function of individual utility. Serving global utility ultimately makes individuals happier. I do not see why perception of the universe necessitates a link between the perceiver and the perceived. The very fact that one object perceives another seems to necessitate a disunion between them. Can you clarify? Joshua Freeman. Here's a little background on the logical structure of relations. Consider the relation x or y, meaning object x relates to object y, in such and such a way. R has two aspects, one predicating the sameness of x and y. X and y share the property of being relatable by the relation R, and one predicating difference. In other words, although x and y are different, at least typographically, R represents a structured set to which x and y both belong, and to that extent, x and y share the same description, are the same. Now let's narrow the context. Perception refers to a mapping between the mind of the perceiver, which is by definition internal to the perceiver, and some aspect of external reality. This perceptual mapping relates the structure of mind to that of reality in a way amounting to mutual containment, while the mind perceives itself as part of the content of reality. Reality is the content of perception. Because the perceptual mapping is a containment mapping, and a containment mapping predicates coincidence, perception predicates coincidence and is therefore a similarity mapping, homomorphism. So the perceptual similarity mapping Joshua R universe, where R denotes perception and mutual containment, is an assertion of similarity regarding Joshua and the universe. I hope this helps. In a vacuum, a train is traveling at the speed of light. The engineer turns on the front lantern. Does he see the light ahead of him? Is the light traveling twice the speed of light, or does the light not escape the lantern? First, let's change a train is traveling at the speed of light to the more correct a train is traveling at almost the speed of light. Due to something called the relativistic mass increase, nothing made of matter can be accelerated to the speed of light, it gets too massive and is subject to too much inertia. According to Einstein's special theory of relativity, the engineer sees the light beam from his lantern race away from him at the speed of light in the direction of motion of the train. But a relatively stationary observer standing by the tracks sees the light beam inching slowly out in front of a very short, very fast train, again at the speed of light, and the engineer appears to be frozen. This is because the mutual perceptions of observers in relative motion conform to a mathematical function called the Lorentz transformation, designed to make sure that the speed of light is absolutely the same for everybody. The Lorentz transformation can play weird tricks with space, time and common sense. I just found out that I only got 125 for my first professional IQ test and I'm very disappointed. Should I be? By the way, I'm 16 years old. First, 125 is a pretty high IQ score. Second, since anyone can have a bad day, that 125 is not necessarily written in stone. Third, Richard Feynman, a Nobelist sometimes ranked with Einstein as one of the two greatest physicists of the 20th century, had just about the same IQ score as you do. Yet, his name was, and is, considered synonymous with genius, and take my word for it, people are not merely being kind to him in saying that. The score didn't bother him at all. In effect, he congratulated himself for being so brilliant in spite of his low IQ. Most important of all, Feynman is not the only example of this. Many powerful thinkers have not scored especially well on IQ tests, which measure only a certain range of intellectual performance factors. My advice would be to hold off on self-judgment until you figure out what your real intellectual strengths are. The following was given to me on October 4, 1999, and to date I remain stumped. I sent it to Marilyn at Parade magazine but did not receive a reply. I'm beginning to think that it really does not have an answer. I am giving you the riddle in the exact manner in which I received it. In case there is a clue somewhere that appears to be only a typographical or grammatical error. Here it is. There are 3 words in the English language that end in GRE. One is angry and the other is hungry. Everyone knows what the third one means and what it stands for. Everyone uses them every day, and if you listened very carefully, I've given you the third word. What is it? Underscore 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 GRE? Please help. Congratulations for taking into account the possibility that the wording of the riddle might be critical to its solution. Here's the riddle in its original form. Note the differences, which suggest that it may have been passed on to you by someone who got it wrong or wanted to mess with your mind. Think of words ending in gry. Angry and hungry are 2 of them. There are only 3 words in the English language. What is the third word? The word is something that everyone uses every day. If you have listened carefully, I have already told you what it is. When we restore the riddle to its original wording, it becomes clear that the first 2 sentences are for distraction purposes only. The conditions of solution don't even begin until sentence number 3. If you haven't figured it out yet, the answer is language. That's the third word in the phrase the English language, and it's certainly something that everyone uses every day. In fact, we're using it right now. However, I once used maugre, an obsolete word meaning spite, in a college paper. It got red inked. A dialogic response to an atheist. RFV, the noun reality would seem to have a consensus definition as all that exists, and the adjective real as a distinguishing quality of a particular thus designated abstraction whose existence is deemed independent of the mind of the subject for whom the so defined object seems to be real. I won't bore you with Oxford English or Webster. My ontological preference would be to set such definitive statements as well as those such as, the universe is real, apart from the universe itself. These would not be members of a commensurable set, mind you, but merely examples of an infinitude of inane assertions whose truth, falsehood, or undecidability involves logic applied to other statements of the same class. There are many dumb assertions that do not even merit interment in real phrase cemeteries by real intellectuals, whether true or not. Others may be profound, but to my mind similarly are totally other than the universe itself. Homo sapiens seem particularly vulnerable to the vanity of ennobling the blather of their vocal cords and cortical folds with some special meaning, and in so doing confusing the obvious. How else can one account for Ms. Campbell presuming that Carl Sagan should have been convinced by her flaw of reasoning involving the existence of love being provable by anecdotes as somehow implying that, therefore, so must the existence of God? See for example, my article Does Love Exist? On pages 13 and 14 of Goff number 85. An anecdote may of course embody the actuality of a relationship between known objects, real or otherwise, any one of which could then prove that such relationships occur, even a misinterpretation of which might confirm the argued relation. Is it too subtle to just affirm here, however, that objects differ in certain salient respects from such relations? People other than perhaps Jesus, for whom antinomies were often claimed by the ecstatic Gnostic, are not love in the sense of being love. No portion of anyone is comprised of love, and yet of course, we do love. It's a verb for Christ's sake. Just so, the universe need not, nor ever can, be, nor yet contain, love nor any other relation mathematical or emotional in any real sense in order for the asserted relation to occur. Is this heavy? I don't think so. One must start somewhere, of course, with merely presumed consensus meaning such as what is meant by exist. However, for a credible theory of everything, if that is not in itself the most oxymoronic phrase that could ever be uttered. CML, what we seem to have here is a misunderstanding of the nature and expressive power of language. By the mathematical definition of a language, everything, not to mention theory of everything, is a language. That is, it is a string of characters that has a descriptive meaning, a semantic mapping into the universe of ideas and perceptions. Since a meaningful language can be construed as a theory, everything is a theory. Of what is everything a theory? Well, let's see here. Everything by definition refers to everything, including everything. Therefore, everything is a theory of everything. Granted, there are those who would say that a one-word theory is a poor theory indeed. But value judgments aside, where's the oxymoron? The fact is, human minds have the power to formulate one-word characterizations of the universe. Indeed, I just used a common one, universe. Since, broadly speaking, to characterize is to theorize about, humans have the power to form one-word theories of reality. The axioms and rules of inference of these micro-theories may not be explicit, but they are theories nonetheless. And that's a good thing, since it can easily be shown that without this ability, humans could not formulate their customary long and involved theories about reality. Since any complex theory can be characterized using a single word or phrase, for example cosmology or quantum mechanics, blocking this universal referential mechanism would effectively block theorization, and because theorization characterizes virtually all meaningful cognitive activity, human mentation in general. Of course, such a blockage may already be in effect over in Fred's neck of the theoretical woods. If so, I suggest that he break out the old chainsaw and clear the road before making any more of his own attempts at theorization, especially regarding theories of mine with which he disagrees. RFV, what constitutes the real, i.e., everything that is, would seem to require some sort of minimal definitions with justifications for non-traditional varieties before we encounter sound bites such as, because any real explanation of reality is contained in reality itself, reality gives rise to a paradox unless regarded as an include-user self-mapping. And again, thus, we can speak of time and space as equivalent to cognition and information with respect to the invariant semantic relation processes, as in time processes space and cognition processes information. But when we define reality as a process, we must reformulate containment accordingly. Say what? Time processes space. It is particularly important that definitions be as precise as possible when these seem to differ so considerably from what at least this reader would expect them to entail. CML, time is change of state, and change of state occurs according to laws of mathematics and physics. The laws of mathematics and physics govern changes of spatial configurations of matter and energy. Therefore, time incorporates laws according to which space is changed or processed. That is, the present state of reality is fed into a black box or transducer labeled laws of temporal transformation, which then returns the next state. The box, aka time, aka nomology, is a temporal processor. The structure of the box is the invariant structure of space-time. That is, space-time is the history of the temporal processing of one spatial cross-section of reality into the next according to the mathematical and physical laws comprising the transductive syntax of the box. Thus, time, described as a black box, processes space as input and output. Is this precise enough? RFV, Chris Langan seems quite enchanted by the strange teleological loop of conceiving a universe structured in accordance with consistent conceptions, where these conceptions are thereby deified in a real sense to the status of reality. CML, deified? Talk about loose semantics. Actually, Kant observed that objective phenomenal reality has a mental, i.e. conceptual, component a long time before I did. He was right in the sense that insofar as the mind is that which perceives and theorizes, and insofar as there can be no perception or theorization without the mind, the structure of the mind necessarily intersects with that of phenomenal reality. On the categorical level, this intersection is total, there is no phenomenal disjunction. That's because by definition, perceptual reality exists entirely within the intersect. Kant then went on to hedge his bets by postulating the existence of a really objective noumenal reality that exists independently of the mind. However, he did so completely on faith and in violation of logic. For the only reality we can ever know by perception or cognition is phenomenal, and anything independent of this phenomenal reality is by definition just that, independent of it, i.e. related to it by no causal mapping. In fact, as defined by Kant, pure objective reality is so utterly independent of phenomenal reality that it cannot be considered a part of the same reality at all. Our minds filter it out because its total logical disconnection from our perceptual universe severs any possible perceptual or relational mechanism that might connect it to us. Fortunately, dropping Kant's noumenon fallacy leaves the sounder parts of his philosophy, those relating to phenomena, more or less intact. One then has a platform from which to reason about deep reality in such a way that no matter how many layers of illusion lie between it and our awareness, we remain logically connected to it. RFV, there is definitely a worthy enchantment here. Who, for example, has not in reverie mused concerning the universe in its entirety being constrained by necessity to act in ways determined by the evident relations of its humblest components, and that the descriptions of these relations are somehow of extreme significance beyond the mere words and equations used to formulate them? However, in Chris's scheme the reality of the very words in such statements seems to be guaranteed, if they happen to be true statements, whereas similar, if ultimately non-confirmed statements would seem to be denied the same twinkling with stardust of the real word Hall of Fame. CML, but that's not quite what I've been saying, is it? What I've actually been saying is that our descriptions of the evident relations of the humblest components of the universe are guaranteed only on the syntactic level. That is, they do not qualify as perceptual input unless they conform to our mental structures, our cognitive and perceptual syntax, and this implies that all perceptual input conforms to the laws of mathematics and physics as they exist implicitly in our minds. That's what I mean when I equate mind and reality on the syntactic level. Particular theoretical languages can be wrong, but the basic syntactic descriptions of their perceptual contents are true in any case. Indeed, they comprise the basis of perceptual reality. Since the core of the CTMU embodies the tightest implications of the most general logic, it qualifies as cognitive and perceptual syntax. RFV, thus, true descriptions exist as a structure of the universe itself and are, therefore, available to be perceived in an inverse mapping whereby sentient constituents of the universe may become attuned to the whole enchilada in accordance with their intellectual abilities, this ultimately giving rise to human perception. Where in turn, the set of laws obeyed by the universe is just a minimal set of logical relations that suffices to make these perceptions non-contradictory. Of course we can counter such statements, whether willfully or not, but perhaps in so doing we thereby exile ourselves forever, past and future, from reality and the bliss of the presence of the only true and almighty God of King James, s. CML, perhaps, indeed. Actually, the theological definition hereto referred as the God of King James needs a little revision. But with that understanding, Fred's theological insight will do just nicely. RFV, there are many problems with this, of course. One of which is that in this scheme it would seem to be the intellectually challenged who are the ones endowed with special imaginations capable of envisioning truly original ideas outside the mind of God and that do not, therefore, correspond to, or even exist in, Chris's reality. They either do not exist at all or only seem to exist in the surrealistic idyllic limbo of we idiots who conceive them. CML, say what? Where did Fred come up with this? In fact, since our minds, and every thought they contain, do indeed exist in reality, this makes no sense. I think that Fred's confusion may devolve to the possibility of thinking not just original ideas, but fantastic ones as well. If so, I assure Fred that a functional brain scan would readily reveal that such thoughts are quite real within the brains of those who think them. What is irreal is the assumed veridical mapping of personalized fantasies onto general, perceptual, reality. Again, we have the distinction between particular theoretic languages, which may indeed be fantastic, and the basic syntactic relations of which they are composed. With respect to ordinary theories, the map is not the terrain. With respect to cognitive and perceptual syntax, it sure as hell is, right up to isomorphism. By the way, up to isomorphism is not an escape clause. Beyond the maximum scope and resolution at which the real universe can internally sustain a syntax content, mind reality, cognition information, time-space isomorphism, there is no more reality. The isomorphism is the entire basis of the coherence of the real universe. This should readily become apparent to anyone who tries, logically of course, to find an alternative basis. But something tells me that I've explained all this to Fred before. RFV, another problem is the basic one involving what constitutes a perception. My seeing a pixel of green via rods, cones, and neurons exterior to my brain certainly is a far cry from my having contemplated a description of a corresponding co-reality and further yet from a cognized statement of a law of physics. What is obvious about the usual definition of perception is that it exists as the most basic element of reality we know, and yet here its very existence seems to hang in the balance of compatibility with some all-inclusive abstraction. The whole perception of the reality of perceptions seems to have been hijacked by some contortion of thinking to depend upon a level of reality where poodles and noodles argue differences and similarities rather than just being. See Nicholas Buxka's article, Meta-Questions and Mega-Fallacies in issue number 88 pages 25, 26, where he says, "In nature there is a poodle and a noodle, but there is no such thing as a difference between them. The difference is the mental result of an arbitrary mental process performed on abstract objects, our mental images created from our sensory data of real objects." CML, with all due respect to Nicholas, I'd have to maintain that in nature, there both is and is not a difference between a poodle and a noodle. That there is a difference is evident from the fact that nature gives one the power to bark and chew bones, but not the other. That there is not a difference is evident, for example, from the fact that both have mass and are therefore composed of energy. But this paradox is resolved by recognizing that reality is stratified. Things are the same with respect to shared generalities, all matter consists of energy, while they differ with respect to distinctive specifics. Women perm their hair not to put noodles on their poodles, but to put poodles on their noodles. In order for perceptual reality to exist, this mental stratification must be built into the structure of space-time. If it were not, then space-time and its contents would be totally imperceptible and therefore unreal. RFV, notwithstanding, Chris maintains that, thus, every axiom and theorem of mathematics can be considered implicit in material syntax and potentially exemplified by an appropriate material pattern, for example firing of cerebral neurons. And again, so the background has logical ascendancy over derivative matter, and this permits it to have aspects, like the power to enforce consistency, not expressible by localized interactions of compact material objects, i.e., within the bounds of materialism. This Platonic structure of reality, he clarifies by saying, physical reality is embedded in a more general or abstract ideal reality equating to the reality syntax D, S, and the syntax D, S, is in turn embedded in physical reality. Thus, if D, S, contains supraphysical components, they are embedded in S right along with their physical counterparts. Indeed, this convention is already in restricted use in string theory and M theory, where unseen higher dimensions get rolled up to sub-Planck diameter, whatever that means. CML, the CTMU property to which Fred is referring here is called Hology. That's a logical form of self-similarity in which the structure of an infocognitive system is distributed over the system as self-transductive syntax. An infocognitive system is a system whose components all simultaneously possess the nature of information and cognition. For example, you, the reader, are internally a cognitive entity, but others perceive you as an informational construct related to your external environment. In a generalized sense, the same applies to inanimate objects. They simultaneously possess intrinsic, subjective, and extrinsic, objective, descriptions that are respectively temporal and spatial in character. That is, the purely intrinsic description of an object, being utterly confined to the object, is a self-description and thus a recursive, temporal, sequential process, while an extrinsic description specifies the position or meaning of an object relative to other objects and thus has a spatial, relative, parallelized aspect. As for rolled-up dimensions, that's a convention that goes back to Kaluza-Klein theory, in which light is characterized as a fifth-dimensional vibration. Supposedly, this fifth dimension is imperceptible because it gets rolled up into a tiny little knot of sub-Planck diameter. String theory and M theory have many more of these knotty little dimensions, the revealing of which turns out to present some knotty topological problems. But here, I'm just pointing out a convention of M theory not necessarily shared by the CTMU. RFV, so clothed in the priestly garb of words, we are now ready to address God. I will reiterate the question with Chris: what does this say about God? With regard to Chris's answer, I find that reiteration does not suffice for me. Where he says, so by design, religious beliefs generally cannot be refuted by rational or empirical means, I think he may be intentionally playing on words. Certainly one could never refute that there is belief in God as long as anyone still believes in God. That is an irrefutable fact, like the occurrence of love and other relations between humans and other objects, whether real or not. However, that key tenets of most religious beliefs generally cannot be refuted by rational or empirical means is an assertion that should probably be denied subjective honors of existence in his scheme if he is to remain consistent. It is, in simple fact, absurd. CML, I think that Fred may be overlooking the important fact that while the existence of God is merely a belief to the adherents of traditional organized religions, it is more than a belief in the CTMU. It is an unavoidable syntactic relation. Simply using the term belief with regard to religious ideas does not imply that this is all they are, or that this is their only means of justification. May I respectfully suggest that in the future, Fred acknowledge the discursive context instead of mangling it beyond all recognition? RFV, going further, he asks and answers the question, can a denial of God be refuted by rational or empirical means? The short answer is yes. He proceeds by claiming that by his having merely associated the term God with the abstract level of true statements in his CTMU that he conceives as structuring the universe, that structure constitutes not just a logical framework for reality theory, but the outline of a logical proof of God's existence and the basis of a new logical theology. To my mind, God was no more marginalized by Gnostic abstraction in the Synoptic Gospel than by Chris Langan in his article, Introduction to CTMU, that summarizes for neophytes his Cognitive Theoretic Model of the Universe, CTMU. Nor has God's existence ever been conditioned on more theoretically questionable foundations. CML, Fred is, of course, entitled to his opinion, ill-supported as it may be. But even if he's unable to see that the CTMU is a proof of God's existence, he must admit that either it is a new approach to same, or he doesn't even come close to understanding it. If he prefers, we can leave the success of this approach to the tests of time and logic. Discussion with CTMU conference members. Mark Geddes, what does CTMU have to say about the purpose of the universe, if there is one? I understand that CTMU postulates an extension of the anthropic principle. Could you please give a brief summary of this concept of unbound telesis? Chris Langan, the purpose of the universe is optimal self-actualization. This is called teleology. Accordingly, the teleological CTMU version of the anthropic principle is called the telic principle. In logic, attribution of a predicate to an object or relation is called quantification. Quantifiers bind variables. Thus, when one regressively strips away the attributes of something in order to understand its essence, one unbinds it from its quantifiers. Suppose that in semantic consistency with the concept of teleology, we describe reality as telesis. Then the limit of the process of unbinding reality from its quantifiers in order to understand its essence is unbound telesis or UBT. Mg, is it really true that there is no distinction between knowledge and truth? Cl, knowledge is a noun, while truth can be either a noun or an attribute. However, considered as nouns, they are identical up to isomorphism. The latter phrase, up to isomorphism, leaves open the question of whether one is greater than the other. Insofar as some truths are unknowable to the human mind, truth is greater than human knowledge. But when we talk about the universe's knowledge of itself, they are synonymous. In order to ascribe knowledge to the universe, we need an appropriate generalization of cognition. That's why the CTMU incorporates such a generalization. Mg, for instance, even if absolute truth exists, why does this have to imply that this absolute truth is knowable to human beings? Cl, it doesn't. Mg, even if CTMU is right and tautologies can yield useful information, we run into the problem of Gödel's theorem and the limitations of formal systems again, i.e. how can we ever be absolutely certain that there are no mistakes in our reasoning? Cl, first, if tautologies do not yield useful information, then logic does not yield useful information. If you believe this, then the first thing you should do is throw out your useless personal computer, which was designed according to the tautological principles of Boolean logic. And that's only the beginning. Second, we can be absolutely certain that there are no mistakes in our reasoning by using logic itself as the universal template for knowledge and reasoning. That's why the CTMU is designed as a supertautological extension of logic, and why it is formed by the straightforward adjunction to logic of certain metalogical necessities of cognition and perception. Mg, does CTMU really rigorously show that reality is entirely self-creating and self-describing, or is the use of the tautology simply faulty? For instance, if reality is X, why in plain English, can we really be sure that X has any explanation at all? Cl, because in this usage, explanation is identical to structure. In order to fully specify the structure of a system, one must explain why its aspects and components are related in certain ways, as opposed to other possible ways. If one cannot explain this, then one is unable to determine the truth values of certain higher-order relations without which structure cannot be fully specified. On the other hand, if one claims that some of these higher-order structural components are absolutely inexplicable, then one is saying that they do not exist, and thus that the systemic structure is absolutely incomplete. Since this would destroy the system's identity, its stability, and its ability to function, it is belied by the system's very existence. Mg, CTMU tries to argue that we should say X exists because X exists, but this seems uncomfortably like a semantic trick. I am still not wholly convinced that a tautology can yield useful information and that reality has an explanation. Cl, see above comments. Incidentally, the sentence X exists because X exists is simply an expression of self-containment with respect to causality, and therefore necessary in any self-contained theory. Obviously, a comprehensive theory of reality must be self-contained by definition. Indeed, so must reality itself. Mg, why is there a large school of top-class logicians who still totally deny that a tautology can yield useful information? Cl, let me guess. Because they are hiding in ivory towers in a weak and cowardly attempt to protect themselves and their absurd worldviews from anyone who might know better? Mg. The oldest debate in philosophy. To what extent do things have an existence which is Platonic? Platonic equal timeless, universal, objective. Cl. Well, which is it? Is Platonic equal timeless, universal, or objective? Say that Platonic equal timeless. Then the answer to this question is entirely dependent on one's model of time. With respect to the advanced model of space-time incorporated by the CTMU, the universe is ultimately timeless and therefore Platonic. Say that Platonic equal universal. With respect to itself, the real universe is indeed universal. So again, the universe is Platonic. Finally, say that Platonic equal objective. The latter term refers to an item of shared perception located outside the self, i.e. outside the subjective selves of the perceivers. Because the universe is ultimately its own perceiver, and because it is self-contained, the answer is now no, the universe is not Platonic. It is subjective, or better yet, metasubjective. Mg. For instance, should we consider the entities referred to by scientific theories as simply calculational devices or as real things existing out there? Cl. Algebraically, theories are languages. Languages have syntax. At the syntactic limit, theory equal universe, the syntax controls the process of cognitive theorization as well as the process of perception through which the universe is apprehended. Where theory equal universe, the or in your question is not exclusive. Mg. What about mathematical concepts? Are mathematical concepts things which exist independently of the human mind or not? Cl. Mathematics is the basis of our cognitive and perceptual syntax. So again, the or is not exclusive. Mg. What about moral principles? Should we take a utilitarian view that moral principles are simply human inventions useful for specific social purposes, or is there more to them than that? Cl. The global limit of purpose is teleology, the purpose of the universe as a whole. Since morality is a function of purpose and the justification of purpose, the limit of morality is the teleological morality of the universe as a whole. Obviously, where morality is defined with respect to teleology, it is as absolute as teleology itself. Mg. If moral principles have some sort of real existence, how could we use our reason to discover what they are? Cl. It's really very simple. Start with the utility of the universe, as embodied in teleology. Then parse this utility according to the structure of the universe. Mg. Needs clarifying. CTMU appears to show that the universe is a self-perceptual system and thus there exists a supreme mind. But what specific properties does this mind have? Cl. Omniscience, omnipresence, and even an attribute resembling omnipotence, but only as interpreted within the CTMU, as opposed to the nonsensical way these terms are defined and interpreted by mainstream theologians and their critics. Mg. The existence of a universal mind does not necessarily imply the God concept as understood by conventional religion. In conventional religion, God is a supernatural, omnipotent being. In CTMU, God appears to be neither supernatural nor omnipotent. Cl. In the CTMU, God is quite natural. But where this term is confused with material or merely physical, God has a supernatural aspect as well. In other words, where reality is like a mind, God is the answer to the question whose mind, and this answer is more than merely physical in content. Mg. A brief description of SCSPL please. Cl. An SCSPL is a completely self-contained language. It writes itself, reads itself, interprets itself, and executes itself in the computational sense. Mg. The whole idea of extending set theory to resolve the paradox of the set of all sets needs clarifying. Cl. Already done. Mg. Is SCSPL really a formal system at all, or is it something over and above this? Cl. You can think of it as the extensional limit of a formal system. Bear in mind that the underlying logic of most of the formal systems dealt with in math and science is just first or second order predicate logic. There are no attributes of attributes of attributes. If you want to scale the Everest of metaphysics, you have to deal, at least in principle, with all orders of underlying logic. Since all may in this case refer to an infinite stratification, this requirement amounts to metalogic. Mg. V. Intriguing Chris's earlier discussion in the archives, where he talked about the universe unfolding being analogous to a formal system SCSPL which is in the process of appending Gödel assertions to itself to continuously expand itself. And the possibility of God being able to ensure completeness and closure in one fell swoop. These things are definitely outside the scope of any ordinary formal system. As first defined by Church Turing. CL, yes. But the formal system required by metaphysical reasoning is far deeper and more powerful than those currently required by mainstream math and science, where only object-level descriptions are necessary. Where, as in metaphysics, a formal system is required to incorporate descriptions of itself, provisions must be made for all orders of relationship. This requires metalogical rules like those of the CTMU. Conveniently for the theorist, metalogic is implicit in logic. Mg. I'd like a quick summary of the model of spacetime that CTMU leads to. And also a summary of why you think that CTMU implies a non-zero cosmological constant leading to an accelerating universe. Can CTMU tell us how the universe will end? How it begun? Why is there an arrow of time? CL. Because of the condition that reality must evolve in a way parallel to the logical evolution of the theory that describes it, that is, by logical substitution, the CTMU depicts reality in terms of a logical nesting of states. The operative model, USRE, universe as a self-representational entity, is the conspansive dual of the ERSU, expanding rubber sheet universe, model of standard cosmology. In ERSU, local space and time scales remain constant while the universe expands. In USRE, local space and time scales shrink while the universe remains constant in extent, and do so in a way that can look from a local, internal vantage like accelerating cosmic expansion. By the way in which it internalizes space and time scales, USRE supports certain distinctions between the forward and reverse directions of time that ERSU does not support. These explain the arrow of time. But by the same token, USRE says that the universe will not end until its self-actualization is complete, and that if and when this occurs, it will occur, from a global perspective, at the precise instant that the universe began to evolve in the first place. More precisely, concepts like the beginning and end of the universe are meaningful only when interpreted within the universe itself, which is actually timeless from a global perspective. For more details, please consult some of the material at the Mega Foundation site, for example, the long article I submitted to the last issue of Noesis E. Regarding Larin's link to some of the work of Vladimir Trifunov, Trifunov seems to be working strictly within the standard ERSU model of cosmology. So his assertions must be distinguished from those of the CTMU, which are made with respect to USRE. Mg. I'd like a quick summary of how CTMU deals with the paradoxes of quantum physics. What picture of reality does CTMU present of the quantum world? As compared, for example, to interpretations such as the many worlds interpretation, what about the apparent contradiction with relativity caused by non-locality? What picture of reality would CTMU present to try to resolve these contradictions? CL. The CTMU is the only logically consistent interpretation of quantum mechanics. To begin to see why, please read the article Supernovae and the CTMU in the May-June issue of Noesis E. Ingvar. I think it is almost impossible to show anything metaphysical at all about the world as we know it using logic or math alone. CML. In fact, Ingvar, logic and math are the only ways to establish universal truths. There are two reasons for this. 1. Empirical knowledge is always local and never global. Concisely, the universe is spatially and temporally too big to observe in its entirety, and it breaks down into pieces too small to see clearly. Due to the problem of induction, the fact that we cannot reason infallibly from the part to the whole in the empirical realm, observation and experimentation can never take us to the global limit. 2. To know anything, we must know it with our minds. But our minds obey a cognitive syntax composed of the invariant logical and mathematical rules governing cognition and perception. What is the ultimate generalization of these rules? Cognition and perception as a whole, i.e. cognitive and perceptual reality. Since we know reality solely through cognition and perception, this amounts to reality per southeast. It follows that we can use these logical and mathematical rules to generalize from the mind to the universe, and thus to solve the problem of induction. Ingvar, for example, there are troubles with the paradox the Cantor's set and the set theory Chris uses. CML, I don't use set theory, Ingvar. As Russell has pointed out in this thread, I use an extension of set theory called SCSPL, with respect to which the concept of inclusion or containment is a duality. Containment is a dual aspect affair that amounts to a duality relationship between descriptive and topological aspects. The universe, or set of all sets, topologically contains the syntax that descriptively contains the universe, or set of all sets, and its power set. The set of all sets paradox is thereby resolved, allowing us to achieve a self-contained formulation of the structure of reality. Ingvar, the paradox does not show up if you use a set theory that differentiates between different types of set hierarchies, see Bertie Russell's theory of types. On the other hand, if you use a theory that allows a paradox to exist, the theory will be useless, since it will be possible to imply any proposition within it. So either way, it doesn't seem to work the way Chris wanted to. CML, to prevent the paradox from showing up, it is sufficient to extend set theory with the inclusive duality concept just described. When you do this, you end up with SCSPL. Ingvar, still, I think the CTMU, the little I know about it, is an interesting theory. Yes, Russell, I agree, it looks very promising, to be able to say that much with the CTMU using no empirical data at all. But, as I said before, it is too promising. That is, you can show too much with it. CML, no, you can't. It is true that at the current stage of development of the CTMU, you can't use it to demonstrate every empirical truth. But neither can you formulate an irresolvable paradox within it. In fact, it contains a metalogical axiom called mu which states, in effect, that SCSPL can always be intentionally extended to prevent the existence of such a paradox. This is self-evident insofar as reality would be inconsistent if it were not true, whereas our ability to perceive reality shows that it is in fact consistent. Ingvar, if the paradox leads to a contradiction, and it is allowed in the theory, then the whole CTMU, and everything you implies from it is useless. I don't think there is a way of refuting the refutation that I came up with, but I welcome any tries. CML, see above. The theory of sets is extended by adjoining the concept of dual aspect containment, which is formally effected by the adjunction of certain metalogical axioms supporting this concept. Ingvar, for examples of different ways of dealing with truth, logic, and paradoxes, see Stephen Reed's Thinking About Logic. It's an excellent book, for beginners as well as experts. CML, thanks for the tip, Ingvar. I'm sure some of us would enjoy reading such a book. Cliff Wigdal, I would like to see, at some point, a discussion of whether a toe or gut could directly assimilate of a psyche/matter continuum, as ventured by Jung et al., that might explain occultic magic, synchronicities, UFOs, poltergeist/telekinetic phenomena, bilocation, etc. CL, since those who believe in these phenomena claim that they possess, at least, metaphysical reality, metaphysics is the natural realm of discourse in which to analyze them. The CTMU is an optimum theory of metaphysics, because it is based on cognitive and perceptual syntax, beyond which nothing can be known or perceived. So as we might expect, the CTMU supports possible definitions and realizations of at least some of these terms. To put it as simply as possible, the CTMU shows that the universe is a mind. Like any other mind, this mind has certain powers of association and analogy. The means by which these functions are implemented include something called, suggestively enough, the especially, short for extended superposition principle. This refers to a global analog of quantum mechanical state superposition, but acting over the global wave function with respect to space and time. The especially relates to the teleological collapse of the global wave function as the SP relates to quantum wave function collapse in material entities. CW, as far as I know, I have yet to see anything tangible that explains these paranormal events, with the exception of Bell's theorem, although clearly, it just scratches the surface. CL, you know, there used to be a problem with Bell's theorem, it was impossible to interpret in the standard model of space-time. But with the advent of the CTMU, this problem no longer exists. So if you really value a logical and scientific approach to these issues, the CTMU will become your model of necessity. CW, nice to see the exchanges developing. CL, I very much agree, Cliff. Discussion on the Ultranet list. Russell, my question is not about whether the universe is consponding or expanding, but how can nothing be outside the universe? Because if nothing is defined as zero, then how can zero contain or be outside something? Zero is a mathematical point, zero-dimensional space. Chris, the symbol for nothingness is zero, and zero is a term that requires interpretation. For example, in the context of the integers, zero represents a center or cancellation point between the positive and the negative, while in the context of the non-negative integers, it simply reflects absence. Moreover, zero can apply to information, or to that which information determines. Now, zero information corresponds at once to homogeneity and therefore to unity, and to unbounded potential and thus to infinity. So depending on how we interpret zero, nothingness can mean absence, cancellation, unity, or infinity. This tells us that what is important is not the symbol zero, but its interpretation, and thus the entire cognitive matrix on which the interpretation is based. And within this matrix, nothingness is a complex interplay of, you guessed it, absence, cancellation, unity and infinity. It has structure. Within the cognitive matrix of our minds, the structure of the ultimate ground state of existence called nothingness is UBT, and this is no mere empty set. Russell, the universe must be infinite in some way as to be all there is. Unreality could be hidden within reality? Chris, no, unreality is ultimately contained in UBT, which for present purposes we might as well call pre-reality. But every time a quantum wave function collapses, a new piece of unreality is defined, as the complement of that which is actualized by the collapse. In other words, just as reality is stratified, so is unreality. One level of unreality is unbound, other levels are bound by this or some other reality. Russell, if unreality and reality are distinctly separated, then what contains them both? Chris, UBT, and at derivative levels, the stratified constraints in terms of which reality defines itself. Russell, reality must contain unreality. Reality is infinite. Chris, of course, if by reality you mean UBT. But this reality that we inhabit, characterized as it is by specific laws and material configurations, is self-contained on a secondary level of existence and therefore less infinite. Fortunately, it is still capable of containing as much unreality as it needs to in order to define its own configuration. The logical vessel of containment is the cosmic wave function, which collapses to a single actualization and leaves the rest of its potential unrealized and therefore unreal. Russell, this seems to be an absurd circular question, but at the submicroscopic scale, nature is absurd. Chris, not exactly. What's absurd are the standard interpretations of nature on the submicroscopic scale. Russell, if nothing is undefined, then outside the universe is undefined. That is still an asymptote approaching infinity? Chris, cosmologically, outside the universe simply means unbound by the characteristic constraints of the universe. The exclusion is logical rather than topological. Remember, while the size of the universe is externally undefined, due to the absence of a real external metric in which to define it, its size and laws are internally, intrinsically, definite. Ian, Gina sent me your comments below on zero. The answer to Russell's question might be that if the sum of components within the spacetime manifold, STM, equals zero, and the STM is surrounded by zero, it is simply surrounded by itself, and thus is not surrounded by anything mathematically different. Self surrounding self simply equals self. It's perfect. Chris, hi, Ian. To some extent, I'm in agreement with your reasoning, as I told Johnny Asia and others here quite a while back, I find your own reality theoretic ideas surprisingly harmonious with my own. Specifically, if we assume that cosmogony begins with something called UBT, unbound telesis, in CTMU lingo, the cosmos must inherit the nature of UBT, must, as you put it, be surrounded by itself in the logical sense. Setting 0 equal to UBT gets us around a problem. Cancellation is not an operation that can be taken for granted. Let me explain. If you really start out with nothing, then there is no pre-existing information. You must first tell cancellation how to occur, and tell 0 how to fission into two or more mutually cancelling entities. Since these instructions on how things should cancel consist of constraint, of restrictions that limit the nature of nothing, constraint has logical priority over cancellation. So we have to explain how the constraint got there in the first place, and we have to do it without appealing to any pre-existing cancellation operation supposedly inherent in nothing. By default, the entities comprising the system that you call the sum of components within the space-time manifold must themselves combine to form the constraint, and since neither the constraint nor its constituents equal nothing, we're forced to introduce something at the very outset. This tells us that we're not really starting out with nothing, but with unbound potential or UBT, something which, by its nature, contains everything that can possibly exist. This amounts to interpreting 0 as 0 information and replacing it with a combination of unity and infinity. I.e., by interpreting 0 as the absence of something called information, which implies that it equates to superficially unrestricted homogeneous, and therefore unitary, informational potential, which in turn equates to existential infinity, we're making it possible for 0 to represent the sort of cancellation point you envision. Since this implies that existence is a self-defined attribute, after all, there is no pre-existing informational framework capable of defining it, only possibilities with the intrinsic ability to define and sustain their own existences can be actualized. This is what it takes to get something from nothing. The moral of this story is that numbers, even 0, are concepts which cannot be symbolically isolated within our cognitive matrix. Every time we use them, we implicitly attach the entire load of conceptual baggage in their extended mathematical definitions, and every time we apply them, we're selecting an interpretation consistent therewith. So in using them to, for example, do cosmology, we must attend to every aspect of their meanings. Otherwise, they'll almost certainly prove inadequate to do the explanatory jobs for which we intend them. Hey, they don't call it the cognitive theoretic model of the universe for nothing. Ian, that's what's so beautiful about a zero-sum universe, it can appear and disappear without violating a nothing, no space-time, from which it arose, and in effect is another face of no space-time. A contradiction cannot be shown by raising a no space-time as Russell's question purports to do. I see a direct relation between consciousness and 0, although I've not tried to map that out. In my last post I cite an important major study of the universe that finds that net universal energy equals 0. I intuitively deduced this out before these findings and before I found out that it was known that if the universe is closed then net energy equals 0. These findings say to me 0 is definitely on the right track. Chris, I agree. It's just that we have to be careful how we interpret 0. Ian, Chris, your observations on the many ways of seeing 0 is great. I wonder if any other number has such a wide range of interpretations. Still absorbing the CTMU. The non-stop rigor of your work, Chris, is an inspiration for me to expand my own field of knowledge. Thanks, guys. Chris, you're very welcome, Ian. We feel the same way about you. And thank you from all of us for sharing your fine investigative work with us in Ubiquity and Noesis. It's some of the best I've ever read, and has an unmistakable ring of truth. Best regards. Chris. Discussion with a Mega Society Easy member. Guy, I don't know if any of the following has anything to do with the concept of Cons-pansion or not, but these thoughts grew out of the recent set of emails regarding Cons-pansion, T-duality, etc. Question: does the universe have some kind of absolute scale, for example, a fundamental length scale? Initial answer: of course. There's the Planck length, the Hubble constant, and many, many others. For example, if I am 1.7 meters tall, this size is absolutely determined by its relation to the fundamental scales at the microscopic level and the cosmological level. These fundamental scales are provided by the universe itself. Chris, good point. These constants, along with their dimensions, define invariant relationships among the contents of the universe. But while the overall size of the universe is externally undefined and can only be defined intrinsically, as curvature, the sizes of objects change with respect to this curvature. Because our experiments indicate that nothing is changing locally, we impute this to global rather than local change. The cosmos is expanding, relative to our local experimental framework. Mathematically, we represent this in terms of a geometric model called ERSU, short for expanding rubber sheet universe, in which points retain their positions with respect to a co-moving coordinate system painted on the 2D surface of an inflating balloon. The lost dimension is considered expendable for modeling purposes. But the cosmos can't be expanding in any absolute sense, because there's nothing for it to be expanding into. Therefore, we must invert the model in a way that conserves space-time. The total amount of space-time must remain constant. When we do so, the cosmos ceases to resemble a balloon inflating, extending outward, over time, and instead becomes an inward superposition of sequentially related states. The best way to think of it is in terms of a cumulative embedment of Venn diagrams, of state, on the inside surface of a sphere of extrinsically indeterminate size. As matter shrinks relative to the sphere, time speeds up. In Eddington's words, smaller and smaller, faster and faster. Eddington's phrase for his primitive glimpse of Cons-pansion was the theory of the shrinking atom. As it turns out, the model implies temporal superposition, requiring an ex post facto parallelization of consequent events with respect to antecedent events. The CTMU calls this the especially, for extended superposition principle, and adjoins it to quantum mechanics as an extension of the superposition principle. It permits temporal closure, something conspicuously lacking in the standard model. From a later email by Guy. Chris, nothing that leads to logical inconsistency is confirmed by evidence. Expansion leads to logical inconsistency analytically. To wit, if there were something outside reality that were sufficiently real to contain the expansion of reality, it would be contained in reality. That's a contradiction, ergo, the hypothesis is false. Guy, Chris, I am confused by this statement. Expansion can be defined consistently without reference to some external space in which to expand. For example, the two-sphere is defined by its constant curvature and its total surface area. Mathematically, it's easy to increase its surface area. There's no contradiction. Chris, the contradiction results from the concept of local invariance, the idea that because we can't detect any change in the local metric by experimental means, it must be invariant in some absolute sense. The contradiction is tacit, but it exists nonetheless. The contradiction also surfaces with respect to our concept of motion. In the expansive model, photons and planets alike move by rotation and translation through a background called space, which, while possessing sophisticated properties like Lorentz invariance, is still considered an independent medium containing particles and fields. In the conspansive model, on the other hand, motion is an endomorphism defined with respect to those nested Venn diagrams we mentioned, with outer circles playing the part of quantum wave functions with respect to inner ones, and inner ones playing the role of moving particles with respect to outer ones. Because the circles in the Venn diagrams are just light cone cross-sections corresponding to wave functions because of the conspansive identification of light cones with wave functions and worldliness with particle trajectories, the CTMU defines a general relationship between relativity and quantum mechanics. We end up with two kinds of motion, a primary inner expansive kind representing the growth of Venn diagrams and the interpenetration of their spherical wave functions, and a secondary requantitative kind representing the relative shifting of diagrams as particles and galaxies undergo incidental spatial rotation and translation. But this implies a logical distinction. Simplistically, the first kind of motion characterizes a simulative phase of matter, and the second kind characterizes a simulated phase. Time, calibrated in terms of primary motion, is a process of dualization between these logically distinct levels. The universe becomes a self-simulation, a self-representational entity. Guy, you make a similar statement in the MNF article. The idea that you have a singularity that explodes and expands, what does it expand into? Think about that for a minute. If there was something there for that universe to expand into, now you're obligated to explain what that something is. p. 269. The metric properties of a manifold are describable intrinsically, without reference to any larger space the manifold is embedded in. And this description is completely consistent. This is what Gauss realized in his amazing Theorema egregium. I was quite surprised by this the first time I worked through the proof. It's amazing that something like curvature can be defined without any reference to what a manifold is curving into. Similarly, expansion can be defined in a consistent manner without the need for anything to expand into. A space in which to embed the manifold is not necessary. I'm sure you must know this stuff, Chris. What am I missing? This is a sincere request. I really don't see the contradiction or paradox here. Chris, as I think I've explained above, you're missing, 1. The fact that ignoring extrinsic considerations by resorting to intrinsic definitions does not really dispose of them, and, 2. Some of the implications of inverting ERSU to USRE, of dualizing the expanding rubber sheet universe to its conspansive dual model, the universe as a self-representational entity. In the general relativistic version of ERSU, time is just another linear dimension in which the curvature of the universe progressively changes. In USRE, on the other hand, time is the wave-particle dualization of space to matter, to space, and so on, with cumulative parallelization of time. Again, the ramifications are significant. We have two sets of invariants, one associated with the covariance of distributed physical laws, including all those dimensional constants relating matter, and one associated with the intrinsic invariance of the whole, including the conservation of space and the cumulative present in which the universe evolves. For practical purposes, the standard model ignores the second set entirely. In order to maintain both sets of invariants, we need to change our understanding of the relationship of space, time, and object. Space-time becomes an SCSPL evolving endomorphically, by internal self-mapping, rather than by the motion of matter through an independent medium. Though nothing fancy, this paradigm shift turns out to be philosophically profound. I've already written papers on Cons-pansion. They were originally published in Noesis. From another email by Guy. Guy, in a previous post I demonstrated operationally how to take a passive, changing only the description of a physical system, change of units and produce an active, changing the physical system itself, physical rescaling of the universe, and demonstrated that this rescaled universe is isomorphic to the universe you began with. From inside, you can't tell whether you're in universe A or universe B. Most scientists would say that, since the difference is not measurable, the concept has no meaning or is merely metaphysical. I disagree. This result is interesting. I think it's clear that universe A and universe B are different, though isomorphic. One way to see this would be to take a meter stick from universe B and put it in universe A, where it would be 100 times as long. But the concept of moving objects between universes lacks coherence. A better way to see that these two universes really are different is to note that you can go from universe A to universe B in independent steps: 1. Rescale space, 2. Rescale mass, 3. Rescale charge, and 4. Rescale the laws of physics, which are just relationships between the primitives of space, time, mass, charge, and maybe a few others. Each of these independent steps, if conducted without the others, would yield observable results. It's hard for me to believe, even if the final step results in a universe isomorphic to where you started, that universe B is identical to universe A. I find this result fascinating. Does that mean I've gone off the deep end? Chris, or maybe it's just CTMU time for Guy Fogelman. Universe A and B would appear to be the same in some respects and different in others. But this can be asserted only with respect to a basis of comparison, in this case arithmetic and geometry, which are brought to bear as parts of the cognitive syntax of one Guy Fogelman in the throes of a Gödel experiment. But the conclusions drawn from this syntax are valid only if it characterizes not just the thought processes of Guy Fogelman, but a joint medium containing both universes, i.e., only if arithmetic and geometry are distributed over an objective medium containing the compared entities. What infrastructure does this imply? First, it requires a connection between the cognitive syntax of Guy Fogelman and the objective medium containing both universes, an identity of Guy's mind and objective reality. More generally, it requires a conspansive CTMU infrastructure with logical priority over the Gödel experiment itself. At 2:40 p.m. March 30, 2001, Langen wrote, Chris, but the cosmos can't be expanding in any absolute sense, because there's nothing for it to be expanding into. Guy, again, I still don't see this. Chris, there are two ways to describe things, extrinsically, according to a syntax or scale of measurement external to that which is being described, or intrinsically, using only the described entity itself. An intrinsic explanation is to this extent self-referential. Because reality is self-contained, we ultimately require a global intrinsic explanation of it. If, in moving towards this goal, we happen to find a more or less self-contained sub-theory within the comprehensive theory we seek, as did Riemann with respect to geometry, and Einstein with respect to classical physics, we then have a partial intrinsic explanation. However, that doesn't mean we've finished the job. The intrinsic explanation achieved by general relativity is in poor accord with certain aspects of an even more important physical theory, quantum mechanics, and therefore cannot be taken to imply that a global intrinsic explanation has been achieved. If it could, we'd already have a unified field theory and more. You say that you see no contradiction in the idea of an expanding universe. Apparently, you feel this way because differential geometry can be used to replace the concept of externally measured extent with that of intrinsic curvature. But does this mean that the need for an external medium has been obviated? Hardly, unless, for example, the universe thereby provides the wherewithal for its own existence, the stuff of which it is made. If you respond that the universe is made of energy, then you have to say where that came from. Suppose you say, the positive energy is cancelled by negative energy as part of a true zero-sum system. Unfortunately, that doesn't sound like the zero most of us are familiar with. Why not? Because you still have all that messy structure to account for, the informational framework within which cancellation is achieved. Intrinsic curvature alone isn't up to the job. Chris, therefore, we must invert the model in a way that conserves space-time. The total amount of space-time must remain constant. When we do so, the cosmos ceases to resemble a balloon inflating, extending outward, over time, and instead becomes an inward superposition of sequentially related states. The best way to think of it is in terms of a cumulative embedment of Venn diagrams, of state, on the inside surface of a sphere of extrinsically indeterminate size. As matter shrinks relative to the sphere, time speeds up. In Eddington's words, smaller and smaller, faster and faster. Eddington's phrase for his primitive glimpse of Cons-pansion was the theory of the shrinking atom. Guy, do you have the Eddington reference handy? I have his New Pathways in Science, but, in a cursory survey, couldn't find any similar thoughts in that book. Chris, try The Expanding Universe, but prepare to be underwhelmed. Eddington, having found the Big Bang Theory to be conceptually unsatisfactory, observed that it has an inverse formulation, the theory of the shrinking atom. He apparently worked out some of the rudimentary implications and noted as much in his book, Total Length of Explanation. 1 or 2 pages. But he did so in a way calculated to make other mainstream cosmologists think he was joking, no doubt to protect his professional reputation, which might not have survived the incredulity of his colleagues. Indeed, he quickly dropped the subject and never, to my knowledge, returned to it. I originally found the reference in Cosmology by E.R. Harrison and managed to track down the source material. But this was long after I'd already arrived at the idea of Cons-pansion in connection with a seemingly unrelated problem, how to account for the strangely harmonious relationship of mathematics and physical observation. For another kind of shrinking atom theory, check out the Hoyle-Narlikar model, which places the shrinking atoms in a static universe of infinite H. Chris, as it turns out, the model implies temporal superposition, requiring an ex post facto parallelization of consequent events with respect to antecedent events. The CTMU calls this the especially, for extended superposition principle, and adjoins it to quantum mechanics as an extension of the superposition principle. It permits temporal closure, something conspicuously lacking in the standard model. Guy, I tend to not really feel I understand new theories or principles until I work through most of the details myself, or at least see how they details could be worked through. In the CTMU discussions I've read so far, I think you present your results without adequate, for my purposes anyway, details for me to be able to reproduce them on my own, or in my own language. This is probably intentional on your part. Anyway, I plan to buy your book when it comes out and we'll try to work through the details then. Chris, thanks. From a later email by Guy. Chris, nothing that leads to logical inconsistency is confirmed by evidence. Expansion leads to logical inconsistency analytically. To wit, if there were something outside reality that were sufficiently real to contain the expansion of reality, it would be contained in reality. That's a contradiction, ergo, the hypothesis is false. Guy, Chris, I am confused by this statement. Expansion can be defined consistently without reference to some external space in which to expand. For example, the two-sphere is defined by its constant curvature and its total surface area. Mathematically, it's easy to increase its surface area. There's no contradiction. Chris, the contradiction results from the concept of local invariance, the idea that because we can't detect any change in the local metric by experimental means, it must be invariant in some absolute sense. The contradiction is tacit, but it exists nonetheless. Guy, I honestly do not see it. You are still not required to have the something to expand into, so there is no logical contradiction. Chris, intrinsic expansion is a contradiction in terms. If something is expanding, then it has to be expanding with respect to a fixed referent, and if it is, then it has to be extending into an external medium with respect to which the fixity of the referent has been established. On the other hand, saying that something is shrinking relative to that which contains it presents no such problem, for in that case, nothing is really expanding. An inclusive relationship, like that whereby the universe includes its contents, can change intrinsically only if its total extent does not change, where its total extent is just that of the inclusive entity. This means that the extent of the inclusive entity cannot change. Ergo, no expansion, it's logically analytic. Reason in any other fashion, and the term expansion becomes meaningless. Our only point of disagreement is that despite the above argument, you regard expansion as no contradiction. But because you deny that the universe is expanding in any absolute sense, because you define expansion in such a way that it does not require an extensional medium, the point is moot. Essentially, you agree with me that matter is shrinking relative to the invariant size of the universe. I'm calling it invariant because we're both regarding it as the fixed referent with respect to which matter is contracting. Therefore, you tacitly embrace Cons-pansion. Let's try another approach. The universe is something, and since you can't get something from nothing, you need an ontological substrate to get a universe. This substrate, which has the nature of infinite, unbounded, potential, can be approximately characterized as the absence of that which defines and delimits the contents of the universe. That which defines and delimits the contents of the universe is constraint, and the complement of constraint is potential. Therefore, the universe does indeed require a medium in which it can come into being and evolve, unbound potential, the ultimate logical generalization of existence. However, by the nature of its definition, this medium cannot endow the universe with size or a place in which to expand. That would amount to assigning it a constraint, and the medium is constraint-free. saying that the universe consists of a fixed amount of this potential is meaningless, because the very concept of amount is extrinsically undefined. But saying that there exists an invariant intrinsic relationship between the relative sizes of the universe and its contents is almost the same thing, and this is a matter of absolute necessity. Without such a relationship, one can neither define nor perceive a rate of cosmic expansion, for the rate function, including the algebraic invariance in terms of which it is defined, is just the invariant relationship in question. In other words, something is conserved, that of which the invariant relationship consists, and it is with respect to this something that Cons-pansion must occur. In the CTMU, this something is called SCSPL syntax. Chris, the contradiction also surfaces with respect to our concept of motion. In the expansive model, photons and planets alike moved by rotation and translation through a background called space, which, while possessing sophisticated properties like Lorentz invariance, is still considered an independent medium containing particles and fields. I also find the idea that space is a given independent medium to be unsatisfactory. But I don't see it as a contradiction. Chris, oh, it's a contradiction, all right. Unfortunately, the explanation exceeds my current time constraints. But here's a hint. I've already noted that if there were something outside reality that were real enough to topologically contain it, it would be intrinsic to reality, and therefore contained within it. We can make a similar statement regarding matter. If there were something outside matter that were material enough to contain it, it would to exactly that extent be intrinsic to matter. In order to accommodate matter, space must be potentially identical to it, must share its syntax. In other words, matter doesn't displace space, but occupies it in perfect superposition, intersects with it. So space consists of material potential and is thus a potential phase of matter. Denying this leads to a contradiction. Chris, in the conspansive model, on the other hand, motion is an endomorphism. Intriguing so far. Chris, defined with respect to those nested Venn diagrams we mentioned, with outer circles playing the part of quantum wave functions with respect to inner ones, and inner ones playing the role of moving particles with respect to outer ones. Because the circles in the Venn diagrams are just light cone cross-sections corresponding to wave functions because of the conspansive identification of light cones with wave functions and worldliness with particle trajectories. But this last part sounds a bit hokey to my highly indoctrinated with the orthodoxy ears. But I'll reserve judgment until I see the details. Chris, it shouldn't sound hokey at all, in fact, that's already more or less the understanding. I suspect you may be referring to the fact that light cones are part of an abstract model constructed for explanatory purposes. They don't really specify the locations of photons relative to their sources, and that by the same token, quantum mechanics has disposed of the idea that there are such things as continuous world lines. But light cones and wave functions are already tacitly understood to be codelimiting, and world lines can be approximated by path integrals evaluated over light cone cross-sections. Or maybe you mean that such an identification is too convenient. But if so, that might be because you think the amazing harmony between mathematics and physical reality, for all its ubiquity, seems too good to be true, and that anything but a tentative use of mathematical models is to be avoided. Fortunately, yet another advantage of Cons-pansion is its support for a meaningful approach to this problem. In fact, it was in that connection that I first thought of it. Chris, the CTMU defines a general relationship between relativity and quantum mechanics. We end up with two kinds of motion, a primary inner expansive kind representing the growth of Venn diagrams and the interpenetration of their spherical wave functions, and a secondary requantizative kind representing the relative shifting of diagrams as particles and galaxies undergo incidental spatial rotation and translation. But this implies a logical distinction. Simplistically, the first kind of motion characterizes a simulative phase of matter, and the second kind characterizes a simulated phase. Time, calibrated in terms of primary motion, is a process of dualization between these logically distinct levels. The universe becomes a self-simulation, a self-representational entity. You make a similar statement in the MNF article. I'm sure you must know this stuff, Chris. What am I missing? This is a sincere request. I really don't see the contradiction or paradox here. Chris, as I think I've explained above, you're missing, 1. The fact that ignoring extrinsic considerations by resorting to intrinsic definitions does not really dispose of them. Guy, maybe not, but I don't see anything that requires them, either. Chris, if not, that's only because you're taking on faith the idea that we'll one day achieve an all-encompassing intrinsic explanation for reality, and that this explanation will include no unforeseen additions, and no great surprises for the physics community. But given the history of science, that's not necessarily a good bet. After all, there remain some very challenging unanswered questions, including of what does the universe consist, how did the universe come to exist, and why does the universe exist, that show no sign of being satisfactorily answered by the partial intrinsic explanation of general relativity. One of two things is therefore required: forbidden reference to a measurable external medium, or a more thorough job of intrinsic theorization. So there are indeed crucial requirements left to be filled. Chris, and, 2, some of the implications of inverting ERSU to USRE, of dualizing the expanding rubber sheet universe to its conspansive dual model, the universe as a self-representational entity. In the general relativistic version of ERSU, time is just another linear dimension in which the curvature of the universe progressively changes. In USRE, on the other hand, time is the wave-particle dualization of space to matter, to space, and so on, with cumulative parallelization of time. Again, the ramifications are significant. We have two sets of invariants, one associated with the covariance of distributed physical laws, including all those dimensional constants relating matter, and one associated with the intrinsic invariance of the whole, including the conservation of space and the cumulative present in which the universe evolves. Guy, I'm intrigued and like the sound of this. In my opinion, the present is something on which modern physics does not do a satisfactory job. But, I'll have to see the details of your theory before I comment on what you say above. Chris, fair enough. Chris, for practical purposes, the standard model ignores the second set entirely. Guy, the standard model is, for all practical purposes, silent on the present. Chris, correct. That's because there is insufficient understanding of, and no scientific consensus on, the nature of time. Most theorists know that general relativity regards it as a linear dimension of the manifold called space-time, but few have any coherent thoughts on how this can be reconciled with quantum indeterminacy. The CTMU offers a new perspective. In order to maintain both sets of invariants, we need to change our understanding of the relationship of space, time, and object. Space-time becomes an SCSPL evolving endomorphically, by internal self-mapping, rather than by the motion of matter through an independent medium. Guy, sounds interesting. Chris, or maybe it's just CTMU time for Guy Fogelman. Universe A and B would appear to be the same in some respects and different in others. But this can be asserted only with respect to a basis of comparison, in this case arithmetic and geometry, which are brought to bear as parts of the cognitive syntax of one Guy Fogelman in the throes of a Gödel experiment. But the conclusions drawn from this syntax are valid only if it characterizes not just the thought processes of Guy Fogelman, but a joint medium containing both universes, i.e., only if arithmetic and geometry are distributed over an objective medium containing the compared entities. What infrastructure does this imply? First, it requires a connection between the cognitive syntax of Guy Fogelman and the objective medium containing both universes, an identity of Guy's mind and objective reality. More generally, it requires a conspansive CTMU infrastructure with logical priority over the Gödel experiment itself. Guy, well, I also like the idea of a theory containing both the object of the theory and the subjective theorizer. Again, I look forward to reading more about details of this approach in your book. Chris, they'll be there. Guy, what prerequisites, i.e., how much symbolic logic, higher math, and understanding of modern physics, will you expect from someone wanting to read your book? Chris, I'm trying to make it as self-contained as possible, even if that means some compact appendices in the back. But I won't deny that some exposure to logic, algebra, language theory, physics, and cosmology might help the medicine go down. Regards. Chris. Discussion at the Utney Cafe. This page is intended not as a self-contained discussion of the CTMU, but a more or less random Q&A derived from sundry discussions on various lists. Although many of the questions are intelligent and well-intentioned, there is a recurrent tendency on the parts of certain correspondents to complain to the effect that the CTMU is unconvincing or unsupported. But while some people seem to expect the author to type his entire theory into their email lists, thus sparing them the dire necessity of using the informative hyperlinks with which they are conspicuously provided as background, he is in fact obligated to do nothing of the kind. Suffice it to say that those in need of background information can find it elsewhere on this site. If this is unacceptable, never fear, nobody will force you to accept free access to something for which you can pay later on. The author is presently writing a book on the CTMU, and when it is published, it can be yours for a modest price. Perhaps I should also mention an occasional tendency for a certain kind of person to deplore the lack of bibliographies and academic credentials that I might bring to a given discussion. Concisely, such decorations are utterly irrelevant to content, which means that in all but a few specialized forums, they are a waste of time. As far as glossaries are concerned, I generally try to define my terms as I go along, or in any case, those terms that a reasonably intelligent and conscientious reader cannot be expected to understand by context or by consulting a dictionary. And to the rare gadfly who accuses me of being completely unoriginal and using the ideas of previous authors without due credit, I can only point out that while every philosopher and scientist who has ever lived has stood on the shoulders of giants, this entails no obligation to reel off a complete list of credits with every gesture of self-expression. Since my work contains a great deal that is original, those guilty of such accusations or insinuations merely display a hypocritical ignorance of its content. That being said, it is sometimes hard for a theorist to gauge what his audience does or does not know. For example, there is a tendency to assume that one's interlocutors understand the very basics of a field under discussion, otherwise, why bother to discuss it? Similarly, one tends to assume that if a reader is deficient in the basics, or is unfamiliar with one's own work, he or she will either politely request clarification or withdraw to privately fill the gaps in his or her knowledge before delivering an uninformed critique. Unfortunately, certain questionable aspects of human nature sometimes conspire to invalidate these assumptions. Accordingly, the author wearily offers a brief but informative essay on absolute truth and knowledge, to help readers understand the theoretical basis of what might otherwise look like his unwarranted certainty or unjustified air of authority. It is sincerely hoped that this will help even the most irritable reader avoid the perils and pratfalls of premature judgment. Happy reading! Chris Langan. Johnny Asia, Monday, October 23, 2022 2:32 CDT, 67 lines, initiation of thread. Time out of mind, reader-friendly introduction to the CTMU. http www.ctmu.org/ctmu_articles/time.html. The idea that the universe created itself brings a whole new meaning to bidirectional time, and thus to the idea that cognition may play a role in the creation of reality. As a self-creative mechanism for the universe is sought, it becomes apparent that cognition is the only process lending itself to plausible interpretation as a means of temporal feedback from present to past. Were cognition to play such a role, then in a literal sense, its most universal models of temporal reality would become identical to the reality being modeled. Time would become cognition, and space would become a system of geometric relations that evolves by distributed cognitive processing. Here comes the surprise: such a model exists. Appropriately enough, it is called the Cognition Theoretic Model of the Universe, or CTMU for short. A cross between John Archibald Wheeler's participatory universe and the Stephen Hawking James Hartle imaginary time theory of cosmology proposed in Hawking's phenomenal book A Brief History of Time. The CTMU resolves many of the most intractable paradoxes known to physical science while explaining recent data which indicate that the universe is expanding at an accelerating rate. Better yet, it bestows on human consciousness a level of meaning that was previously approached only by religion and mysticism. If it passes the test of time, and there are many good reasons to think that it will, then it will be the greatest step that humanity has yet taken towards a real understanding of its most, or least, timeless mystery. Introduction to the CTMU, Cognitive Theoretic Model of the Universe. By Christopher Michael Langan. The real universe has always been theoretically treated as an object, and specifically as the composite type of object known as a set. But an object or set exists in space and time, and reality does not. Because the real universe by definition contains all that is real, there is no external reality, or space, or time, in which it can exist or have been created. We can talk about lesser regions of the real universe in such a light, but not about the real universe as a whole. Nor, for identical reasons, can we think of the universe as the sum of its parts, for these parts exist solely within a space-time manifold identified with the whole and cannot explain the manifold itself. This rules out pluralistic explanations of reality, forcing us to seek an explanation at once monic, because non-pluralistic, and holistic, because the basic conditions for existence are embodied in the manifold, which equals the whole. Obviously, the first step towards such an explanation is to bring monism and holism into coincidence. Continued. http://www.ctmu.org/ctmu/article/intro/ctmu.html. http://megafoundation.org. Mission Statement. The Mega Foundation is a tax-exempt non-profit corporation established to create and implement programs that aid in the development of severely gifted individuals and their ideas. The Mega Foundation also supports and develops innovative projects in the arts and sciences, based solely upon the merit of the projects and the vision of their creators. Chris Langan, Tuesday, October 24, 2000, 4:56 CDT, 78 lines, in reply to Don Carlos D. Espinosa. Carlos, I can easily see why we can't speak of the universe as existing in space and time, but I don't see why we cannot, nevertheless, argue that the universe simply is a spatio-temporal, causally closed system. Chris, of course. The crucial point is that space-time is self-generative and logically self-contained. More precisely, it embodies both the logic according to which it is self-generated and self-contained, and the wherewithal to reflexively apply that logic. This means that to a species of sentience based on its own structure, the universe exhibits something analogous to self-awareness, a generalization of that to which we rather ambiguously refer as consciousness. I.e., the universe is understood by its own sentient agents to possess a predicate akin to consciousness, provided they reason correctly about their own status with respect to it. Carlos, surely if the universe is all of space and all of time, there is no larger space or time in which it could reside. But, for just this reason, there is no reason to think that there is more to the universe than the totality of causally interacting objects over space and time. Is this what Langan is also arguing, or would he disagree with this claim? Chris, reality consists of more than material objects, it also possesses aspects that cannot be reduced to matter alone. For example, space and time are relations of material objects that cannot be localized to the individual objects themselves, at least as locality is generally understood, they are greater than the objects they relate, permitting those objects to interact in ways that cannot be expressed solely in terms of their individual identities. Equivalently, we cannot reduce the universe to a set of material objects without providing a medium, space-time, in which to define and distribute the set. It follows that space-time possesses a level of structure defying materialistic explanation. Indeed, insofar as they possess spatio-temporal extension, so do material objects. Carlos, I certainly don't see why cognition is the only model for self-organizing systems. Our science here is in its infancy. Perhaps there are larger classes of such systems, the universe itself being the largest, and cognition as we know it is only a subspecies of such a system. Chris, suppose that cognition is not the only model for self-organizing systems, i.e. that such systems can be essentially non-homomorphic to cognitive processing. If so, then they lack meaningful cognitive representations, defying characterization in terms of mental categories like space, time, and object. But then they fall outside reality itself, being indistinguishable as causes, effects, or any kind of phenomena whatsoever. In a word, they are irrelevant with respect to that part of reality isomorphic to human cognition. It follows that by any reasonable definition, reality is cognitive up to isomorphism with our own mental structures. Carlos, it seems irresponsible of us to confuse a subspecies with a larger class. For one thing, cognition involves many properties and relations which I would not want to attribute to the universe as a whole. Cognition involves beliefs and intentions, and you'll have a hard time convincing me that the universe as a whole has either. But, as I said before, there could be many types of system that exhibit some characteristics of cognition. Chris, cognition can be partitioned into general and non-general functions. When we take the intersect of all of our individual cognitive functions, non-general options like beliefs and intentions cancel out and leave only those functions which are general to all the mental functions by virtue of which we all directly apprehend one and the same causally connected reality. In the CTMU, this cognitive intersect is called the human cognitive syntax or HCS. By the above reasoning, the universe, aka reality, aka space-time, is cognitive up to isomorphism with the HCS. To avoid this conclusion, one must break out of the above reasoning. But this is not as easy as one might previously have been led to believe. Chris Langan, Tuesday, October 24, 2000, 18:38 and 0 seconds CDT, 157 lines, in reply to Bill Lindsley. Bill, there are some interesting paths in this forest, but I suspect the unconvincing irrelevance of the tautology when language is crunched to include huge chunks of rock and ice hurtling through vast regions of near-empty space as mere subsets or projections of cognition. The problem with defining cognition to include the entirety of reality is that by definition, then, it includes the entirety of reality and really does not say anything much about the characteristics, the features, not even the behaviors of the many facets and elements of this reality. Chris, huge chunks of rock and ice hurtling through vast regions of near-empty space involves the processing, within a near-empty space, of the physical states of huge chunks of rock. This processing conforms to a state transition function included in a set of such functions known as the laws of physics. Calling these functions cognitive is hardly a stretch, since it is largely in terms of such functions that cognition itself is understood. Moreover, since the characteristics, the features, the behaviors of the many facets and elements of this reality are generally attributed to the laws of physics, it is not clear why cognition should not generally apply. After all, space-time consists of events and separations, and events can be described as the mutual processing of interacting objects. So where physical interaction is just mutual input to output behavioral transduction by physical objects, and cognition is mutual input to output behavioral transduction by neurons and their inclusive brain structures, physical interaction is just a generalization of human cognition. If this seems like a tautology, indeed it is. Self-contained self-referential systems are tautological by definition. Bill, do not get me wrong. I am intrigued. Less philosophically, however, than from the perspective of religion. The entirety of the universe as cognition sounds a lot like an all-knowing supreme being. Chris, quite so. Bill, the comment about beliefs and intentions is not a valid criticism, because knowing, the most significant import of cognition, is very different from believing and may have nothing to do with intention at all. I have no problem, either, with imperfect human, or partial cognition constituting fleeting glimpses into this universal cognition. I just think, though, it starts to sound awfully convenient, and it leans toward an isolated character sort of anthropomorphism, the isolated character meaning the ability of the human to think, thus man creating the ultimate universe in his own image, with his own image focused on the I think, therefore I am characteristic of being human. Chris, the anthropic principle, a controversial, but in the final analysis, necessary, ingredient of modern cosmology, is already about as anthropocentric as it gets. The CTMU replaces it with something called the telic principle, which avoids reference to particular agents such as human beings. The telic principle says merely that the universe, in addition to being self-configuring and self-processing, is self-justifying. Only the real universe can formulate and provide a real answer for the question of why it exists, and it does so through internal self-projections, distributed syntactic endomorphisms, called sentient agents. By the way, your mention of Descartes' cogito ergo sum is quite appropriate. Cartesian mind-body dualism underlies our ongoing reluctance to equate physical and mental processes. Yet, I think, therefore, I am explicitly implicates cognition in a general form of existence, thus implying that this form of existence transcends the merely physical. This suggests that there is a deeper way to view reality than through the empirical lens of scientific methodology, and that on this deeper level of reality, there is no hard divider between physics and cognition. Bill, as in most metaphysical systems, however, I tend to not approach them with the idea that what is important is whether they are true or false representations of what is, but more with the perspective of how can this system, this way of looking at things, help us to understand better the various disciplines of human understanding, including the sciences, and also including the arts, and most definitely the inquiry into understanding who we are and what it means to be and to be in the world or universe, or reality, whatever word one prefers to signify all that is. Chris, there will, of course, be a book on all this. Bill, I will note this: cognition, in my mind, means a process of knowing, and to know requires a knower and an object, that, or who, which knows and that which is known. I am very cognizant of some a priori or pure knowledge sorts of things, but they are of course all tautological. Such as mathematics, logic. No physical reality required, 1 + 2 = 3. But to know of any physical reality requires sentience, and there again that demands the observer and the observed. But we also recognize that the observer, and with some applied ability, the observer becomes a knower, is part of that being observed, the knower attempts to include herself in that known. We are also very cognizant of the inherent paradoxes that arise in self-references, Russell's paradox? I forget, though I know he addressed this at length in his discussions of set theory. Thus, we quickly run into a problematic wall, for it is one thing for the knower to know oneself, partially, incompletely, as part of what the knower perceives to not be the self, but as soon as this all-knowing entity attempts to refer to its own state of knowledge and being, it then invites the paradoxes, the inextricable morass of apparent sense without comprehensible meaning. What happens when cognition stumbles upon the proposition, "This sentence is false," which, if false, is true? We tend to attribute such paradoxes to the imperfections of language, and one might simply make a rule that it is improper syntax to use self-referential statements, but then the problem is we need self-referential statements, we use them extensively, meaningfully. Chris, such paradoxes are properly viewed not as static objects, but as dynamic alternations associated with a metalinguistic stratification that is constructively open-ended but transfinitely closed. Note that this is also how we view the universe. Otherwise, the paradox corrupts the informational boundary between true and false, and thus between all logical predicates and their negations, which of course destroys all possibility of not only its cognitive resolution but cognition and perception themselves. Yet cognition and perception exist, implying that nature contrives to resolve such paradoxes wherever they might occur. In fact, the value of such a paradox is that it demonstrates the fundamental necessity for reality to incorporate a ubiquitous relativization mechanism for its resolution, namely the aforementioned metalinguistic stratification of levels of reference, including levels of self-reference, i.e. cognition. A paradox whose definition seems to preclude such stratification is merely a self-annihilating construct that violates the syntax, structural and inferential rules of reality and therefore lacks a real model. In other words, to describe reality as cognitive, we must stratify cognition and organize the resulting levels of self-reference in a self-contained mathematical structure called self-configuring self-processing language, or SCSPL. SCSPL, which consists of a monic, recursive melding of information and cognition called infocognition, incorporates a metalogical axiom, multiplex unity, or mu, that characterizes the universe as a syntophionic relation or self-resolving paradox. The paradox is self-resolving by virtue of SCSPL stratification. A syntophionic relation is just a universal quantum of inductive and deductive processing, i.e. cognition, whereby different objects are acknowledged to be the same with respect to their mutual relatedness. Bill, so, when this supreme cognition includes itself in what it knows, what happens? Perhaps it quivers and a black hole is created? Chris, quite the opposite. In fact, it transforms itself from a featureless, or more precisely, homogeneously self-similar, cosmic singularity to an internally variegated syntophionic relation, fractionating into layers of space-time in a process called Cons-pansion, material contraction qua spatial expansion. The associated logico-algebraic structure, SCSPL, reflects the cognitive structure of that all-knowing supreme being you mentioned. As one might expect, the theological ramifications are extensive. Chris Langan, Wednesday, October 25, 2000, 12:09 and 46 seconds CDT, 135 lines, in reply to Paul Kisak. Chris itemized responses to Paul's numbered questions. 1. Do you contend that the universe is better modeled as a dynamic object of a dynamic set, a static object of a static set, or something else entirely? CL. First, sets and objects are objectivized concepts and therefore merely informational. The subjective side of their existence has been wrung out of them. In contrast, the universe is infocognitive, which means that it is everywhere both objective and subjective. So sets are of limited value in describing the universe, at least as they are normally understood. Second, since time is a function of scale, the universe is both static and dynamic, depending on descriptive scale. From its own global vantage, the universe is timeless, or if you prefer, evolves in a single instant. From a local internal vantage like ours, it is dynamic. Equivalently, the ultimate laws of the universe are invariant and therefore timeless, while the internal states of the universe are dynamic and temporal. 2. My personal opinion regarding a definition of reality would lean more towards the potential of known truths rather than the status of known truths, when attempting to develop cosmological models of our universe. Likewise, I would agree that space-time is self-generative, possibly at the thermodynamic expense of another similar set, system, and/or dimension. At this point, I am uncertain as to whether or not the conceptualization of such a dynamic system is outside cognition in its entirety. Personally, I visualize the attempt to render closure on such a modeling effort to be akin to the conceptualization that is required when intuiting a mathematical singularity. The math goes ballistic at the asymptote, but verbal and other cognitive processes step in to bridge the ever-dwindling gap between the explanation/model and the understanding. Is it your belief and/or position that my presumption of this asymptotic gap is an ever-present illusion, or that at some point the fundamental decomposition of matter, for example, will cease as we know it or evolve into a further division of energy quanta, for instance? CL. I agree that there is a kind of asymptotic gap between reality and nothingness where the laws of physics, like matter itself, break down. However, certain syntactic invariants will remain in place nevertheless. For example, certain features of logic must still apply, otherwise, there is no point to the logical exercise called theorization, and because logic defines our cognitive framework, this means that some degree of cognitive isomorphism still applies. To put it another way, only tautological systems like logic and cognition are capable of emerging from the background of pure potential, and the fact that such systems are tautological isolates them to the point of mutual irrelevance. This means that the best we can do is to start with what we are given in this reality and attempt to generalize it into the asymptotic realm. Reality theory seeks a description of reality on its most basic, that is to say its most general, level. So if our local reality is asymptotically embedded in some kind of meta-reality, the purpose of reality theory is to describe the latter. But this description will to some extent describe our local reality as well, since the embedment of reality in meta-reality is analogous to that of a closed, self-contained subgroup in a larger group. Reality and meta-reality will share the same systemic identity. The tautology persists, indeed. The hallmark of a real tautology is that you can't break out of it. 3. Do you think that such a model would transcend the current triad of philosophical taxonomies, axiological, metaphysical, epistemological? CL. Technically, metaphysics includes epistemology, along with cosmology and ontology. Because axiology, which has to do with values, extends to the values according to which a universe is created, it overlaps with metaphysics. In fact, since axiology is predicated on real contexts and reality is ultimately metaphysical, it can be regarded as wholly included in the metaphysical realm of discourse. So it all comes down to the most basic and general science of all, metaphysics. In fact, since anything worth talking about assumably exists, and metaphysics contains ontology, the study of existence, we can rest assured that this will remain true. 4. Do you think that the basic laws of thermodynamics, as they are currently applied to the behavior of tangible systems, can have a direct corollary to intangible systems? Cl. The laws of thermodynamics are a subsyntax of the laws of logic and mathematics in terms of which they are expressed. So the question is, how does their generality compare to that of the overall reality syntax? In how general a context can they reasonably be applied? Well, whenever we have a system, we have a conserved systemic identity, and the conservation of an identity is always in a sense thermodynamic. So the answer is very general indeed. But where there exists a systemic stratification involving nested closed subsystems, we must be careful to observe the various levels of closure. We can't just excerpt thermodynamic relationships from the physical, or material, level of reality and apply them to more basic, hypothetical, levels. 5. Do you currently have a bibliography that is relevant to the CTMU? Cl. Unfortunately, no. Due to the generality of the theory, the fact that a general theory of reality, it is designed to apply to everything real, a thorough bibliography would have to be quite extensive, and in any case, the theory contains certain mathematical ingredients that, to my knowledge, cannot be found in the standard literature. The fact is that while many books contain clues on how to construct a comprehensive theory of reality, there are no currently available books that include them all. On the other hand, since I prefer to work from first principles wherever possible, I'm not much for bibliographies anyway. We've reached the point in many disciplines where keeping abreast of the literature takes more work than synthesizing theoretical ingredients from scratch. As data access technology moves forward, this may change for the better. If you want to know how to prepare for the CTMU, I'd recommend a good history of Western philosophy, for example Russell, a good book on mathematical logic and formalized theories, for example Rogers, and a good book on general cosmology, for example Harrison. 6. Do you plan to publish a bibliography at some time in the future that pertains to the CTMU? Cl. Only if I absolutely have to, see above explanation. 7. Could you make a bibliography that is relevant to your development of the CTMU available? Cl. Those 3 books I mentioned might be a good start. The history of philosophy will inform you on the state of the art in reality theory, which, unfortunately, was reached several centuries ago with the still unresolved dispute between Hume and Kant. The book on logic and formalized theories will inform you on the basic mechanics of reasoning and the criteria for constructing meaningful theories. And the book on general cosmology will inform you on the application of mathematics, and particularly algebraic systems, to observable reality. The rest you can infer. Chris Langan, Wednesday, October 25, 2015 o'clock/45 CDT, 102 lines, in reply to Vatayan. Cl. Yes. Well, Vatayan, I think you're making a mistake here. You're pointing to word usage, grammatical formations, styles of expression and so forth, but passing your judgment on content rather than form, which is actually what you're criticizing. See comments below. Vatayan, here we have strings of inferences and speculations that are carefully couched and put together with the implication that they mean more than they say. Notice the nature of the initial string of suppositions. Because cosmic expansion seems to imply that the universe began as a dimensionless point, the universe must have been created, and the creation event must have occurred on a higher level of time, cosmic time. Cl. You want to keep your eye on the ball here. These suppositions are shared by the wider community of scientists and philosophers, who subscribe to something called the Standard Model. What we're doing is establishing a basis for dialogue with that community by adducing an inference, namely cosmic expansion from an initial singularity, from a set of observations, namely cosmic redshift attributed to galactic recession, of interest to that community. The reason I write seems is that the CTMU offers a new set of inferences distinct from those of the standard model. Vatayan, a speculation that only seems to have validity is the if. Based on the if we have a then which must be real. See above remark. Vatayan, Langan writes, prior to the moment of creation, the universe was not there, afterwards, the universe was there. This is speculation taken as final truth. The universe has also been speculated as existing perhaps in some state prior to the expansion events of the Big Bang. We should be extremely careful about supposing that our speculations offer final truth. Once again, I'm referring to a set of inferences shared by many members of the scientific community, not necessarily my inferences. A close reading of this passage, not to mention the article, would have sufficed to make this clear to anyone without an axe to grind. Vatayan, Langan writes, if the creation of reality was a real event, and if this event occurred in cosmic time, then cosmic time itself is real. This implies that cosmic time, and in fact reality, must have created themselves. Ifs and their implied implications once again turn into must-haves. Wrong again. The ifs refer to a chain of widely assumed conditions, and the this implies refers to a consequence following from those widely assumed conditions in light of other widely assumed conditions mentioned previously. But that's almost beside the point, because the CTMU conspicuously places no reliance on these widely assumed conditions to derive the given consequence. It relies on pure logic instead. Inasmuch as I'm busy describing that logic for dissemination to people who are truly interested in the theory, I don't think it's fair to insist that I repeat it all here. Vatayan, Langan writes, the idea that the universe created itself brings a whole new meaning to bidirectional time, and thus to the idea that cognition may play a role in the creation of reality. As a self-creative mechanism for the universe is sought, it becomes apparent that cognition is the only process lending itself to plausible interpretation as a means of temporal feedback from present to past. The apparent bidirectionality of time poses difficult questions as to the nature of perceived reality. Once again, the speculation that is offered as to the meaning begins with an if, proceeds to a may have, and then ends with being an only plausible interpretation. This method of discourse is repeated over and over. In the end, we only have strings of speculation that show that the author is familiar with a great body of cosmology and has put out his own model. The difficulty I have with it is that it pretends to be more than a string of inflated inferences. It implies more than it actually delivers. Unfortunately, you're now making another bad assumption, that what is implied has not been delivered. In fact, it has been delivered, in other forums, and what we're doing here is merely notifying people of the theory's existence and offering a very brief description. In fact, I'm only participating because a buddy of mine posted the excerpt to which you refer without prompting from me, and I felt that Café Utni participants might appreciate a follow-up from the horse's mouth. However, that doesn't mean that I have time for content-free discussions of my writing style. Chris Langan, Thursday, October 26, 2000, 16:08 and 21 seconds CDT, 132 lines, in reply to Paul Saad and Johnny Asia. Paul Saad, just a small question. Is this science or metaphysics or something entirely different? Did not Spinoza try something very similar but from a different perspective? Johnny Asia, that is a big question. I'm sure you'll get a good answer. Far be it from me to refuse such a friendly challenge. Empiricists believe that knowledge of reality is based solely on observation or sensory input. Although they do not generally dispute the reality of rational conceptualization, they maintain that it is somehow separate from physical reality, and that only sensory experience can justify its physical application. Thus, many empiricists subscribe to dualism. Rationalists, on the other hand, hold that because the senses can lie, sense data are always unreliable, thus, certainty is the exclusive province of logic and mathematics, and reality can be known only by fitting it to abstract logico-mathematical structures. In practice, most modern scientists adhere to a model-theoretic blend of these two viewpoints, rationalistically applying logic and mathematics to empirical data obtained through observation and experimentation. In the spirit of this dual allegiance, they avoid things that they, mistakenly, believe can be neither directly observed nor mathematically expressed, things like purpose, emotion, and consciousness. Like Descartes and Leibniz, Baruch Spinoza is considered to be one of the supreme rationalists of Western philosophy. As a true member of the breed, he believed that knowledge comes from logic and reason alone, and that real truth is obtained solely through the rational analysis of ideas without regard to observation, emotion, or arguments from authority. Accordingly, he presented his own rationalistic views as geometrical inferences, deducing theorems about reality in strict mathematical style from what he considered to be self-evident axioms. Like a geometrician, he proceeded from definitions, axioms, and postulates to propositions, demonstrations, corollaries and lemmas or intermediate theorems. Relegating empirical information to a merely suggestive role, he proposed to base science as well as theology on a rationalistic conceptual framework consisting of an axiomatic system from which the laws of reality can be deduced. When applied in the context of religion, rationalism opposes the acceptance of beliefs that cannot be logically justified. For example, the Reformation was characterized by rationalistic challenges to such Christian doctrines as the creation, the flood, the Holy Trinity, the Incarnation, and the Resurrection. In addition to being a scientific rationalist, Spinoza was a religious rationalist bent on devising a purely logical brand of theology. Thus, he is remembered for his attempt to devise a comprehensive theory of reality seamlessly combining logical theology with a rationalistic approach to science. Since this goal is philosophically inevitable, it is not surprising that the CTMU shares it. But despite the similarities between Spinoza's approach and my own, there are significant differences as well. Because Spinoza was primarily concerned with religion and virtue, he brought God into the mix from square one, characterizing God or nature as the one substance of which reality in general is composed. That is, he subscribed to a dual-aspect monism in which God, equating to nature, possessed two aspects called thought and extension. Although thought and extension are to be understood in terms of the Cartesian distinction between mind and matter, Spinoza broke with Descartes in making God the basis of a dual-aspect monism instead of a third basic ingredient of reality. In the first part of his definitive work Ethics, he defines God as that outside of which no other substance can be given or even conceived. While acknowledging this divine substance to have an infinite number of attributes, Spinoza insisted that human beings can know only two of them, thought and extension, ideic and spatial existence. That is, while stating that there is a one-to-many, and in fact a one-to-infinity correspondence between each attribute and particular things or modes, he asserted that humans can know only those modes entailed by the two specific attributes in question. While ideas and bodies appear to human experience to be separate things, they are simply twin aspects of one divine substance. Now let us review three facts. First, Spinoza's rationalistic outlook is logical in essence and therefore imposes on reality the consistency of reason. Second, Spinoza embraced dual-aspect monism, further stating that the order and connection of ideas is the same as the order and connection of things and thereby asserting the coincidence of thought, or idea, and extension, or physical reality. Thus, he believed that there is a sense in which mind equals or coincides with material reality, and thus that no part of material reality eludes mind in its distributed deic sense, that the realm of ideas, which might be viewed as comprising the syntax of the deic level of mind, is comprehensive with respect to reality. And third, Spinoza subscribed to a deterministic form of cosmic self-containment or closure, using the phrase divine freedom to refer to a kind of global self-determinacy associated with a total absence of external constraint. Note that Spinoza did not extend this freedom to human intentionality, he excluded contingency from the divine substance and its attributes and modes, equating it to mere ignorance of the true causes of one's actions. Enter the CTMU. The CTMU amounts to a metalogical reality syntax incorporating three high-level principles or metalogical axioms corresponding to the above three elements of Spinoza's metaphysic. Although Spinoza long predated the study of formalized theories and could not avail himself of its mathematical machinery far more advanced than his tool of choice, ancient Greek geometry, the three formal attributes consistency, comprehensivity, and closure turn out to be sine qua non for what we now refer to as a theory of everything. Specifically, they are high-level syntactic attributes of the mathematical structure, self-configuring self-processing language or SCSPL, in terms of which the CTMU explains reality. Thus, although Spinoza could not know how to precisely formulate or apply these three principles, we can say that his system was to some extent CTMU-like, a sort of entry-level CTMU prototype. But while there are other intriguing parallels between Spinozan metaphysics and the CTMU, the similarity is strictly limited by certain crucial points of departure, largely predicated on several centuries of philosophical and scientific progress. For example, the CTMU regards what Spinoza called divine freedom as a distributed aspect of reality available to human agents by virtue of a new conception of space-time structure. Next, while the CTMU is also a dual-aspect monism, it asserts that the basic substance of reality is infocognition, a blend of information and cognition analogous to this new version of space-time. And whereas Spinoza began with God as a primitive or axiomatic ingredient of reality, the CTMU defers all mention of God until a rational basis for his/her existence has been laid by scientific reasoning from the metalogical axioms whose existence his work could only adumbrate. In fact, the CTMU uses these metalogical requirements to construct a whole new proof of God's existence. There are other differences as well. But for now, suffice it to say that on the holodeck of the Enterprise, Baruch Spinoza and I would enjoy a mutually sympathetic discussion or two. Chris Langan, Thursday, October 26, 2000, 18:35 and 23 seconds CDT, 240 lines, in reply to Nick Blythe, Don Carlos D. Espinosa, and Mackenzie Anderson. Nick Blythe, MMMM. Why cognitive and not just information? Sorry if I'm being thick. CL, because you can't define information without implicitly including cognition, mechanical computation, or some other form of transduction in the definition, and vice versa. I.e., information and cognition are recursively defined in a medium called infocognition. On the logical level, space and time are recursively defined in exactly the same way. That's how we achieve a monic, infocognitive explication of space-time. 2. Don Carlos D. Espinosa, the argument, very roughly, goes like this. 1. The universe is self-created. 2. Our best example of a self-created process is cognition. 3. Therefore, cognition is a model for the universe. CL, unfortunately, Carlos, that's wrong. 1. Is correct. 2. Should read our only example rather than our best example. In order to call something an example, we must subject it to cognition, and by virtue of cognitive embedment, it is isomorphic to cognition and therefore cognitive, regardless of whatever other descriptions it might support. And technically, 3. Should read generalized cognition instead of cognition. As I've already stated, the universe is cognitive up to isomorphism with human cognition. Beyond that point, it is cognitive only in a precise generalized sense, namely that of input to output transduction of information. Because generalized cognition logically embeds human cognition, it is necessarily even more powerful with respect to transductive potential. Carlos, if I agree to 1, and 2, 3, does not follow. Cognition is only an analogy for the universe, and an analogy is not an explanation. However, I don't agree to either 1 or 2. CL, since you've got 2 and 3 wrong, responding to subsequent inferences is unnecessary. But for clarity's sake, let's do so anyway. Carlos, 1, claims that the universe must be self-caused, i.e. a cause that caused all other causes. This argument goes at least as far back as Aristotle, and it's a traditional definition of God within Western theology. CL, yes, it's Aristotle's prime mover argument, and you're correct in asserting that it is a traditional definition of God within Western theology. Hence the theological implications of the CTMU. Carlos, the standard model of the Big Bang attributes self-causation to the universe itself. However, there's still legitimate controversy within the cosmological community over this. Martin Rees and Lee Smolin, two of the hottest names, have both offered cosmologies which do away with the self-caused character of the Big Bang, by suggesting that our universe is not the only one. There's no way to know, i.e. empirically, if there are other universes, but there are good mathematical reasons to think so. And there are better mathematical reasons to think not, at least when it comes to incorporating them in an explanation of why this particular reality exists. What it comes down to is this: reality by definition contains all that is real. So in the widest sense of reality, reality theory must explain genesis within reality itself. Rees and Smolin are merely avoiding this necessity by pushing the genesis problem back a step to some kind of meta-reality. But we can easily rephrase our questions about genesis so that they refer to this more basic level of reality, and unfortunately, Messrs. Rees and Smolin are neither prepared nor equipped to answer those reformulated questions. The CTMU does not share this drawback. The reason: the CTMU is logically structured in a way that forces it to refer directly to the most basic and general level of reality, without speculative departures based on mere physical analyses of material reality. The fact that physics is embedded in logic should, perhaps, have clued these gentlemen in on the necessity to attend first to the logical structure of their theories and only secondarily to the associated physics. Carlos, as for, 2, I simply don't see how cognition can be self-caused even if strange loops, a la Hofstadter, are employed in logic and other cognitive processes. Cognition coordinates sensory input and motor output, to use the computational model, which is convenient, though misleading. There must be a world for cognition to work from and act on, no self without a world. Yet, if we begin by identifying cognition and world by saying that reality is cognitive, then cognition has a world to work from and act on, namely itself. After all, in addition to acting on external input, cognition is primarily self-active, otherwise, it is incoherent and therefore non-cognitive in any integrated sense. When your brain undergoes cognition, its own neurons are processing each other's behavior by input-to-output transduction. It's all inside your brain, and that means that the macroneuronal level of processing associated with your brain is self-contained with respect to your brain. This general reflexive relationship applies to any engine of cognition whatsoever, even the coherent wave functions of subatomic particles and the universes which contain them. Carlos, perhaps one might think of cognition as self-caused insofar as the structure of the mind in the Kantian system is transcendental, i.e. not subject to categories such as causation. But it is difficult to defend Kant without having some response to the criticisms of post-Kantians such as Hegel, Nietzsche, or Heidegger. There are substantial disagreements between them as well. I'm not suggesting that there is a single, coherent post-Kantian position. I'd be willing to make a considerable wager that I've got it all covered, at least in principle. 3. Mackenzie Anderson, I have no argument with what you are saying and I find that you have a great deal clarity. However, I'm wondering why you haven't mentioned David Bohm, since in Wholeness and the Implicate Order, 1980, he has already described an enfolding and unfolding universe using the descriptors implicate and explicate. He described all that is as undivided wholeness and flowing movement, which seems to be what you are saying. The difference is that unlike Professor Bohm, I'm not using poetic license to gloss over the fact that I lack a comprehensive mathematical structure supporting my assertions. When Bohm appealed to his nebulous holographic analogy, he was merely hinting at SCSPL. Don't get me wrong, much of Bohm's work is very insightful. But to make his ideas work, you need a concept called Hology predicating a distributed endomorphism from the overall informational structure of reality to every internal point of reality as cognitive syntax. This is what expresses the identity of information and cognition I've been referring to as infocognition. It's a key characteristic of SCSPL, and you need a whole new model of space-time to define it. Furthermore, you need a lot of additional logical and mathematical apparatus that Bohm left out of his inspired speculations about quantum non-locality. This additional apparatus resolves certain long-standing paradoxes to which Bohm apparently devoted little of his thought and energy. Mackenzie, there is also a book called The Conscious Universe by Robert Nadeau and Minas Kafatos, who also wrote The Non-Local Universe, 1999. They likewise make the point that it cannot be argued that scientific theory does not support the existence of God, although they acknowledge that it is interpretational. One can accept the philosophy of wholeness without identifying such concept with the God concept. No, one cannot. It comes down to coherence. The wave function of the universe must be coherent in order for the universe to be self-consistent. Otherwise, it pathologically decoheres into independent and mutually irrelevant subrealities. Because the universe is both cognitive and coherent, it is a mind in every sense of the word. God is simply a name that we give in answer to the unavoidable question whose mind. Mackenzie, Paul Case, a recognized world authority on the Kabbalah and the Tarot, describes the universe being created and sustained through self-contemplation in his published Meditations, the Book of Tokens. However, in the Kabbalistic sense, it is not cognition which is responsible for creation, but desire. Personally, it seems logical to accept that there is a consciousness which permeates everything, once one accepts the concept of wholeness, whether it be from the point of view of mystical oneness, or from the point of view of a single quantum system. If the parts have consciousness, why would the whole of which they are a part also not have consciousness? The spooky action at a distance of paired photons supports the idea that the universe is conscious. However, I don't know how the idea that only certain parts of it are conscious is supported. I have heard it said quite dogmatically that stones have no consciousness, and I always wonder what this assertion is based upon. If stones have a consciousness but do not use it to communicate to humans or in any way, which is recognizable to humans, how would we know about it? The idea that they don't have consciousness is just an assumption. I do know from the subjective experience of holding stones in my hand that they have strong vibrational energy. We know that rocks are cognitive because we observe their molecules to interact, that is to say, effect mutual input to output behavioral transduction. That's the rock's very own internal dialogue, and there is absolutely no valid reason to deny its cognitive nature. The rock even has a generalized sort of desire to self-interact. This desire is logically inherited from a global attribute previously described as the telic principle. Concisely, the rock self-cognites because its medium, namely the universe of which it is a part, self-cognites out of a desire to self-create. This desire corresponds to the ability of reality to internally support a desire for its own existence. Like reality in general, it's a recursive function. Mackenzie, if wave-particle duality can be applied to all that is, no matter how many universes that might include, in the sense that all that is becomes one complete quantum system, the implication is that there are at least three epistemologies involved, that of the wave and that of the particle, and that of the whole. Empiricism may be a valid approach from the perspective of the particle, alone, but when wholeness is taken into consideration, the action of the wave has to be accounted for, and that cannot be known from the dualistic particle perspective. Which brings us to St. John of the Cross and his infused meditation, which is the tradition of inspiration upon which religions have been born. In the CTMU, the decoherence of the quantum wave function is simply the conversion of a coherent or cognitive state potential, or wave, into actualized information, i.e. a particle, by cognitive interaction, radiative intersection, with another wave function. Wave and particle, cognition and information, alternate with stable identity in conspansive space-time. On the limiting scale of reality as a whole, this says that the wave function of the universe is self-interfering and self-collapsing. The universe is an eigenfunction of its own teleological operator. This works only in conspansive, CTMU, space-time, where ingredients like the telic principle, already described, and the especially extended superposition principle, allow the self-cognitive universe to self-select from a background of unbound potential defined on an utter lack of constraint. Note the cybernetic terminology. Without these ingredients, reality theory ultimately falls flat. Mackenzie, of course, wholeness can never be proved to the satisfaction of those who require empirical proof, since one can never step outside of wholeness and observe it without creating a state of duality. This in a sense describes the creative function of self-contemplation. CL, yes, but it can be proven to non-empiricists by showing that empiricism is only half of the route to knowledge, and that the other half, rationalism, is the key to proof. Although you'd never know it by talking to some scientists, radical empiricism went out with Hume. As for the rest, well, enough said. By the way, welcome to the 3rd millennium AD. Chris Langan, Friday, October 27, 2000, 15:57 and 2 seconds CDT, 190 lines, in reply to Johnny Asia, Lucas, and Mackenzie Anderson. Thanks, Johnny, see you next week. Lucas, I haven't read everything in regard to your theory, but I personally feel that, the need for a new math for this notwithstanding, any real answers will finally be found between UFT and chaos theory. Frankly, I am relieved I'm not the person for that job. CL, you're evidently talking about a lower order of explanation than that of the CTMU. Otherwise, you'd be neglecting a very important necessity, to explain the UFT and chaos theory themselves. In reality theory, one is not free to inexplicably parameterize an explanation, you have to regress to self-explanatory constructs, and neither UFT nor chaos theory fills the bill. To do that, you have to get down to the foundations of mathematics. But I agree that UFT and chaos theory are definitely a part of the larger answer. Johnny, maybe God is not a being after all, but rather being itself. CL, excellent. As we usually conceive of a being, it requires a medium, specifically, a being usually exists in space and time. But an ultimate being must serve as its own existential medium. Mackenzie, which still sounds quite a bit like what you have been talking about with your nested sets. CL, I haven't been talking about nested sets, I've been talking about nested SCSPL sublanguages. There's a world of difference, some of which was explained earlier in this thread. Mackenzie, you then say in order for SCSPL to work you need a whole new model of space-time to support it, without describing that model. I'll take a guess, that what you mean is a form of simultaneous time in which space and time exist as a unity rather than as a complementarity. I think such is implied whenever the concept of wholeness is discussed, including the Bohm's discussion. CL, close, but no cigar. When first conceived, the CTMU was heavily influenced by the mathematics of computation theory. Thus, what you call simultaneous time in which space and time exist as a unity is treated as a primitive form of parallel distributed processing, PDP, built into the structure of space-time. Time is actually a higher-order sequential relationship of parallel computative, to be generalized as cognitive, domains. Bohm left this model theoretic nicety out of his discussion. And regarding what is implied whenever wholeness is discussed, there are those who would say that the entire universe is implied by a single electron. Unfortunately, to get credit for tracking such implications, one has to be more explicit. Mackenzie, next you go on to say that one needs a lot of additional logical and mathematical apparatus that Bohm left out of his inspired speculations about quantum non-locality. However, you have glossed over whatever apparatus that may be. CL, I don't have time to spoon-feed the entire theory to the sort of casual reader who leaps to negative conclusions without even seeing it. The concept of conspansive spacetime has been thoroughly explained in Noesis, the journal of the Mega Society, to the readers of various email lists, and even to an editor of Scientific American. But I will give you a couple of important facts. In conspansive spacetime, it is more correct to say that you are shrinking than that the universe is expanding. The size of the universe is an undefined absolute, i.e. externally immeasurable but invariant. And in conspansive spacetime, there are two levels of motion, one logical in character and the other algebraic, and neither is what you ordinarily think of as motion. Mackenzie, you close by saying this additional apparatus resolves certain long-standing paradoxes to which Bohm devoted too little of his thought and energy. Which is a damn glossy statement. Who can possibly argue with certain long-standing paradoxes since you haven't given a clue as to what you are actually referring? CL, the paradoxes in question are common knowledge among those familiar with this topic, ex nihilo cosmogony, how to get something, namely a universe, from nothing, the cosmological paradox of external embedment, how reality can exist without a medium to contain it, the arrow of time, and so on. Since all of these reality paradoxes are interconnected, Bohm could not achieve a complete resolution of the paradoxes of quantum collapse and non-locality without resolving other reality paradoxes in the process. He didn't do that. But that doesn't mean I see no value in his work. In fact, I freely acknowledge his genius. Mackenzie, once again I can't understand what it is you are denying about the works of Robert Nadeau and Minas Kafitos. In fact, I cannot tell from what you have written if you have actually read their works. CL, at the risk of looking like a barbarian, may I make a little confession? I've never read anything by either of these authors. But then again, my analytical approach doesn't seem to require it. Please bear in mind that as a non-academic on a limited budget, I don't always have access to everything a given person thinks I should read. And then there's the time factor. Mackenzie, I have to tell you, Chris, I much prefer Bohm's poetry, as exemplified in phrases like undivided wholeness in flowing movement to cybernetic terminology. When one hears Bohm's phrase, one doesn't have to resort to Bohm's own personal dictionary with all of his personally invented words and concepts in order to understand what he means. His poetic phraseology communicates to a much wider audience because it uses generally understood words. I think this matters. CL, other than a couple of acronyms, I haven't used any neologisms in my posts here. I suspect that you may simply be unfamiliar with some of the mathematical terminology, isomorphism, endomorphism, sublanguage, etc. But in that case, you should avail yourself of a dictionary or two before criticizing my vocabulary. The downside of Bohm's poesy, which I can appreciate as much as you do, is that it doesn't explain the logical mechanics of the topic at hand. While his language captured some of the mechanics, it left some gaping holes as well. In formal reality theory, the logical mechanics are everything, poetry comes second. Mackenzie, I disagree with you about your key to proof. IMHO, rationalism, and empiricism are functions of particle nature. Gnosis is the complementary way of knowing, which is analogous to the wave function, which relates the particle to the whole. CL, in the sciences, knowing equals definite cognitive modeling through observation and /or inference, compare empiricism and /or rationalism. While intuition and gnosis are more direct forms of cognition, and your assertion that they are associated with the wave phase of material cognitors happens to be very insightful, the knowledge thereby acquired can only be confirmed by scientific means. Since everything I contribute to reality theory is subject to scientific confirmation, I don't have the luxury of appealing to the intuition or Gnosticism of my readers. Please bear this in mind the next time you find yourself tempted to deplore my less than poetic writing style. Johnny Asia, you might enjoy the work of an acquaintance of mine, Chris King, self-described knobby and biocosmologist. CL, you bet I do. A scintillating website by a very insightful author. Make no mistake, the transactional interpretation is a very useful bit of reasoning, and Chris King is right on top of some of its implications. Lucas, Chris, do you think that cognition does not require an observer, and that QM does not, a la Prigogine et al.? CL, better to say the observer may coincide with that which is observed. In other words, subjective self-observation is just another way to say cognition. Regarding QM, the best way to handle observation is to distribute it over that which is observed, i.e. to regard particles not only as measurables, but as measurers. That's implicit in their generalized cognitive functionability. Mackenzie, however, upon reading Langan's post, again, it might be interpreted otherwise. I thought there was another place where he had made claim to an absolute proof, but for the moment I can't find it. Perhaps I was mistaken. CL, I most certainly do lay claim to an absolute proof of sorts. What I mean by absolute is precisely this: 1. You can't relativize your way out of it by changing the context. 2. Finding it in error equates to destroying your own basis for inference. These criteria are built into the theory from the ground up using some very effective, that is to say ironclad, techniques. Logically, there is no way out. But don't take my word for it, wait for the book and then give it your best shot. The ability to rely on blind faith is a wonderful thing. But it can also be an extremely destructive thing, and too often in the course of human history, it has been just that. The world is still full of people willing to kill, and die, for their beliefs, willing to destroy the planet and everyone on it for the sake of their faith. As long as they can continue to deny the existence of any absolute truth but their own, as long as they can hold their religious or political dogmas above the very laws of logic themselves, this perilous situation will continue to threaten our world. The CTMU aims to change all that, ultimately preventing the baser elements of humanity from continuing to risk our lives and welfare, and deprive us of our freedom, under cover of arbitrary anti-rational justifications devolving to blind faith. You may not like this degree of absolutism, and being a lover of intellectual freedom, I sympathize. But it's a logical universe, logic unavoidably constrains our view of reality, and that's the way it has to be. If I hadn't come up with the CTMU myself, it would eventually have been discovered by someone else. Again, welcome to the new millennium. From Chris Langan to Don Carlos D. Espinosa, Thursday, November 2, 2023, 29 and 26 seconds CST. Carlos, what I find objectionable is not the content of the CTMU model, since I lack the proficiency to judge it. I object, rather, to the cult of personality that surrounds men and women of genius. This cultish behavior entails at least the following: genius can only be recognized, i.e. measured, by other genius. If someone is a genius, what they say can only be refuted by another genius. If a non-genius expresses disagreement with a genius, or refuses to participate in the cult of genius, it can only be a result of resentment. CL, at the risk of deviating from the main content of this list, I dislike intellectual snobbery as much as the next person, and to show that I put my money where my mouth is, I've worked many blue-collar jobs that most soi-disant geniuses wouldn't touch. But make no mistake, geniuses do think more efficiently than most people. That's what being a genius is all about, and it makes very little sense not to pay them at least a little extra attention. It's amazing how many people who would never dream of trying to replace a star athlete at the plate or the free throw line think nothing of holding themselves equal to a certified genius when it comes to solving philosophical riddles. It's as though they equate philosophy with free-for-all. Unfortunately, that's a bad call. Carlos, personal note: feel free to disregard. When I was 5, I was given an IQ test. As a result, I was placed in a gifted program in grade school, and remained in it throughout primary and secondary school. In retrospect, I feel that the opportunities and resources made available to me through that program, teachers who actually care and have the time to devote to individual students, opportunities to develop my own interests, etc., should have been available to everyone. Maybe some of my fellow students would still have become burger flippers or drug dealers, but they should have been given a chance. Instead, some arbitrary test determined that I and a few others would be given what should have been given to all. CL, how true. But sadly, we do not have limitless educational resources, and this means that we must maximize the resources we have. Since the great bulk of human intellectual progress has been the work of geniuses, it seems more efficient from a survival of the species standpoint to make sure that where geniuses are identified in the course of the educational process, they are provided with the resources to achieve their potential. Let's try an analogy. If instead of first fueling the fastest and longest range vessels in our exploratory fleet, we insist on evenly distributing a finite fuel supply among all of the vessels, what we may end up with is a fuel crisis halfway to our destination. Possible result: exploratory mission cancelled, new, cure, technology, energy source, cancelled, mankind cancelled, etc. Paying special attention to gifted children can hardly be characterized as penalizing average children when the fruits of their inimitable labors may eventually prove to be the keys to human survival. In fact, such a characterization is groundless. For if ostensibly normal children succeed in distinguishing themselves within the ranks of the average, they can always be reclassified as geniuses or genius material and become the recipients of increased resources and attention. If a child can show uncommon intellectual ability in a gifted program, then he or she can certainly do so in a mainstream program provided, of course, that the programs are conscientiously taught and administered. But that's another problem entirely. Carlos, as far as the CTMU is concerned, Langan develops one idea that I find rather interesting, although I would proceed differently than he does. A true theory of everything, for those of you just tuning in, must necessarily be a tautology. What I find curious, however, is that he does not draw what I would consider to be the next step, that because a toe is tautologos, it is useless and we should spend our time as scientists on something more interesting. CL, this idea was specifically addressed in my brief essay on absolute truth and knowledge. The idea that tautologies are inherently uninteresting is based on the obvious fact that if a piece of circular reasoning deals with only a small part of the world, then it can tell us nothing about other parts and in fact can mislead us by falsely purporting to universality. But this does not mean that tautologies are useless, not even close. In fact, propositional logic is a mathematical structure that consists of nothing but tautologies, they are its axioms and theorems. Thus, your statement translates roughly as follows: logic is useless. How many intelligent people would agree with your hypothesis when thusly formulated? Probably not very many, which of course makes one wonder just who has been teaching this ridiculous platitude, and why, to the many people who seem to embrace it. In fact, tautological logic is the most powerful tool in our intellectual arsenal, supporting the derivation of countless new logical expressions and embedding every past, present and future mathematical and scientific theory. Without it, we not only could not theorize about reality, we couldn't even observe it. Without it, there would be no such thing as a mathematical proof. And without it, you wouldn't even have a computer with which to register your philosophical views. The CTMU is a metalogical extension of logic designed to embrace reality in general, and as such, it must embody the reality-theoretic counterpart of a tautology called a supertautology. That you still don't know what this entails is unsurprising, because it's only one of a large number of original mathematical ideas that were necessary to formulate the extension of logic called a toe, again, see on Absolute Truth and Knowledge. But in any event, you can be sure that by the method of its construction, this metalogical extension of logic is even more powerful than logic alone. And that means very powerful indeed. Carlos, on the other hand, the search for the Holy Grail that physicists call a toe is really a theory that unifies general relativity and quantum mechanics. CL, as does the CTMU, at least in part. But understanding how would require an advanced comprehension of conspansive space-time. Suffice it to say that while the CTMU does not yet qualify as a unified field theory, a UFT alone does not a toe make, and those who call it a toe are guilty of a misnomer. Rather, the UFT being sought by the physics community is something that can be well formulated only in a real toe like the CTMU, and until it is in danger of unraveling like an old sweater due to deep cosmological and mathematical paradoxes threatening its foundations. Carlos, such a theory would be a theory of everything, and as such be tautologos, if we could also reduce psychology to biology, biology to chemistry, chemistry to physics, and physics to the toe. Contemporary complexity theory, as I understand it, gives us reasons for rejecting reductionism. Now, it is possible that complexity theory itself could be reduced to a toe. In that case, the toe might very well encompass everything, although in a holistic rather than reductionistic sense. CL, in fact, complexity theory is a disconnected set of mathematical vignettes that scarcely merits description as a theory. Part of the motivation behind the CTMU was to provide the field of complexity with a more coherent theoretical framework. This goal has been at least partially realized. Carlos, here the connections between CTMU and Spinoza's conception of God as the one substance that truly exists, are again evident, although I'm not sure it's a model of God that the traditional, i.e. Judeo-Christian, believer would find compelling. CL, believe it now or believe it later, the choice is one's own to make. The only point I am trying to make at the present time is that as soon as one subjects the God concept to true logical reasoning, it's CTMU time. And although I can already hear the howls and imprecations, I'll add a little something for the sake of honesty: there is no logical escape. But if you haven't been following my explanations to date, then I'm afraid that's just another piece of friendly advice. Carlos, suppose however, that we develop a toe which does indeed explain everything, whether this is the CTMU or some other model, and this we call God. Is this really an explanation of anything? Or, rather, is it that, because it encompasses everything, it actually explains nothing, because there is nothing outside of it in which it is explained? Would it not then be, not the ultimate explanation, but the limit, or end, of all explanation? Cl. A toe would be the end or limit of logical explanation only with respect to generality. With regard to observable specifics that are not completely determined by its limiting generalities, it would remain internally open despite its algebraic closure, and therefore thermodynamically able to accommodate new information. Again, that's a function of conspansive spacetime, which is a direct consequence of the CTMU's supertautological structure. Carlos, the reason why mysticism explains nothing, as the advocates of Enlightenment rationalism claim, is because mysticism is not an explanation, but something entirely different. The failure of the Enlightenment lies in this, not that they failed to perceive something which can be explained, though perhaps not in scientific terms, but that they failed to see that explanation is not the end of the matter. There can be light if there is also darkness, there can only be explanation if there is also mystery. Cl. Quite so. That's why there is plenty of room within the CTMU for new mysteries and new explanations. From Chris Langentu, Lucas, Thursday, November 2, 2023, 34 and 16 seconds CST. Lucas, well, Chris might be right. I didn't really see any math to check. Did I miss something? I'm sure Eva is qualified to check it, as are Ted, Simon, Dan WS, and a bunch of other folk here. I have tried to forget all that stuff, myself, but have dusted off a book or two since Simon put me up to reading Prigozhin's End of Certainty business. Cl. Actually, it's all mathematics, mainly advanced logic including a lot of model theory and algebra. I've just been putting it in such a way that readers with no math background can understand it with minimal effort. Although people sometimes complain about the lack of awe-inspiring strings of mathematical symbols in my explanations, I'm actually being exceptionally considerate by omitting them. For example, while many people are familiar with Kurt Gödel's undecidability theorems due to popularizations following their introduction, very few people are actually able to sort through his original mind-boggling sequence of cumulative mathematical definitions and symbolic notation. If Eva is one of those people and thinks she's qualified to check or critique my work, I welcome her attention. But she'd better be thorough and correct in her judgments, because when she's finished, I'll critique her critique, and with all due respect, I usually come out on top in the event of conflicts. Academic credentials never seem to play a meaningful part. From Chris Langentu, Mackenzie Anderson, Friday, November 3, 2000, 8:49 and 22 seconds CST. Mackenzie, first quoting Gina Lasasso, Chris exhibits the utmost patience in responding to every sincere question that is put to him, and is happy to continue the dialogue as long as content remains the focus. This discussion changed its form after Chris left. Imho, he wasn't willing to answer questions put to him. It seems he was here to recruit people to join his own discussion forum, not as an equal member of this one. Cl. Unfortunately, this isn't quite correct. Vatayan began relieving himself of bigoted absurdities, and you, Mackenzie, started accusing me of paying criminally short shrift to David Bohm, before I withdrew. There were other impolities as well. Please, there's no point in discussion unless we stick to the truth. From Chris Langentu, Lucas, Friday, November 3, 2000, 10:25 and 23 seconds CST. Lucas, tautologies are generally thought of as useless because they can only be defined in terms of the plus missiles. For example, if you define consciousness as awareness, that's a tautology, and it has to be, since there really is no other way to define consciousness except to use other words that mean the same thing. Cl. Good point about the self-definitive nature of tautologies. In effect, they are recursively defined. Notice that through the conceptual intersect of tautology and recursive definition, tautology is related to the more practical mathematical realms usually associated with recursion. Unfortunately, when we theorize about reality in general, tautology is the name of the game. That's because reality is a universal autologous, self-descriptive, predicate that is self-contained and therefore needful of some enlightened circular reasoning. This can easily be proven by contradiction. If there were anything outside of reality that were real enough to affect it in any real way, then it would not be outside of reality, but an integral part of reality, QED. Ergo, it is an analytically demonstrable fact that we can reason about reality only in a self-contained or circular fashion. But don't let this get you down. Algebra in its entirety, including arithmetic, geometry, calculus, and every other branch of mathematics, is based on circularity or closure. In fact, circularity is ultimately the only valid basis for mathematical and scientific reasoning. Lucas, so you go round and round, but never really get anywhere. That's what Carlos meant by such arguments finally being useless, I think, no matter how elegant or how detailed they might be. See above response. Lucas, as I stated from the beginning, I rather agree with Chris, but there is no escaping that Carlos is correct regarding the above and that Eva, Tim, and others are correct as well. There's no way to check it, no observational point. Of course, Chris admits that from the start. Not quite. We have just escaped from Carlos' reasoning, and can continue to do so ad infinitum no matter what might be added to it. As shown above, circularity is ultimately the whole story in science. The illusion of openness is something that we can enjoy only in specific localized contexts. The problems with circularity arise only when claims of generality are erroneously made for circular contexts that turn out to be non-general, which can't happen here. In the above proof by contradiction, we saw that the claim of generality associated with a supertautology is analytically based on the recursive definition of reality itself. While tautology has gotten a bad rep because circular rationalizations have too often been erroneously mapped onto parts of reality that didn't really afford them a model, logical and metalogical tautologies are absolutely universal and do not share this risk. Don't be misled by the pontifications of your high school teachers et al. Regarding the impossibility of meaningful tautological reasoning in science. If a given piece of scientific reasoning is logically correct, then it ultimately has to be tautological on the propositional level. As a quintessential case in point, the CTMU supertautology has plenty of ramifications that end up expressing themselves in terms of non-logical, non-tautological symbols and their associated mathematical machinery. But until we can break through certain fundamental misunderstandings about the role of tautology in science, there is no point in discussing them at length. Discussion between Christopher Michael Langen and Russell Fred Vaughan, Ph.D. Part I. RFV, I've been meaning to begin a dialogue with you that would help us both understand each other better. Bob Seitz thinks most highly of you, and such a friend is the best recommendation a man can have in my book. I would be foolish not to know you better than I do, with you being only an email away. What I'd like before attempting any major intellectual challenge like your CTMU, that I would like to get into later after I have some background, is to compare our perspectives on various topics without the public displays and distractions of being on the list. If you have any questions about my leanings on any topic, please let fly with questions and I'll answer them as straightforwardly or as stupidly as I happen to hold my opinions. I would like to discuss them in such a non-confrontational way, and slowly so that it sinks in. I will be as intellectually fair with you as it is possible for me to be. I do find it easy to acknowledge others' ideas, but that does not mean that I have none of my own that I would deny having had before a conversation. I am personally not nearly so worried about my own ideas as I once was, but naturally we all have some level of paranoia with regard to such things. I hope we can converse in such a way that you are always convinced of my good faith in this regard. Assurances are best proven rather than stated. CML, of course. I share and appreciate your willingness to progress towards mutual understanding. I know that some of my ideas look somewhat strange from a conventional viewpoint, but they're not lightly formulated, and I always welcome a chance to explain the underlying logic. RFV, if there's a different agenda or different approach to this one that is better, then let's do it. But in the meantime, could we investigate one of the questions that I have that seems to involve a major difference of opinion between us? I happen to think that one cannot know the world without data, and that our most abstractly generalized notion of the world must be based on inductive reasoning from that data. Having developed a generalized notion or theory, one can then deduce specifics that are warranted, and our theory is only warranted to the extent that these deductions map to actualities. It is my impression that you hold a somewhat different opinion or place emphasis differently within such a scheme. Teleological arguments are not something I think should be tossed out without consideration, but I do have much more skepticism with regard to them. However, I hold what can only be called faith, that the ultimate physical theoretical solution will of a necessity about it which is very convincing, SOR of Einstein's God would have done it this way. CML, I agree that we can't know the world without data. But since we necessarily receive and interpret these data mentally, they provide important clues about our mental structure. The idea that this mental structure shapes the phenomenal world has been known since Kant. The CTMU simply pushes Kant's ideas to their logical conclusion, dealing directly with the relationship between mind and reality. RFV, could we just talk about this topic quite narrowly for a beginning? That is, unless you have a question of me or a different agenda. CML, sure. No problem. RFV, thanks in advance for whatever this engenders. Part 2. RFV, I agree that we can't know the world without data. Okay. That one's out of the way. But since we necessarily receive and interpret these data mentally, they provide important clues about our mental structure. Obviously, this is the big swinging door. Obviously, on the one hand, we have photons, and on the other, complex ideas. Perceptions are somewhere between. CML, there's the first catch. Your clear distinction between photons and ideas is not globally valid, but a provisional convention. Photons have a general abstract existence as well as a specific physical one. This is what happens when you embed physical reality in a space of abstractions in order to theorize about it. Real objects necessarily conform to more or less exact configurations of an abstract distributed syntax. Since there's no way out of this requirement, it's pointless to theorize about photons without admitting it from the outset. A theory that doesn't is nothing but an oxymoron. It contains an implied logical inconsistency from Jump Street and invalidates itself. RFV, I never want to underestimate you, but at the same time I want to be sure that something that I happen to know that I consider relevant is known to both of us. So, let me just ask. Are you aware of biophysics studies by Hofmans, and probably others later, demonstrating the development of Lie groups, as in the Norwegian mathematician, in the neurons between the eyes and the brain, which affect the transformations of rotation, translation, etc. outside of the brain? CML, if we examine a brain under a microscope, we see neurons and synapses. A neuron is either firing or not, its state is either 1 or 0, corresponding to the truth values of two-valued logic. If we think of a neuron as a brain quantum, we get a brain quantum, and therefore a brain, conforming to 2VL. Nothing that cannot be expressed in this 2VL language can be formulated within the brain, or any larger neural system including, for example, optic neurons, including non-discrete mathematics, for example, continuous Lie groups. On the other hand, anything that can be formulated in this language can be cerebrally formulated. The exact location of visual transformations is beside the point. The neurons that affect them are still microbrains obeying a 2VL mental syntax. In this sense, visual transformations are still mental in character even when they occur outside the brain. However, although Hofmann's research sounds familiar, I'd appreciate a web source, if available. RFV, these capabilities are staged in development with the shape-size transformations not being completed until around the age of 8. The reason I bring this up is that one actually takes a tremendous leap from photons upon the eye to perception to the brain without any mental operations whatsoever. Perhaps a newborn has to work the problem from beginning to end, but it's simplified for us. This also, of course, gives us theory-laden data from the outset. And these transformations can fail to be developed properly if eyes are crossed and not fixed until after that particular transformation is programmed, etc. CML, again, when you say mental operations in a CTMU context, you're talking about a generalized form of mentation, not just the mentation of a human brain. Since a photon and a brain both transform information, albeit on different levels of complexity, they are both mental in nature. In other words, you seem to be making an a priori semantical distinction between levels of information transduction, the levels represented by a brain and a photon, and, again on an a priori basis, assigning mental status to only one of them. There's no scientific basis on which you can do that. It amounts to anthropocentrism. What we seek in any scientific context is a distributed formulation of reality that applies inside the brain as well as without it, and although the terms mental and brain are often assumed to be associated, this need not be exclusively so. Where the universe is described as existing within an abstract space with exhaustive mathematical structure, a kind of self-distributed Platonic proto-universe, everything employs this structure as transductive syntax up to isomorphism with the intrinsic structure of the transducing object. But the intrinsic structure of an object need not be directly observable, for the simple reason that it's distributed and thus cannot be locally discerned by observation. The intrinsic syntactic, mental, structure of an object can only be inferred from its behavior, which is where a need for data enters the picture. In other words, something doesn't have to have observable structural complexity to have a complex behavioral syntax. If it did, then the theory of so-called elementary particles would be free of mathematical complexity. RFV, the idea that this mental structure shapes the phenomenal world has been known since Kant. So to what extent can the external world shape the mind, i.e., affect its programming? Certainly there must be some of that going on within the brain as well, mustn't there? CML, of course. But to achieve a closed-form theory of reality, we need to admit that this shaping or programming process is mutual. That's why the CTMU employs a model of space-time in which mind programs universe even as universe programs mind. RFV, the CTMU simply pushes Kant's ideas to their logical conclusion, dealing directly with the relationship between mind and reality. Let us hold off a bit longer on this till we have a common understanding of percepts. CML, in the conventional model, percepts are objective observables that actively imprint themselves on, and thereby shape and determine, the passive mind and its internal processes. But a more general, and therefore more scientific, less tautological, description of percepts portrays them also as having a subjective perceptual aspect that is identified, at a high level of generality, with the creation event itself. This is just an extension of Wheeler's observer participation thesis: only intelligent entities are observers. To physical reality in general, everything is an observer, with the caveat that it's still possible, and indeed necessary, to reserve a special place for intelligence in the scheme of things. The surprising part, in my opinion, is this. This reduction of all reality to simultaneously active and passive infocognition amounts to defining reality as did Hume as pure experience. Infocognition is just a technical synonym of experience that opens the concept up to analysis from the dual standpoints of information theory and cognition or computation theory. Thus, the Kantian mind-matter distinction, as embodied in the term infocognition, is simply distributed over Hume's experiential reality by synonymy, bringing the metaphysics of Hume and Kant into perfect coincidence. Part 3. CML, let's see if we can cut to the chase here. Suppose you're wearing blue-tinted glasses. At first, you think that the world you see through them is blue. Then it occurs to you that this need not be true, maybe it's the glasses. Given this possibility, you realize that you really have no business thinking that the world is blue at all. Indeed, due to Occam's razor, you must assume that the world is chromatically neutral, i.e., not blue, until proven otherwise. Finally, managing to remove your glasses, you see that you were right, the world is not blue. This, you conclude, proves that you can't assume that what is true on your end of perception, the blue tint of your lenses, is really true of reality. Fresh from this victory of reason, you turn to the controversial hypothesis that mind is the essence of reality, that reality is not only material, but mental in character. An obvious argument for this hypothesis is that since reality is known to us strictly in the form of ideas and sensations, these, after all, are all that can be directly known, reality must be ideic. But then it naturally occurs to you that the predicate mental is like the predicate blue, it may be something that exists solely on your end of the process of perception. And so it does, you reflect, for the predicate mental indeed refers to the mind. Therefore, by Occam's razor, it must be assumed that reality is not mental until proven otherwise. However, there is a difference between these two situations. You can remove a pair of blue sunglasses. But you cannot remove your mind, at least when you're using it to consider reality. This means that it can never be proven that the world isn't mental. And if this can never be proven, then you can't make an assumption either way. Indeed, the distinction itself is meaningless. There is no reason to even consider a distinction between that which is mental and that which is not, since nature has conspired to ensure that such a distinction will never, ever be perceived. But without this distinction, the term mental can no longer be restrictively defined. Mental might as well mean real and vice versa. And for all practical purposes, so it does. A theory T of physical reality exists as a neural and conceptual pattern in your brain, and/or mind, it's related by isomorphism to its universe U, physical reality. T, isomorphism, U. T consists of abstract ideas, U consists of supposedly concrete objects like photons, perhaps not the best examples of concrete objects. But the above argument shows that we have to drop the abstract-concrete distinction, which is just a different way of expressing the mental-real distinction. Sure, we can use these terms to distinguish the domain and range of the perceptual isomorphism, but that's as far as it goes. For all practical purposes, what is mental is real, and vice versa. The TU isomorphism seamlessly carries one predicate into the other. Now let's proceed with your questions. RFV, but since we necessarily receive and interpret these data mentally, they provide important clues about our mental structure. Obviously, this is the big swinging door. Obviously, on the one hand, we have photons and on the other complex ideas. Perceptions are somewhere between. There's the first catch. Your clear distinction between photons and ideas is not globally valid, but a provisional convention. I knew there'd be a catch here somewhere. I'm treading lightly on photons now, okay? Maybe we should accept a continuum between these? Or doesn't that work either? I can remain provisional on photons for a little while yet. CML, no. Photons are at once abstract and concrete. In fact, the distinction might as well not even be discussed, because it's oxymoronic, as shown above. RFV, photons have a general abstract existence as well as a specific physical one. Okay, take me through this one gently. I don't think I'll have a problem here if this level of abstractness involves alternative equivalent representations prior to collapse of a wave function or something like that. What do you have in mind here? CML, as explained above. Or if you prefer, assume that a photon has no abstract existence. Then since ideas are abstract, it corresponds to no idea. But you know the world through ideas. So for you, a non-abstract photon has no existence. But you're discussing photons that exist. So the photon you're talking about is abstract, as well as concrete? RFV, this is what happens when you embed physical reality in a space of abstractions in order to theorize about it. Now, are we supposing that our physical reality is but one in a space of all possible realities? And then what is a reality in this case? An instantaneous snapshot of all things. CML, no. It's a self-perceptual system with a combined abstract and concrete nature, as explained above, that possesses closure with respect to other realities. RFV, real objects necessarily conform to more or less exact configurations of an abstract distributed syntax. Please do not get impatient with me here. I really do not understand what you mean by your words without definitions and explanations, and you are being very patient so far. In what sense do you mean more or less exact configurations? Further, and maybe with a little more detail, what does an abstract distributed syntax mean to you? And how have we concluded that real objects necessarily conform to such a thing? These are major leaps, perhaps not for you, perhaps not for anyone you might hope I were, but for me they are major. Necessarily implies to me that it should be self-evident, since it could be no other way, at least after I understand it. Conforms is a verb one doesn't usually see in this context, so I assume you mean to imply that there is an isomorphism that could be established between real objects and such a more orderly abstract structure. If that's what you mean, I'm with you. If not, please provide a little remedial instruction. CML, if we form a theory of some aspect of reality, it may or may not be correct, i.e., it will be more or less exact. But even if not, we can be sure that the correct theory will conform to our mental structures, since otherwise we won't be able to create a conceptual isomorphism with it, and that's what a theory is. A syntax is to be interpreted as any set of structural and functional constraints applied to any system. A syntax takes the form of general information and is implemented by generalized cognition. RFV, since there's no way out of this requirement. I understand that idealization at some level is required to theorize about anything if that's what you mean. It's pointless to theorize about photons without admitting it from the outset. If you mean that I must suspend belief about what a photon is until the theory is completely understood, that is no problem since no one else knows what a photon is yet in its fullest sense either. CML, a photon is a configuration of the syntax of reality, as already explained, that's assured. It's also assured that a photon is at once abstract and real. RFV, a theory that doesn't is nothing but an oxymoron, it contains an implied logical inconsistency from Jump Street and invalidates itself. This last sentence seems to break with what I understood we were talking about. I thought we were addressing provisionality of what a photon is and the fact that real objects must be abstracted into a more formal structure in order to theorize. I buy that, but I have not yet considered the class of theories about such real objects. But if you are meaning to imply that a theory that begins with a preconceived notion about an object, say photon, it won't be of much use with regard to clarifying what a photon is, I can buy that. But, there are hierarchically ordered theories for which it might work just fine. We are not hot on the trail of one of that kind, I presume. CML, again, the combined abstract/real nature of a photon is not provisional, but given from the outset. It's only the exact corresponding configuration of reality syntax that remains a mystery, and in a sense, not even that. RFV, continuous Lie groups. On the other hand, anything that can be formulated in this language can be cerebrally formulated. The exact location of visual transformations is beside the point, the neurons that affect them are still microbrains obeying a 2VL mental syntax. In this sense, visual transformations are still mental in character even when they occur outside the brain. I have no disagreement with any of this, but the 2VL neurons are not limited to 2VL types to my understanding, they may be quite analog computer-like, in which case I don't know where 2VL fits into this scheme. I noticed that you placed a lot of credence on distinctions with this kind of logic, and that was actually the next area that I wanted to question you about your background assumptions. So maybe you could tiptoe through some of this for me. CML, analog computers are as bound by 2VL as are digital computers, an analogy either exists, 1, or not, 0. All distinctions are 2VL, one thing is either distinct from another, 1, or not, 0, on a given level of definition. Since information consists of distinctions, constraints differentiating one thing from another, information is 2VL. Since theories consist of information, theories are 2VL. And since theories are isomorphic to reality, reality is 2VL. There is no escape, no crack in the stone of truth versus falsehood. Even to explain why there might be, you would be forced to resort to 2VL. And your putative exception would be embedded in 2VL by fiat. RFV, however, although Hoffman's research sounds familiar, I'd appreciate a web source, if available. I have a couple of copies of papers circa 1965 around here somewhere. Come to the shindig next summer and I'll find them for you. CML, hey, I'm 3,000 miles away. But I appreciate the invite. Maybe if I make a lot more money than I have now, I'll surprise you and show up. RFV, again, when you say mental operations in a CTMU context. That was why I wished to remain outside that context until I get some background that presumes none of CTMU. Any word I use for now will be a lay definition term except as our mutual backgrounds accommodates more extensive terminology. I can't do this any other way, I'm sorry. It's just a limitation I have. CML, as explained in the preface, mental operations cannot be distinguished from real operations except in a provisional way. That's what I mean by a CTMU context. It's given a priori. RFV, you're talking about a generalized form of mentation, not just the mentation of a human brain. Since a photon and a brain both transform information, albeit on different levels of complexity, they are both mental in nature. I have no problem with this in general, and the existence of levels of consciousness as other than human mental operations is something I can readily accept. A photon? I don't know, what's the information? Blue? CML, actually, the example of a photon is problematic for reasons too advanced to cite here. But for now, let's just say that a photon transforms the state of an atom by causing an electron to jump from one orbit to another. Even more basically, it transforms its own coordinates as it moves. Due to the CTMU conspansive model of spacetime, the quotation marks are necessary. Atomic states and position coordinates are informational. RFV, in other words, you seem to be making an a priori semantical distinction between levels of information transduction, the levels represented by a brain and a photon, and, again on an a priori basis, assigning mental status to only one of them. I did in fact. And now I think I'm a little more in tune with where you are in this. CML, sounds promising. RFV, there's no scientific basis on which you can do that, it amounts to anthropocentrism. No need to disagree here since we don't, but I'm not sure that those who do disagree might not consider their approaches scientifically palatable. What we seek in any scientific context is a distributed formulation of reality that applies inside the brain as well as without it. Whoa! Now here is another big hop. I, for example, have never presumed so great a scope for limited scientific endeavors. Let's leave this one for now unless there is some brief clarification that lessens the hurdle for me now. CML, what I said is an implication of the scientific method, and specifically the experimental replicability criterion. If an experiment is replicable, then it can be repeated anywhere in space-time provided the proper conditions are present. The possibility of the existence of those conditions at any point in space-time, given the presence of supporting conditions, means that it is distributed over space-time, but in a conditional way. Because all scientific truth is obtained by the scientific method, it conforms to this description. It has a conditional distributed formulation. This relates to the concept of space-time homogeneity. It's a logical necessity of meaningful theorization. RFV, and although the terms mental and brain are often assumed to be associated, this need not be exclusively so. Absolutely with you here. Where the universe is described as existing within an abstract space with exhaustive mathematical structure, a kind of self-distributed Platonic proto-universe. I know I'm breaking this sentence apart, but it's necessary for me to do so. I understand the agenda of the first part of this sentence, but I get confused here. Everything employs. What do you mean here? Do you mean, for example, that any analysis of the universe necessarily employs the mathematical analog of the universe? I think so, and if so, I buy that. CML, no, it goes even farther. Any material object or field has intrinsic mathematical structure that acts as a syntax to process information, for example, the photon described above. Again, it goes along with the absence of an absolute distinction between the abstract, syntactic, and concrete sides of reality. RFV, this structure as transductive syntax up to isomorphism. The isomorphism between universe and mathematical structure is, of course, all that can justify the approach, but with the intrinsic structure of the transducing object. Now this I have problems with. This says that the fact, which I accept but some would doubt, that we can create an isomorphism between the universe and a mathematical model necessarily implies that the agent that can do this must have a structure isomorphic to the universe as well. That requires some very critical thought. Let me do it. CML, let me save you some time. The isomorphism is given on a de facto basis. Indeed, it follows from the preface. RFV, but the intrinsic structure of an object need not be directly observable, for the simple reason that it's distributed and thus cannot be locally discerned by observation. No problem here. The intrinsic syntactic, mental, structure of an object can only be inferred from its behavior, which is where a need for data enters the picture. Very definitely. But here you need an extreme amount of data, it would seem to me, and I don't know off the top of my head that I can think of what kind of data would justify such a claim. It strikes me somewhat of the I can test of 4 sigma, therefore IR1. A test would be good. CML, remember, theories are made to be superseded by better theories, data can always be extended. Only tautological self-distributed systems possess certainty. That's why we can be so sure of the 2VL component of reality syntax. Theories generally aren't so ironclad. RFV, in other words, something doesn't have to have observable structural complexity to have a complex behavioral syntax. If it did, then the theory of so-called elementary particles would be free of mathematical complexity. But regularity ought not be confused with simplicity. CML, true enough. RFV, the idea that this mental structure shapes the phenomenal world has been known since Kant. So to what extent can the external world shape the mind, i.e., affect its programming? Certainly there must be some of that going on within the brain as well, mustn't there? Of course. But to achieve a closed-form theory of reality, we need to admit that this shaping or programming process is mutual. That's why the CTMU employs a model of space-time in which mind programs universe even as universe programs mind. We're going a little ahead of my schedule here, but let me address the if a closed form exists, then. What makes you jump for such a solution? Don't get me wrong, I like closed form too, but one usually adapts one's desires to the problem. I guess, never mind. CML, the discernibility and stable identity of objects within the universe can be shown to imply that the universe is informationally closed in the following sense: it is possible to distinguish that which it contains, reality, perceptions, from that which it does not contain, unreality. I.e., there's an informational boundary separating that which the universe includes from that which it excludes, and this boundary is what is closed. No closure means no boundary means no information. RFV, the CTMU simply pushes Kant's ideas to their logical conclusion, dealing directly with the relationship between mind and reality. Let us hold off a bit longer on this till we have a common understanding of percepts. Still hold off a little. I'm sure it will do us well. In the conventional model, percepts are objective observables that actively imprint themselves on, and thereby shape and determine, the passive mind and its internal processes. Yes. But a more general, and therefore more scientific. We have somewhat different definitions of scientific. CML, again, scientific means replicable, replicable means distributed, and distributed means general. Moreover, science carefully excludes false tautologies, or circular but non-general forms of reasoning. RFV, less tautological, description of percepts portrays them also as having a subjective perceptual aspect that is identified, at a high level of generality, with the creation event itself. You mention description, that is the key word. How are percepts best described? Data is needed here too, it seems to me. CML, description can here be considered synonymous with theory, and thus related to perception, data, by isomorphism. RFV, this is just an extension of Wheeler's observer participation thesis: only intelligent entities are observers. To physical reality in general, everything is an observer, with the caveat that it's still possible, and indeed necessary, to reserve a special place for intelligence in the scheme of things. This is a whole nother topic. A great one. We got started on that when I was accused of being a murderer. What constitutes a real event? My understanding of at least one of Wheeler's notions was that an irreversible change had to have taken place, intelligent observers be damned. CML, if you're right, then Wheeler's title for his thesis, Observer Participation Thesis, would seem to indicate his agreement with me about what constitutes an observer, namely anything able to participate in an irreversible change. This reflects the distributed subjectivism and self-processing character of reality, the fact that mind, or observership, and reality can't be absolutely distinguished. RFV, the surprising part, in my opinion, is this. This reduction of all reality to simultaneously active and passive infocognition amounts to defining reality as did Hume as pure experience. Infocognition is just a technical synonym of experience that opens the concept up to analysis from the dual standpoints of information theory and cognition or computation theory. Thus, the Kantian mind-matter distinction, as embodied in the term infocognition, is simply distributed over Hume's experiential reality by synonymy, bringing the metaphysics of Hume and Kant into perfect coincidence. I see what you are saying here, but I'm not here yet. CML, it's even simpler than I put it above. Experience entails something that experiences and something that gets experienced. So if reality consists everywhere of experience, it is everywhere self-experiencing, and has everywhere the character of both mind, the subjective experiencer, and objective reality, that which gets experienced. So the categorical imperative relating the subjective and objective aspects of reality everywhere coincides with experience. They're the same thing described in two ways, singular, Hume, and dual, Kant. RFV, thanks again. Maybe you'll see a transition in understanding as I went down this message, I hope so. I also hope this doesn't bore you too badly. CML, I see improvement, by God. But in any event, just don't say I didn't try my best. Keep up the good work. Part 4. RFV, blue shades/mind analogy, but without this distinction, the term mental can no longer be restrictively defined. Mental might as well mean real and vice versa. And for all practical purposes, so it does. A theory T of physical reality exists as a neural and conceptual pattern in your brain, and/or mind, it's related by isomorphism to its universe U, physical reality. T, isomorphism, U. T consists of abstract ideas, U consists of supposedly concrete objects like photons, perhaps not the best examples of concrete objects. But the above argument shows that we have to drop the abstract-concrete distinction, which is just a different way of expressing the mental-real distinction. Sure, we can use these terms to distinguish the domain and range of the perceptual isomorphism, but that's as far as it goes. For all practical purposes, what is mental is real, and vice versa. The TU isomorphism seamlessly carries one predicate into the other. I'm pretty much on board here. Photons have a general abstract existence as well as a specific physical one. I'm getting the scheme here. There is an isomorphic relationship between the abstract and concrete photons, which in some very real sense leans heavily toward the abstract, since everything we know because of knowledge of the abstract version. Okay. As explained above. Or if you prefer, assume that a photon has no abstract existence. Then since ideas are abstract, it corresponds to no idea. But you know the world through ideas. So for you, a non-abstract photon has no existence. But you're discussing photons that exist. So the photon you're talking about is abstract, as well as concrete? Okay, I made that turn. No. It's a self-perceptual system with a combined abstract and concrete nature, as explained above, that possesses closure with respect to other realities. So, do you mean a conceptual model of reality which could be very different than our own reality? I think so. I see self-perceptual as a block to my acceptance here. I think you make the leap that isomorphic structures are the same structure to say that. Am I right? If so, how is that justified? CML, it's an implication of the fact that no meaningful distinction can exist between mind and reality. With respect to these two predicates, they're the same. That is, we took the isomorphism M, T, U and predicated P1 equal mental, abstract, ideic, on T and P2 equal real on U. Then we realized that no meaningful distinction exists between the predicates P1 and P2. So now we're dealing with U on an abstract basis, just as we're dealing with T on a real basis, which it is because at the very least, it exists as a real neural pattern in your real brain. Now consider an isomorphism between two distinct sets A, B consisting of 10 red golf balls each for a total of 20 distinct balls, N, A, B. Obviously, we can assign the predicate red to each set. This means that the sets are identical with respect to the predicate red. But so what? There's still a distinction between A and B, because they in fact contain different golf balls. Note that if the golf balls were electrons, it wouldn't be entirely possible to say this. Electrons to some extent share their identities. Note also that matter consists of such particles. And since red equal red just as surely as P1 equal P2 in the last paragraph, there's still a distinction between T and U, or is there? We can call the sets A and B different because the identical red golf balls of which they consist are located at different coordinates. We can ascertain this with the help of nothing but a marking pen and a tape measure. There's the meat of our distinction with respect to A and B. But are T and U located at different spatiotemporal coordinates? How can we prove it? As we've already seen, we know the universe U directly only through the abstract ideas and sensations T to which it corresponds in our minds, and that includes any sequence of measuring events we might undertake. In this sense, T and U are at the same coordinates. So to prove that T and U are actually at different coordinates, we'd have to prove that their coincidence is an illusion. But if we could do that, then we'd have the basis for distinguishing mental from real, after all, something we already know we can't do. So after a little reflection, we conclude that as it is for knowledge, so it is for measurement. The only things we can directly measure are the ideas and sensations corresponding to U, and we can only do it with an abstract tape measure at that. This, of course, is what philosophers call solipsism, but without the assumption of personal control. In a word, it's impossible to prove that the universe doesn't exist entirely inside our minds, and that all that objective reality out there isn't just some kind of subjective internal simulation. While it's true that control of the simulation seems to be distributed among many people and influences, this merely amounts to a kind of distributed solipsism, after all, an intersect of solipsistic viewpoints in one and the same metasolipsistic universe. In other words, the solipsistic abstract/concrete self of the universe distributes over all of its contents, and our own selves are just many solipsistic aspects of it. So the objective and solipsistic models are as indistinguishable as U and T, abstract and concrete, and we have to drop the distinction. And in this case, objective, isomorphism equals, abstract, subjective, identity. When we talk about T and U, we're really talking about different aspects or characterizations of the same thing. So the perceived universe and the perceiver are one, and the universe is self-perceptual. This is where reality theory meets the philosophy of mind. But that's fine, because as should by now be obvious, they need each other. RFV, real objects necessarily conform to more or less exact configurations of an abstract distributed syntax. If we form a theory of some aspect of reality, it may or may not be correct, i.e., it will be more or less exact. More or less correct. Right? Exactness is a small case in point. CML, yes. There are two kinds of truth, syntactic and semantic. Syntactic truth amounts to internal consistency, and semantic truth amounts to external isomorphism or quantification. If T is true on neither the syntactic nor semantic level of reality, then it has zero scope or content. But then the theory has no model and is not a theory in the strictest sense. At best, it's just an empty, content-free pattern of neural events or an inky set of typographical symbols on paper, with irrelevant fantasy for content. That part of a theory that's wrong is empty, but the part that's right has real content. The theory tautologically corresponds to just that part of reality for which it's true. In fact, logicians already know that insofar as they can often either extend or qualify a troubled theory so as to adjust its referential quantifier, think Lowenstein's column, Duhem Quine, etc., and thereby restore its validity, think classical physics as the low-velocity limit of relativity physics, the idea of an absolutely false theory is not what it seems. The point of all of this is that a theory can evolve, changing its form to absorb more and more real content. That's what I meant by more or less exact. Perhaps more or less correct would have been better. RFV, but even if not, we can be sure that the correct theory will conform to our mental structures, since otherwise we won't be able to create a conceptual isomorphism with it, and that's what a theory is. I have a hard time with this. An analog computer is an isomorphic structure of a screen door when it is set up to solve the screen door problem. However, a general-purpose computer is not isomorphic with a screen door when it solves the screen door problem. General structures are adaptable in a sense which allows them to accommodate an isomorphic model without themselves being limited to anything like that model. Structurally. So in what sense, and to what degree, do you insist on this conformal mapping? CML, there is a very general abstraction called logic that permits various mappings among devices and other physical contexts. Have you ever heard the term up to isomorphism? It generally refers to a relationship that contains an isomorphism, but exceeds it. Some logical abstractions permit multiple isomorphisms, and these isomorphisms may be either structural or functional or both. In the above question, you seem to be talking about these two distinct kinds of isomorphism. In any case, for computational purposes, the isomorphisms you mention are logically equivalent up to isomorphism with the screen door problem, whatever that is. The abstractions being employed by the two types of computer are always expressible in terms of the penultimate abstraction, logic. Nothing I've said so far is incompatible with this fact. RFV, a syntax is to be interpreted as any set of structural and functional constraints applied to any system. Okay, that's pretty much as I had concluded. A syntax takes the form of general information and is implemented by generalized cognition. Go easy now. Implemented by generalized cognition is a big bite. I assume that a mental awareness of the constraints on the physical model is good enough for a neophyte. Perhaps I even see a sense in which all but the generalized makes sense, but why is generalized in the phrase? CML, most people think that cognition is only done by brains. The phrase generalized cognition, actually synonymous with time, simply extends human cognition to generic information processing. It's this sense in which generic information processing obeys a cognitive syntax. Thus, time is any grammatical implementation of the SCSPL reality syntax. RFV, a photon is a configuration of the syntax of reality. Chris, you're going to have to lighten up just slightly on some of this stuff. What you appear to be saying is that a photon is properly speaking a particular instance of the general structure of reality. That isn't very informative. What do you mean here? CML, just that a photon obeys certain structural and behavioral rules, and those rules exist as constraints within the overall set of constraints called the reality syntax, including the laws of math and physics, of which our exhaustive knowledge is not assumed. These are the abstractions to which the photon primarily corresponds. Stay with it, Fred, this is all really very simple, given the unnecessary compartmentalization of physical concepts in diverse formalisms. Maybe the problem is that it seems too simple. RFV, as already explained. Then I missed it. That's assured. It's also assured that a photon is at once abstract and real. Got that? Again, the combined abstract/real nature of a photon is not provisional. You didn't treat me to be provisional about it though. CML, that a photon is both real and abstract is an absolute, non-provisional fact. However, what counts as real and abstract in any given case is a relative, or provisional, matter, and sometimes even a matter of semantic convenience. I sometimes tend to assume that my meaning is obvious when it isn't. RFV, but given from the outset. It's only the exact corresponding configuration of reality syntax that remains a mystery, and in a sense, not even that. I assume you mean that the actualities of the behavior of photons are all that is, maybe, unknown? Its place in the structure of reality is known? CML, some aspects of a photon's behavior, and corresponding details of its place in the structure of reality, are known. But the intrinsic structure of the photon, the syntax it obeys, is not known except through this behavior. You can't hold a photon under a microscope and dissect it. All you can do with any subatomic particle is collide it and monitor the resulting events. Sometimes, you get what appear to be objective subpart ICLs, but again, you can only see them through their effects. So all you can say for sure is that one configuration of SCSPL reality syntax is merely decomposing into others. Getting too hung up on objects and their innate properties has been a recurrent problem in science. One generation's particles are the subparticle interactions of the next. We need to realize that what we're dealing with are transformations of a global nomology or syntax, or to oversimplify and appeal to popular terminology, of the ultimate equation, along with the syntactic structure of the language in which it will be expressed. RFV, analog computers are as bound by 2VL as are digital computers. An analogy either exists, 1, or not, 0. All distinctions are 2VL, one thing is either distinct from another, 1, or not, 0, on a given level of definition. Since information consists of distinctions, constraints differentiating one thing from another, information is 2VL. Since theories consist of information, theories are 2VL. And since theories are isomorphic to reality, reality is 2VL. There is no escape, no crack in the stone of truth versus falsehood. Even to explain why there might be, you would be forced to resort to 2VL. And your putative exception would be embedded in 2VL by fiat. This is not very convincing to me. First of all, accepting your premise that all distinctions, knowledge, etc. are 2VL does not prove anything about reality. Ideational objects, even given the isomorphism, are not the objects themselves or exact equivalents. There are, for example, things which are not known about photons that are true of photons but not yet integrated into the ideational counterpart. So we have isomorphic structures of the reality of which we are aware and the reality we thereby presume. And we are in some sense limited such that our truths pertain to such a reality, but what about undecidability and such notions? How do these not end up being cracks in the stone? One must reason decidably about undecidability, which doesn't, thereby, prove that all things are decidable. CML, first, logical consistency equals the syntactic phase of truth. The stability, objective perceptibility, of reality implies that it's consistent, and the fact that it's consistent implies that it conforms to 2VL. Again, something either exists, 1, or does not exist, 0, so as soon as you say that it's real or that it exists, you tag it with a logical predicate, 1 equal true equal reality inclusion, that anchors it to the entire logical syntax of which this predicate is a part. Of course, we can still make a distinction about which level of reality includes this something, but whatever that level is, it obeys the distributed tautological syntax of reality, logic. Second, decidability is a logical concept whose definition is based solely on logical, syntactic, operations, namely those executed by Gödel in defining it. So you can't use it against logic without undermining its definition and thereby invalidating it. I suspect that what you might be positing is an abstraction exceeding logic and consistency, an even more general predicate. Indeed, that's the only thing your description would fit. No problem. The CTMU contains an ultimate predicate called UBT, unbound telesis. But logic is a closed tautological system, and the relationship of this pre-logical predicate to logical reality is appropriately constrained. After all, what I'm trying to tell you about is the logical structure of reality, without which it would be no reality at all. For God's sake, don't interfere. Your world could dissolve into an illogical chaos of ambiguities right before your eyes, and you're a part of it. RFV, hey, I'm 3,000 miles away. But I appreciate the invite. It was great. Andorra. It's a damned cheap vacation, all you have to do is get here. We're going to have a lot more people next year. CML, I appreciate the invite, and I'll try to make it. Just remember that I'm not retired yet, not even close, and the saloon barons who pass as my employers don't know the meaning of vacation time. And speaking of saloon barons, you apparently run one of the great salons of the 20th-21st centuries. CML, as explained in the preface, mental operations cannot be distinguished from real operations except in a provisional way. That's what I mean by a CTMU context. It's given a priori. Nor of course can they be equated in other than a provisional way. I understand now, but this need not be a CTMU context for the sense to have real meaning. CML, yes, they can be absolutely equated, because as I explained above, we ultimately can't prop up the distinction between them, distributed solipsism, remember. Therefore, it's only the distinction itself that exists in a provisional way. As far as the name's concerned, I'm the guy who's done the most to analyze reality from this angle lately, and CTMU's my name for it. But as long as we both know what we mean, that's good enough. RFV, you're talking about a generalized form of mentation, not just the mentation of a human brain. Since a photon and a brain both transform information, albeit on different levels of complexity, they are both mental in nature. In view of what follows, I need a little definition of what this generalized mentation is. Does it relate to that which takes one form of reality into another, or what? CML, any construction you place on mental above and beyond pure information processing, information transduction, state transformation, etc. is, as we observed last time around, superfluous and anthropocentric. These are what is meant by generalized mentation, what you get when you take the men out of mentation. Again, think time, the grammatical implementation of reality syntax by reality itself, i.e., reality self-processing. Remember, where abstract and real are the same, so are mind and reality, and so are human and non-human info processing, cognition, time. The logic is so simple it hurts. Human cognition, assumed to be fundamentally unique by anthropocentrists everywhere, is just the temporal processing that goes on in a brain. Of course, there may be more to it than that, and there is, but for present purposes, that's good enough. The more in question has to do with distributed solipsism, and the consequent fact that there is a sense in which sentient cognition is primary, that what goes on in reality, namely temporal processing of all kinds, really goes on in the minds of sentient observers. RFV, actually, the example of a photon is problematic for reasons too advanced to cite here. But for now, let's just say that a photon transforms the state of an atom by causing an electron to jump from one orbit to another. Even more basically, it transforms its own coordinates as it moves. Is its mentation different in this sense than a baseball going from one hand to the other? You're going to have to stretch me a little here too, I think. CML, yes. A photon is a very fundamental object that can be described as expanding at the speed of light, and then collapsing someplace on its own expanding wave front. This amounts to motion of primary type, and is how the space-time metric is created layer by layer in the Cons-pansive model, CTMU spacetime. When a baseball moves, it's moving in a much more continuous fashion through a sequence of metric domains created by Cons-pansion, as described in that noesis/ES 142 file I sent you, geomusser doc***. That's motion of secondary type. But I hope we're not getting ahead of ourselves here. RFV, due to the CTMU Cons-pansive model of spacetime, the quotation marks are necessary. Atomic states and position coordinates are informational. What we seek in any scientific context is a distributed formulation of reality that applies inside the brain as well as without it. It was rather the that applies inside within the brain as well as without it that boggled my mind. The isomorphism we developed earlier would accommodate my mentally embracing the distributed formulation, but you are implying here either that the formulation applies also to the brain, which it well may not if the formulations doesn't pertain to brains, or that the formulation can be made without a brain. The latter is what I think you mean, and I'm certainly not there yet. Allowing a level of mentation to objects does not in itself open the door to complex formulations being possible without brains. CML, I simply meant that, since the brain is embedded in space-time, or physical reality, and obeys its laws, a distributed formulation of physical laws must apply to those parts of space-time containing brains as well as those that don't. Obviously, the kind of mentation transpiring inside a brain entails the presence of the brain in the part of reality where it occurs. But because the presence of the brain is possible anywhere in space-time, since the laws governing cerebral structure and functionability are everywhere operative, that possibility is distributed. So no matter where in space-time the brain goes, it can still function. Clearly, the same applies to inanimate objects and their generalized cognition. Again, we neglect the distributed solipsistic ramifications. RFV, and although the terms mental and brain are often assumed to be associated, this need not be exclusively so. Absolutely with you here. However, that is a long ways from saying that I accept that complex formulations of reality exist outside the brain. Not that I couldn't ultimately be convinced, but am currently not. CML, again, Fred, your distinction regarding what's inside and outside the brain doesn't necessarily work for the mind corresponding to the brain. In a solipsistic model, the brain is merely the localized objective terminus of a material endomorphism, internal self-mapping, of the subjective, distributive mind. Because the mind shares the syntax of reality, and that syntax is scale invariant, or geometrically self-distributed in the sense of a hologram, its boundaries are those of the reality it perceives. But you can't fully understand this without understanding the conspansive model of space-time, in which objects literally include themselves in a spatio-temporal sense. That is, their SCSPL syntactic images, which are basically cognitive in nature and correspond to the subjective phase of their existence, temporally configure the metric in a cumulative step-by-step way by expanding through space at the common rate c, that's inner expansion, and then recollapsing to define the objective phase of their existence, that's requantization. Inner expansion and requantization correspond to coherence and decoherence of the quantum wave function. RFV, again, it goes along with the absence of an absolute distinction between the abstract, syntactic, and concrete sides of reality. This structure as transductive syntax up to isomorphism with the intrinsic structure of the transducing object. Now this I have problems with. This says that the fact, which I accept but some would doubt, that we can create an isomorphism between the universe and a mathematical model necessarily implies that the agent that can do this must have a structure isomorphic to the universe as well. That requires some very critical thought. Let me do it. Let me save you some time. The isomorphism is given on a de facto basis. Indeed, it follows from the preface. This is my big problem so far. It occurred above and now here. This is where we need to concentrate effort. I have not bought in here yet. CML, again, the syntax of the mind is that of reality as a whole, that's the distinguishing characteristic of SCSPL. The deepest, most general level of this syntax is like a hologram whose image exists everywhere within it on all scales. That's due solely to a lack of prior constraint on scale. Since the syntax is primal, no prior constraints can exist. This is a mathematical criterion, not the assumption of some big holographic crystal dangling in space. The brain partakes of this distributed holographic syntax. The technical term is hological, by virtue of its topological embedment in physical space. But through Cons-pansion, this topological embedment is computationally reciprocated by the mind corresponding to the brain. The mind, cognitively, contains the reality that, topologically, contains the brain objectively embodying the mind. Logically, this comes down to certain CTMU duality principles mentioned in that Geomusser doc file. In particular, a form of duality that can be referred to as spacetime object, wave particle, or just plain conspansive defines an alternation in which the mind solipsistically configures reality by a cumulative selective filtration of syntactic potential. During the inner expansion phase of Cons-pansion, the mind builds a set of exhaustive potential future realities by superposition, and in the requantization phase, selects a future reality in which to re-embody itself as a material brain. Just in case this conjures up some kind of bizarre brains in vats scenario, please remember that the mind, just like a photon, is regarded as a configuration of the reality syntax. Indeed, all matter behaves alike in this regard, as does the mind, so do its contents. RFV, the intrinsic syntactic, mental, structure of an object can only be inferred from its behavior, which is where a need for data enters the picture. Very definitely. But here you need an extreme amount of data, it would seem to me, and I don't know off the top of my head that I can think of what kind of data would justify such a claim. It strikes me somewhat of the I can test of 4 sigma, therefore IR1. A test would be good. In rereading yours/mine here, I have a little different picture/problem. Intrinsic syntactic means mental. I see the intrinsic form of an object as the ideal for that object, but not that object's idea of itself. Clearly the form or ideal structure of an object can only be inferred from data. But its ideational capabilities are altogether different. Here, more explanation was required. The object corresponds to a configuration of an absolute hological syntax, whether or not we or the object have data or can infer what that configuration is, or for that matter, what the hological syntax itself is. This is given by the abstract equal real or M equal R relationship. Remember, theories are made to be superseded by better theories. Easy to remember. Data can always be extended. Okay. Only tautological self-distributed systems possess certainty. The certainty or necessity of such a consistent system would indeed be very convincing, but the only here bothers me. CML, it inheres in the definition of tautology. Tautology, which denotes informational closure, exists wherever stable perception is possible. Specifically, it must exist in an embedding system of any perceptible non-tautological system precisely because the latter is stable enough to perceive. Closure is what forms the informational boundaries that distinguish and define the percepts. Unfortunately, we seldom know exactly what the embedding system is, for example, because definitive axioms are missing. This, of course, relates to undecidability, which states that axioms are always missing in logico-arithmetic systems of sufficient complexity. But the important thing to realize is that because perceptible informational boundaries exist, because the system has enough distributed structure to be coherent and self-connected, closure is given at various levels of systemic self-reference. It's an existential necessity in the mathematical sense: no informational closure, no stable perceptual invariance. To have certainty at arbitrary levels of specificity, we'd need to know all the axioms of the overall system, i.e., a full description of the global systemic tautology allowing perception. Obviously, any non-tautological subsystem is open to undecidable data and therefore uncertain. In the case of reality at large, this uncertainty, which, by the way, is associated with quantum uncertainty, owes to the fact that increasingly specific axioms are even now being created by sentient agents. That's why reality, aka SCSPL, is said to be self-configuring. That's what intrinsic cosmogony is ultimately all about. Sorry if I lost you up there, but explaining this is hard. RFV, that's why we can be so sure of the 2VL component of reality syntax. Theories generally aren't so ironclad. I still have the problem of not having accepted the ubiquitous nature of 2VL. CML, it's ubiquitous because if it weren't, we'd have a breach in the boundary between 1 and 0, true and false, which would compromise informational boundaries at all orders of predicate logic, in the abstract logical phase of reality, which implies the perceptual inconsistency of reality, which means logical collapse of the entire perceptual system. Due to the systemic ubiquity of the truth or systemic inclusion predicate, inconsistency can't be isolated in logical and perceptual systems. A hole in truth means holes everywhere. Note that undecidability relates two aspects of informational closure or perceptual stability, namely consistency, the integrity of the T/F boundary, and incompleteness, the fact that certain axioms are even now being decided and are therefore missing from our worldview. RFV, the discernibility and stable identity of objects within the universe can be shown to imply that the universe is informationally closed in the following sense: it is possible to distinguish that which it contains, reality, perceptions, from that which it does not contain, unreality. In what sense do you assume this closure encompasses completeness? Completely, I assume, but is that warranted? What possibilities are excluded by including only those forms that we currently incorporate into the isomorphism? CML, explained above. At any given point, we possess incomplete theories that are good only up to isomorphism with what we currently perceive. I.e., there's an informational boundary separating that which the universe includes from that which it excludes, and this boundary is what is closed. No closure means no boundary means no information. RFV, why would the infusion or exit of a few forms every few billion years mean that there is no information? CML, because on the basic level of this discussion, the forms of interest are syntactic invariants of perception. If any of these forms were to cross each other, the result would be perceptual inconsistency, loss of closure, and the collapse of perceptual reality, i.e., the formation of a gap between two discrete, mutually disconnected, internally consistent realities in which the contradictory perceptual invariants are isolated two mutually irrelevant parallel universes. We're only interested in the universe we inhabit. RFV, the CTMU simply pushes Kant's ideas to their logical conclusion, dealing directly with the relationship between mind and reality. I don't know that I'm ready, I'm not. But please administer the fire hose in accordance with your perception of my readiness. I know there are a couple of concepts that seem like prerequisites that we need to consider terminological deficits to be worked on as we go. CML, I've been hosing on this for hours now. I hope it helps. RFV, but a more general, and therefore more scientific. We have somewhat different definitions of scientific. Again, scientific means replicable, replicable means distributed. I buy that. And distributed means general. I don't buy this, yet. We could have a very widely distributed specific thing for which its wide distribution implies nothing but its wide distribution. CML, you seem to mean distributed in a statistical sense, something sprinkled through a pre-existing metric space. The kind of distribution we're talking about here is logical and refers to the syntax of reality itself, which obviously distributes over that which it governs, otherwise it wouldn't be where it has to be in order to do its job. Your kind of distribution is defined on the metric, mine defines it. Actually, RFV is probably talking here about the distinction between conditional and unconditional logical distribution, only the latter is really general. See below, 2 CML entries down the page. RFV, moreover, science carefully excludes false tautologies. I don't see science as excluding much at all. Early stages of science in a given field would probably include false notions. It would still be science in the fullest sense of the term, just subject to being found out later to have been wrong, but that's almost the definition, and certainly much of the value of science. CML, I simply mean that when science becomes aware of a false tautology, it breaks its back to get rid of it. RFV, or circular but non-general forms of reasoning. I see it as excluding circular arguments but definitely not non-general forms of reasoning. The ultimate scientific achievement may very well be described as you have, but not in its current state. Are we arguing different things here? CML, hoops, I meant circular but non-general forms of reasoning that pretend to generality. I sometimes tend to forget that not all scientists are seeking a theory of everything, perhaps because they run into such spectacular problems when they do. Let me explain. Once again, the scientific method entails both local distinguishability and replicability, two predicates which become opposed to each other on the syntactic level. To be universally operative or replicable, reality syntax, the laws of science, must be distributed throughout space-time, but since it is, it's not locally distinguishable. The limitations of the scientific method are those of science. But since science doesn't yet realize these limitations, it continues to seek laws with distributed, replicable, formulations by empirical, locally distinguishable, means whether the laws are general or conditional. Where the laws are indeed general, this is a logical impossibility. The only thing that can make a scientific law locally distinguishable is the presence of specific definitive conditions that are elsewhere absent. Science often ends up chasing its own tail when it tries to go too general for its objectivist limitations, as it does in fields like cosmology and consciousness. So what it seems to come down to is this: I'm talking about what science is ultimately trying to do, seek general laws that apply everywhere in space-time, while you're talking about what it actually can and does do in its current objectivist form, seek non-general laws that are nonetheless distributive in effect, or replicable under more or less specific sets of conditions anywhere in space-time. I guess I tend to view science in terms of trying to make it what it wants to be. RFV, you mentioned description, that is the key word. How are percepts best described? Data is needed here too, it seems to me. Description can here be considered synonymous with theory. I like this notion. It also flies with current philosophical presuppositions. CML, and glossaries. In most usages, the two terms are equivalent. A description lacks the mathematical structure of a theory, having no explicit axioms and rules of inference, but borrows them implicitly from the syntax and semantics of the language in which it is expressed. RFV, and thus related to perception, data, by isomorphism. You just don't let me catch up, do you? I see perception more as a dot or stroke in an impressionist painting, you tend to see it as a Rembrandt. I don't see a theory as being perceived. I see it as ultimately being understood on the basis of many, many perceptions. I guess that's what I'm doing here, forcing you to strain your theory through my sieve. CML, maybe that's a good thing for me. In the CTMU, as in Hume, reality coincides with perception, and also with its cognitive underpinnings as described by Kant. Indeed, science already effectively describes reality as a de facto blend of thought and perception, with theories using rational relationships to weld together our shared perceptions. Scientific theories can thus be regarded as common generalizations of those little impressionistic dots you mention. So when we set out to construct scientific theories, which is, after all, what we're doing here, we must first buy into the assumption that there are commonalities among our perceptions. And this isn't really a questionable assumption, because those perceptions, as opposed to our personal interpretations of them, can always be scientifically reconciled. This reflects the fact that reality is logically self-consistent, which in any case can be established by reasoning along the lines described above. RFV, if you're right, then Wheeler's title for his thesis, Observer Participation Thesis, would seem to indicate his agreement with me about what constitutes an observer, namely anything able to participate in an irreversible change. That happens also to be mine. It is a good concept that concedes what has to be conceded without selling out altogether. It also is in stark conflict with relativistic concepts. Hoops, let's stay on course here. CML, that's good. Then you're amenable to a formalism in which the universe perceives itself through the objects it contains. That's SCSPL, and that's the CTMU. RFV, this reflects the distributed subjectivism and self-processing character of reality, the fact that mind, or observership, and reality can't be absolutely distinguished. Perhaps? What I am pushing on to understand. CML, compare distributed solipsism to distributed subjectivism. RFV, it's even simpler than I put it above. Experience entails something that experiences and something that gets experienced. So if reality consists everywhere of experience, it is everywhere self-experiencing, and has everywhere the character of both mind, the subjective experiencer, and objective reality, that which gets experienced. A good notion, but I see this from my background as more of a demonstration of observer/controller equivalence duality. From absorber theory, Wheeler also, there is no significant distinction to be made between emitter and absorber. In tracking technology, the algorithm for tracking many targets to minimize uncertainty is essentially the same, an inverse, as that to situate sensors so as to maximize observability. CML, two different languages describing precisely the same thing. The main difference, my language has been developed in the direction I've been outlining, resulting in a global reality theory. RFV, so the categorical imperative relating the subjective and objective aspects of reality everywhere coincides with experience. I have always seen the duality as action/observation, both fairly closely associated with a subjective view of reality overlaying a physical level. Not worth pursuing here probably. CML, maybe so. One of the best ways to achieve understanding is to see the same things in as many different ways as possible. But remember, according to distributed solipsism, which is simply a correlate of yesterday's blue shades analogy, subjective reality overlays physical reality dualizes as physical reality overlays subjective reality. The dual viewpoints are complementary and mutually essential, and this is the point. From this duality, plus a big load of logic, the CTMU follows. RFV, I see improvement, by God. But in any event, just don't say I didn't try my best. Keep up the good work. You've done well. Please keep it up. CML, hope you like this as much. Part V. RFV, Chris, thanks for the continued help in understanding where you're coming from. It is indeed a great privilege to get such insights from the originator of a theory. I'll chop old conversation that it seems like we agree that I understand and continue on the ones where I've had difficulty. No. It's a self-perceptual system with a combined abstract and concrete nature, as explained above, that possesses closure with respect to other realities. So, do you mean a conceptual model of reality which could be very different than our own reality? I think so. I see self-perceptual as a block to my acceptance here. I think you make the leap that isomorphic structures are the same structure to say that. Am I right? If so, how is that justified? So the objective and solipsistic models are as indistinguishable as U and T, abstract and concrete, and we have to drop the distinction. And in this case, objective, isomorphism equals, abstract, subjective, identity. When we talk about T and U, we're really talking about different aspects or characterizations of the same thing. So the perceived universe and the perceiver are one, and the universe is self-perceptual. This is where reality theory meets the philosophy of mind. But that's fine, because as should by now be obvious, they need each other. RFV, your treatise was excellent. I am a bit surprised that you've never mentioned Bishop Berkeley though. I do think I understand where you are coming from on this and I would like to suspend judgment on it for the time being. There is very much a hard-nosed aspect I like in accepting what we know without wistfully assuming more. It's a quite scientific approach to my mind. However, I believe that solipsism cannot intuit distributed self, i.e., I think, therefore I am does not work for we or an amorphous ubiquitous self any more than it worked in proving the existence of God. And if one were to reject the distributed subjective aspect, it would seem to me that the feasibility of an extensive isomorphic relationship between my mind and the universe comes into serious question. CML, those unfortunates who formerly tried to prove the existence of God using solipsism, cogito ergo sum, or comparable failed because they unwittingly remained in the context of the objective, Cartesian, mind versus matter, model without correctly discarding the absolute distinction between the subjective and objective pictures of reality and availing themselves of the implications. The whole point of what has gone so far is that you can't reject the distributed solipsistic aspect. The distinction between solipsism and objectivity is ultimately imperceptible and therefore empty of content in any perceptual reality. You have to reason without the distinction when reasoning about reality, and that means that the abstract and concrete phases of reality coincide. Restoring the distinction on an a priori basis is simply unjustifiable. RFV, you have set up an analogy to the mapping between the inside and the outside of a sphere, i.e., x, 1/x, x complex. The analogy works fairly well. The problem I see is that awareness of the mapping, or creation of the mapping isn't included. That remains either a fact or not. T remains a subjective map of the objective U. How can T become the map of U and the map? That is the question. CML, where the universe is a self-similar structure whose overall characteristics are locally, endomorphically replicated everywhere within it, and that's what distributed over it means with regard to its syntax, the mapping of which you speak is just the endomorphism in question. It's inescapable and does not have to be justified in particular cases. Equivalently, your absolute distinction between what's inside and outside of a sphere is really a provisional distinction that vanishes above a certain level of abstraction. Although the interior of a particular sphere is localized within its boundary, the raw syntactic potential for being inside a sphere is distributive, because the abstract mathematical laws that characterize this state are distributive. Whereas your distinction applies with respect to the geometric interior of a particular sphere, the mind exists on a higher level of generality than that. When we talk about the laws of cognition, including those of math and physics, we're talking not merely about actual brains enclosed in actual skulls, but the abstract essence of brains, i.e. mind. Mind distributes over this entire universe, and with it, the possibility of being inside or outside a particular brain. Possibility is a generalization of actuality representing all conceivable actualizations, and this describes the reality syntax. RFV, another aspect that bothers me is the following. A theoretical basis of holography is that if one can determine the electromagnetic field throughout a window surface, one can determine the field throughout the volume on the other/either/both side, s. This is a powerful but nonetheless legitimate statement. But with it there is an extreme implied simulation capability, I guess we should have known from our screens. So, and importantly, the window itself may be all there is, it is at any rate the best place to watch for something new. The value of the window seems somewhat diminished by some of your presumptions. In fact, it seems to have paled into insignificance. If I were to develop a theory with the scope of yours, it would be centered on the window itself and the window treated as the only thing real. Did you happen to read my Working with the Given in Goff number 99? CML, I'm not making presumptions. Rather, you're presuming that there's an absolute distinction between the window and what's outside it. The holographic analogy was just that, an objective approximation of a self-contained, globally subjective, self-perceptual system whose existence we established by eliminating the empty distinction between the mental and the objective, and thus between the observer and the observed. In a so-called holographic universe, the interference pattern cast by the hologram is internally projected or simulated. As I've previously explained, the universe can be regarded as self-simulating. Reality check doc, Geomusser doc. RFV, another thing is that reality is more than what I, and I believe anyone, can mentate. There are aspects which currently defy modeling, although I do believe ultimately they will be modeled. These aspects of you find no place in T and are carried in my mind, or not, as little unmodeled chunks of data U_I. So the isomorphism must hinge on T, U_I or T plus T_I, U. And since there are so many of these chunks and the T_I are so unmentatable currently, at a minimum, the perfectness of the isomorphism is somewhat destroyed. CML, you have a limited capacity to mentate because your brain is able to explicitly replicate only a part of the reality syntax. Your cerebral neurons don't fire in explicit isomorphism to the entire syntax, but only a restricted part of it. But the overall syntax of which your own is a restriction is, as I've been trying to point out, distributed. You seem to be assuming that T exists strictly inside your head, and if T is empty of physical content, perhaps it does. But for purposes of this discussion, T equals a global distributed formulation of the reality syntax in which all aspects of you find a place. Such a formulation certainly exists whether or not we know what it is, and we don't. Specifically, it exists in the conspansive T equals 0 state in which the evolution of the universe is instantaneously realized, after we've selected it from the set of all possible evolutions and formulated a nomology to render mutually consistent the perceptions we create. At this stage, theory equals reality, M, T, U, equal T, U, equal U. One distributed ingredient of this distributed formulation that we can be sure of right now is the set of two VL tautologies, which cannot be violated with regard to perception. You'll never have a real perception that is both T and F unless you simultaneously inhabit two parallel, mutually inconsistent universes. That's just the way it is. Any two people who won't both admit that the perceptual basis of reality is 2VL have nothing to discuss. Were 2VL mistakenly acknowledged to fail for the real content of this discussion, then insofar as this discussion is taking place inside the reality being discussed, i.e., inside its own content, 2VL would inevitably fail for the discussion itself. That would make this discussion, and indeed every discussion, irresolvable. But in that event, math and science would be a useless farce, because what one of us perceives to be true, and even tautologically true, may not be acceptable to the other. RFV, yet another is the equivalence you assign to isomorphism. It's admirable to the extent of going with only what one knows, but less admirable, I believe, in possibilities of enshrining error. CML, as I've already explained, any isomorphism to whose range and domain you can't assign different qualitative or quantitative coordinates at a given level of discourse is really an identity relation, at that level. In that case, the range and domain differ only as coincident aspects of one and the same reality. You're still talking about T being essentially different from U, even though we've shown that at a sufficiently high level of content for T, T equal U. Again, T is in this case the reality syntax, the mathematical and physical laws that the universe obeys everywhere, and objective reality, U, is merely the variegated actualized content of that distributed form. For example, the law of conservation of momentum, and its underlying arithmetic, is everywhere valid, but only active and perceptible in the presence of actual moving bodies. Similarly, physical reality is merely an evolving set of instantiations of a set of relations that are everywhere valid. These instantiations are metrically separated, but the metric itself is completely characterized by a distributed form that exists in every part of space that could ever be occupied by your brain, even if your brain has only managed to figure a little bit of it out by firing isomorphically to it. The distribution of this form throughout space distributes your mind over reality in the form of general mental syntax. RFV, those are my reservations, but I understand what you have said, appreciate it, and it will ride with me, perhaps ultimately persuading me. You may continue hammering on this or accept this limited conversion as you see fit. I do enjoy the dialogues on the subject. CML, as do I. It helps me understand where the rough spots are, and encourages me to find ways to get past them. I think one of the problems so far is that you haven't really absorbed the fact that the distinction between mental, abstract, and objective, concrete physical, reality is a stratified distinction that gradually disappears as we approach the top stratum, global distribution. Less general, more conditional features of reality appear to be localized within their specific instantiations, permitting internal-external distinctions. In this sense, cognitive, or computational, distribution relations are equivalent to topological inclusion relations. That's a CTMU duality principle. If distribution is general or unconditional, on the other hand, it applies to all things, and the distinctions among these things exist within it in the sense that it resembles a self-executing program instruction that internally simulates them. In other words, general features of simulative spacetime include specific aspects as output, which is then uploaded to spacetime as further programming, and so on. Topological inclusion follows from computational inclusion because topology is computationally simulated. Real objects necessarily conform to more or less exact configurations of an abstract distributed syntax. If we form a theory of some aspect of reality, it may or may not be correct, i.e., it will be more or less exact. More or less correct. Right? Exactness is a small case in point? Yes. There are two kinds of truth, syntactic and semantic. Syntactic truth amounts to internal consistency, and semantic truth amounts to external isomorphism or quantification. If T is true on neither the syntactic nor semantic level of reality, then it has zero scope or content. But then the theory has no model and is not a theory in the strictest sense. At best, it's just an empty, content-free pattern of neural events or an inky set of typographical symbols on paper, with irrelevant fantasy for content. RFV, but such things may become the eureka source next week. Is the entire universe reborn in that case? CML, if T has no model, then it has no real content, and in that case, eureka becomes eureka. Now, maybe its apparent lack of content is only temporary because we're misinterpreting it, which means that we haven't accurately identified its constituent concepts, or perhaps the only thing that prevents it from having all kinds of real content is one little piece or two that we'll eventually recognize as unnecessary and discard, leaving a big pile of eureka material. But then the part of the theory that is found to be correct will have possessed real content all along. I.e., the content of a theory is not necessarily dependent on what we recognize it to be at any point in time. That part of a theory that's wrong is empty, but the part that's right has real content. RFV, the wrong part of a theory may be the handle of its replacement and thence the most real aspect of it. CML, as my last entry acknowledges. The theory tautologically corresponds to just that part of reality for which it's true. In fact, logicians already know that insofar as they can often either extend or qualify a troubled theory so as to adjust its referential quantifier, think Lowenheim-Scullum, Duhem-Quine, etc., and thereby restore its validity, think classical physics as the low-velocity limit of relativity physics, the idea of an absolutely false theory is not what it seems. RFV, I'm not sure I fully understand the last part of this last sentence. It may, of course, be that I didn't understand the first part or the sentences that preceded it. Would you please try to explain this to me? It's interesting. CML, the falsifiability criterion of scientific theories is rather tricky. If you have a theory that all cats are gray, including a reason for that prediction, it's falsifiable only in that part of the universe containing non-gray cats. And even after it's been falsified, we can still resurrect it in that part of the universe where all cats are gray and your reason applies. All we have to do is create an extension of your theory that applies to the rest of the universe. Once your theory has been embedded in a correct overall theory, one can no longer say it's been falsified. It simply applies to a smaller part of the universe than originally intended, and is quite true for that part. In addition, once we do away with Occam's razor, every interpretation of a theory becomes a theory in its own right, each of them as correct as the next. And even worse, every possible unverifiable, and thus unfalsifiable, extension of theoretical content screams for airtime, all kinds of true but bizarre and mutually contradictory theories raising their ugly heads for keeps. Most telling of all, there are two kinds of falsifiability, rational and empirical. The former kind is employed in rejecting erroneous mathematical proofs and even mathematical theories of physics, the latter, in rejecting physical theories. A true logical or mathematical theory is not empirically falsifiable, and neither is the 2VL logical syntax validating the falsification process itself. The syntax is literally tautological. The point of all of this is that a theory can evolve, changing its form to absorb more and more real content. That's what I meant by more or less exact. Perhaps more or less correct would have been better. RFV, yeah, okay. That's what I thought, but in the explanation I got some interesting understandings. This does put my notion of the U_I into a dismal light, and I don't exactly know what to do about that. I think I'll leave it as a record of my discontents along the way. But even if not, we can be sure that the correct theory will conform to our mental structures, since otherwise we won't be able to create a conceptual isomorphism with it, and that's what a theory is. I have a hard time with this. An analog computer is an isomorphic structure of a screen door when it is set up to solve the screen door problem. However, a general-purpose computer is not isomorphic with a screen door when it solves the screen door problem. General structures are adaptable in a sense which allows them to accommodate an isomorphic model without themselves being limited to anything like that model structurally. So in what sense, and to what degree, do you insist on this conformal mapping? There is a very general abstraction called logic that permits various mappings among devices and other physical contexts. Have you ever heard the term up to isomorphism? It generally refers to a relationship that contains an isomorphism, but exceeds it. Some logical abstractions permit multiple isomorphisms, and these isomorphisms may be either structural or functional or both. In the above question, you seem to be talking about these two distinct kinds of isomorphism. Indeed. More or less as levels of isomorphism? But, if one allows levels or degrees, then isomorphism can certainly not mean equivalence, nor does it. Then to substitute equivalence seems unwarranted without being able to demonstrate isomorphism at all levels. CML, isomorphism always denotes equivalence with respect to two triangles of the exact same size and shape are isomorphic with respect to structure, but if one's red and one's colorless, the isomorphism holds only with respect to geometry and gives out with respect to color. Were one triangle to have more structure than the other, homomorphism would be the best we could do, but since color is independent of, and in fact irrelevant to, geometry, isomorphism holds. It's just that for the colorless triangle, including color in the isomorphism doesn't even make sense. So the triangles have equivalent structures but differ in aspects like color and location. On the other hand, perfect isomorphism with respect to all predicates describing two objects means not just equivalence, but identity. In any case, for computational purposes, the isomorphisms you mention are logically equivalent up to isomorphism with the screen door problem, whatever that is. RFV, the problem is to determine the angle of a screen door that has a spring and dash pot. Its solution is that of a simple differential equation. In an analog computer there is a resistor whose resistance is scaled to the resistance in the dash pot on the door, the inductance to the spring constant, etc., and the current in the electric circuit is related in the same way to the angle of the door. It's all one-to-one. In a GP computer, of course, the analogies become much less obvious in the sense of there not being a continuous nor continual solution, i.e., it doesn't hardly map at all. In a digital differential analyzer, the physical structural analogy of components is maintained with digital registers and the flow of overflow bits becomes an analogy for the current/angle. Just a side tidbit. The abstractions being employed by the two types of computer are always expressible in terms of the penultimate abstraction, logic. Nothing I've said so far is incompatible with this fact. First of all, it is in a very obscure sense that one can say an analog version is implemented in logic because it isn't any more than an electric current is logic. Secondly, you seem to be implying that logic is a structural level of the brain, maybe that's where 2VL comes in. But I don't think so. I believe logic in the sense of an or not and implies is an acquired capability of the mind superimposed many layers above the structure of the mind. I don't believe we are primarily a logic machine. We are pieces of you, conceivably capable of implementing limited complexity logic circuits. CML, the brain is indeed a logic device, a neural network, but this is hidden by the fact that it employs logic to construct modes of activity that are apparently illogical in character. Electric currents are logical in essence as well, obeying a 2VL theory of electromagnetic interactions whose statements and their negations are T and F respectively. The M currents behave isomorphically to the theory, and the theory behaves isomorphically to the logic inherent in its structure. Every non-logical predicate in the theory is in fact embedded in one or more logical variables or relations, just like a seed is embedded in an apple. M current is logic because insofar as it behaves coherently enough to conform to a theory, it must coincide with something that permits it to do so. Whatever that something is, it obviously includes logic, since if it didn't, the current could not behave in a coherent way or even maintain its existence equal T, as opposed to non-existence equal F. The mistake is to underestimate the tendency of logic, often disguised by other elements of reality syntax which are themselves logical in form, to naturally assemble itself into seemingly illogical configurations and processes. RFV, at this point I'm going to repeat your original sentence from above. But even if not, we can be sure that the correct theory will conform to our mental structures, since otherwise we won't be able to create a conceptual isomorphism with it, and that's what a theory is. There is a sense in which M, T for any possible T. Of course there are probably even existing theories that have not yet been completely comprehended, M, T, although already formulated, T, in which case you seem to be content with M, T, being what a theory is. And there is definitely a sense in which T, U, and you seem to be content with T, U, being you, because if there were more known of you it would be in T, U. I think what I feel certain of at this point is U. CML, theories consist of abstract relationships. To whatever extent they are correct, i.e. apply to some part of reality, they coincide with that part. Why? Because the abstractions that correctly describe a part of objective reality, whether or not you are aware of the actual correspondence, are exactly the ones that are indistinguishable from its concrete components, as in the blue shades analogy of yore. A syntax takes the form of general information and is implemented by generalized cognition. RFV, whoa. Chris, you've got to start me all over on this one. I thought I was about through the original sentence. I think I buy the original sentence with the extension of generalized cognition within my limitations expressed above. But the phrase generalized cognition, actually synonymous with time. How in hell did we get here? I take a synonym to mean that a dictionary can help me, but it doesn't here. CML, all you need is your memory, because we've already been through this. The operative analogy is time, space, cognition, information. I.e., time equal info processing equal generalized cognition, where information here refers to the abstract dimensions of real objects and processes, which, as we've already seen, coincide with them. Simply extends human cognition to generic information processing. RFV, how does /can time perform this function? CML, time is not a thing, it's a function of space-time. Space-time performs this function because it's full of syntax, and some of this syntax is grammatical as opposed to structural. Grammar governs the evolution or state transition of the language of reality. It's this sense in which generic information processing obeys a cognitive syntax. RFV, I was left on the other side of the river on this one. Help. CML, see my last entry above. Thus, time is any grammatical implementation of the SCSPL reality syntax. RFV, I think we have to hold off on SCSPL a little longer. A photon is a configuration of the syntax of reality. Chris, you're going to have to lighten up just slightly on some of this stuff. What you appear to be saying is that a photon is properly speaking a particular instance of the general structure of reality. That isn't very informative. What do you mean here? Just that a photon obeys certain structural and behavioral rules, and those rules exist as constraints within the overall set of constraints called the reality syntax, including the laws of math and physics, of which our exhaustive knowledge is not assumed. These are the abstractions to which the photon primarily corresponds. Stay with it, Fred, this is all really very simple, given the unnecessary compartmentalization of physical concepts in diverse formalisms. Maybe the problem is that it seems too simple. RFV, this part I have gotten largely because of your patience, so stay with me. That a photon is both real and abstract is an absolute, non-provisional fact. However, what counts as real and abstract in any given case is a relative, or provisional, matter, and sometimes even a matter of semantic convenience. I sometimes tend to assume that my meaning is obvious when it isn't. RFV, this was very clear. But given from the outset, it's only the exact corresponding configuration of reality syntax that remains a mystery, and in a sense, not even that. I assume you mean that the actualities of the behavior of photons are all that is, maybe, unknown? Its place in the structure of reality is known? Some aspects of a photon's behavior, and corresponding details of its place in the structure of reality, are known. But the intrinsic structure of the photon, the syntax it obeys, is not known except through this behavior. You can't hold a photon under a microscope and dissect it, all you can do with any subatomic particle is collide it and monitor the resulting events. Sometimes, you get what appear to be objective subpart ICLs, but again, you can only see them through their effects. So all you can say for sure is that one configuration of SCSPL reality syntax is merely decomposing into others. Getting too hung up on objects and their innate properties has been a recurrent problem in science. One generation's particles are the subparticle interactions of the next. RFV, other than the reference to SCSPL, which I'm deferring, I think I Understand this and certainly agree with it. We need to realize that what we're dealing with are transformations of a global nomology or syntax, or to oversimplify and appeal to popular terminology, of the TO. Theory of everything. CML, yes. The TO is envisioned as a master equation governing all of reality, a condensation of all the laws of physics. Ultimate equation, along with the syntactic structure of the language in which it will be expressed. RFV, I see where you're coming from, but slipping the word nomology in there was a dirty trick, because that's the part I'm having trouble accepting. CML, nomology refers to the abstractions governing the evolution of reality. It's inherent in space-time. There is no assumption that we can ever do more than approximate it in any human theory. All we know about nomology is that it is what connects events, and is what affects the consistency of our perceptions. Nomology must exist up to determinacy, or its absence would show up in the form of irresolvable perceptual paradox. A distributed abstract nomology to which perceptual reality must conform ensures the resolvability of paradox, which is just a way of saying the self-consistency of reality. Analog computers are as bound by 2VL as are digital computers. An analogy either exists, 1, or not, 0. RFV, but that analogy is not performed by the analog computer, so I still don't see where you get that such a computer is 2VL. The use of its results may involve 2VL, but its operation doesn't. CML, without 2VL, it would have no coherent results. All distinctions are 2VL. RFV, it doesn't make distinctions. CML, yes it does. It distinguishes between what it is and what it isn't, and how it must behave and how it must not behave. These distinctions are encoded in the space-time it occupies. One thing is either distinct from another, 1, or not, 0, on a given level of definition. RFV, is an electron in a circuit of my computer distinct from one in yours? I think yes. Is an electron in an adder circuit in my computer distinct from one in my instruction register circuit? Is an electron in a circuit distinct from another bound electron in a copper atom of the wire through which the electron travels at that moment? Is it distinct from adjacent band electrons in the flow? Distinctions get a bit fuzzy. CML, our respective electrons are distinct images of a single distributed syntactic photon consisting of the rules that all photons must obey regardless of where they are. The images reside in different locations, and these differences are significant. But it's like Wheeler said to Feynman, they're all one photon. Since information consists of distinctions, constraints differentiating one thing from another, information is 2VL. Since theories consist of information, theories are 2VL. RFV, I can accept Whitehead and Russell on that. And since theories are isomorphic to reality, reality is 2VL. Where I'm at, you've just convinced me that M, T, U, is 2VL. There is no escape, no crack in the stone of truth versus falsehood. Even to explain why there might be, you would be forced to resort to 2VL. And your putative exception would be embedded in 2VL by fiat. That's certainly true for M, T, U. CML, great. Because the isomorphism M is a perfect equivalence relation with respect to everything but degree of generality, the abstract is more general than the concrete because one abstraction can possess many concrete actualizations. So M is an equivalence relation between T and U up to isomorphism, i.e., up to exhaustion of the structure of U. This is not very convincing to me. First of all, accepting your premise that all distinctions, knowledge, etc. are 2VL does not prove anything about reality. Ideational objects, even given the isomorphism, are not the objects themselves or exact equivalents. There are, for example, things which are not known about photons that are true of photons but not yet integrated into the ideational counterpart. So we have isomorphic structures of the reality of which we are aware and the reality we thereby presume. And we are in some sense limited such that our truths pertain to such a reality, but what about undecidability and such notions? How do these not end up being cracks in the stone? One must reason decidably about undecidability which doesn't, thereby, prove that all things are decidable. First, Logical consistency equals the syntactic phase of truth. RFV, I buy this except that I'd mellow out truth just a little to something like correctness or verifiability. CML, no, the syntactic phase of truth equals consistency. That's what the predicate true means with respect to syntax. The stability, objective perceptibility, of reality implies that it's consistent. RFV, persistent at least. Perhaps one could argue from persistence in U to consistency in T, U. CML, yes, one could. As T converges on the reality syntax, U and T, U, become coincident. And the fact that it's consistent implies that it conforms to 2VL. RFV, I think there's a logic hop here I didn't make. An analog computer's solution is persistent but is not thereby, in my opinion, 2VL. CML, see above. Consistency is a 2VL concept synonymous with the tautologies, T or F, and not, T and F. Since reality by definition contains all truths, otherwise, they wouldn't be true, its consistency implies that it contains no falsehood, since such a falsehood would contradict the truth corresponding to its negation. So consistent means true means included in existential reality. Again, something either exists, 1, or does not exist, 0, so as soon as you say that it's real or that it exists, you tag it with a logical predicate, 1 equal true equal reality inclusion, that anchors it to the entire logical syntax of which this predicate is a part. RFV, I totally disagree here. Saying that something exists adds nothing of logical import to a concept in this context. Do the true, 1, statements, mastodons do not exist, 1/0, and unicorns do not exist, 1/0, imply the same level of non-reality, 0? If existence is 2VL, it should. CML, exists equal is included in an existential system, which implies is, at least, included in, the most basic existential level of reality, which implies is consistent with the rest of reality, which equals the syntactic phase of truth. Now, T and F only become contradictory when they coincide in some actuality. Fortunately, mastodons do not exist need never coincide with mastodons exist in any actual context. That is, mastodons do not exist can be interpreted over a range of actual times for which it is true. On the other hand, unicorns do not exist can be interpreted over an even larger real context, and to that extent is quantifiably truer in a concrete context. Of course, we can still make a distinction about which level of reality includes this something, but whatever that level is, it obeys the distributed tautological syntax of reality, logic. RFV, granted you can probably escape the former argument with a defined level of reality. But more importantly, an electric field is not defined in terms of whether it exists or not. It is more, given X, then Y, such that existence becomes very much a side issue in T at least, and there may be hidden parameters P_I in a theory for which not everyone envisions a counterpart in U. So the existence of P_I in T leaves its existence in U, and therefore at all, quite up in the air. CML, if relevant, the parameters P_I are, at the very least, permissible transformations of reality syntax that may be realized in physical reality. Color force among quarks is a pretty weird parameter that has theoretic utility, but can't yet be empirically established. The configuration of syntax we're currently working with won't actively display it. But one day we may contrive to force a transformation of syntax that does. Moreover, this transformation will itself be governed by the syntax that is transformed. I.e., the syntax is autologous. Second, decidability is a logical concept whose definition is based solely on logical, syntactic, operations, namely those executed by Gödel in defining it. So you can't use it against logic without undermining its definition and thereby invalidating it. RFV, I am not very enthused about Gödel's destruction of _Principia M_ myself, and I'm somewhat interested tangentially in your statement here. I suspect that what you might be positing is an abstraction exceeding logic and consistency, an even more general predicate. No. But thanks for thinking so highly of me. Indeed, that's the only thing your description would fit. No problem, the CTMU contains an ultimate predicate called UBT, unbound telesis. But logic is a closed tautological system, and the relationship of this pre-logical predicate to logical reality is appropriately constrained. Woe again! If I'm going to stay in this monastery, you have to go slow. CML, information consists of distinctions in which one thing is syntactically constrained to differ from another. Because concrete reality mirrors the abstract information coinciding with it, it too can be regarded as information, we're information too, and the reason all this info seems concrete is that there's a syntactic displacement principle in effect. So the question arises, what does this information become when all the binding constraints are removed? The answer is unbound telesis or UBT, the ground state of being. This universe has only arisen within the UBT ground state because it has constrained itself to do so. This is the sense in which it's self-configuring. After all, what I'm trying to tell you about is the logical structure of reality, without which it would be no reality at all. For God's sake, don't interfere. Your world could dissolve into an illogical chaos of ambiguities right before your eyes, and you're a part of it. RFV, it has. It has. But I'm feeling better. Please don't do that to me again. Employers don't know the meaning of vacation time. And speaking of saloon barons, you apparently run one of the great salons of the 20th-21st centuries. Slipping logic by me is one thing, but when someone tries to get humor by me, I have a hard time with it. What on earth do you mean? CML, the salons of the nobility used to be the most lively, scintillating conversational settings in the world. Salon baron salon baron. As explained in the preface, mental operations cannot be distinguished from real operations except in a provisional way. That's what I mean by a CTMU context. It's given a priori. Nor of course can they be equated in other than a provisional way. I understand now, but this need not be a CTMU context for the sense to have real meaning. Yes, they can be absolutely equated, because as I explained above, we ultimately can prop up the distinction between them, distributed solipsism, remember? RFV, yes, but you must remember that you left me back there on the peg labeled M, T, U. Not really, at least when T converges on reality syntax. In view of what follows, I need a little definition of what this generalized mentation is. Does it relate to that which takes one form of reality into another, or what? Any construction you place on mental above and beyond pure information processing, information transduction, state transformation, etc. is, as we observed last time around, superfluous and anthropocentric. RFV, let me backslide just for a little reverie here. What about likes, is that a construction on mental? I think so. So if it isn't carried into generalized mentation, where is it? Okay, so it's anthropocentric, so what? Do we then have M, A, T, U? CML, no, what we have is a component of the cognitive syntax called ETS, short for emotelic subsyntax. The emotions are subjective predicates like qualia, special subsyntaxes are reserved for the predicates in these groups. But the relationships of these predicates with other syntactic elements are logical in nature. Enough on that for now. These are what is meant by generalized mentation, what you get when you take the men out of mentation. RFV, sometimes your technique reminds me of men of God in my past. CML, against my better judgment, I'll take that as a compliment. Again, think time, the grammatical implementation of reality syntax by reality itself, i.e., reality self-processing. RFV, Chris. I'm not ready for baptism. This is only my second lesson, for God's sake. CML, that's okay, we've been through it at least twice up there. Remember, where abstract and real are the same, so are mind and reality, and so are human and non-human info processing. RFV, got it. Cognition, time. Don't got it. CML, that's okay, we've been through it at least thrice up there. The logic is so simple it hurts. RFV, I know, but I still ain't got it. CML, that's okay, we've been through it at least force up there. Human cognition, assumed to be fundamentally unique by anthropocentrists everywhere, is just the temporal processing that goes on in a brain. Of course, there may be more to it than that, and there is, but for present purposes, that's good enough. The more in question has to do with distributed solipsism, and the consequent fact that there is a sense in which sentient cognition is primary, that what goes on in reality, namely temporal processing of all kinds, really goes on in the minds of sentient observers. RFV, this soothes my mind, but all of this is not just time. CML, sure it is. It's the refined kind of time that passes in a brain. Yes. A photon is a very fundamental object that can be described as expanding at the speed of light, and then collapsing someplace on its own expanding wave front. This amounts to motion of primary type, and is how the space-time metric is created layer by layer in the Cons-pansive model, CTMU spacetime. When a baseball moves, it's moving in a much more continuous fashion through a sequence of metric domains created by Cons-pansion, as described in that Noesis/ES 142 file I sent you, GMUSR doc. RFV, if that was more than a brief page or two of text, I'm quite sure I did not get it or get it. CML, resent and acknowledged. That's motion of secondary type. But I hope we're not getting ahead of ourselves here. RFV, I think we may well be. However, that is a long ways from saying that I accept that complex formulations of reality exist outside the brain. Not that I couldn't ultimately be convinced, but am currently not. Again, Fred, your distinction regarding what's inside and outside the brain doesn't necessarily work for the mind corresponding to the brain. In a solipsistic model, the brain is merely the localized objective terminus of a material endomorphism, internal self-mapping, of the subjective, distributive mind. Because the mind shares the syntax of reality, and that syntax is scale invariant, or geometrically self-distributed in the sense of a hologram, its boundaries are those of the reality it perceives. But you can't fully understand this without understanding the Cons-pansive model of space-time. You're right. I'm not there yet. In which objects literally include themselves in a spatio-temporal sense. That is, they're SCSPL syntactic images, which are basically cognitive in nature and correspond to the subjective phase of their existence, temporally configure the metric in a cumulative step-by-step way by expanding through space at the common rate c, that's inner expansion, and then recollapsing to define the objective phase of their existence, that's requantization. Inner expansion and requantization correspond to coherence and decoherence of the quantum wave function. This part looks interesting but so far from the outside. Let me save you some time. The isomorphism is given on a de facto basis. Indeed, it follows from the preface. This is my big problem so far. It occurred above and now here. This is where we need to concentrate effort. I have not bought in here yet. Again, the syntax of the mind is that of reality as a whole, that's the distinguishing characteristic of SCSPL. Even ignoring SCSPL for the present, this equivalence from isomorphism of T to U is still a difficulty in as much as I have only accepted M, T, U, U, and now I must accept that U, T, M, M. I don't know. CML, again, where T stands for the distributed reality syntax, or ultimate theory, M, to, and the isomorphism M collapses because you can't keep the abstract and concrete sides of reality out of coincidence up to U isomorphism, due to the blue shades analogy, M, T, U, equal U. The deepest, most general level of this syntax is like a hologram whose image exists everywhere within it on all scales. That's due solely to a lack of prior constraint on scale, since the syntax is primal, no prior constraints can exist. This is a mathematical criterion, not the assumption of some big holographic crystal dangling in our space. RFV, yes, but saying the syntax is primal does not make it so. CML, no, but describing it as such certainly does, provided that description is embedded in the kind of model we've been talking about. After all, if syntax isn't primal, then the process of its creation required a more basic level of syntax that was primal. That's what Hawking is saying, in effect. Without dealing with the logic, you ultimately have to deal with reality on a primal level on which its syntax, or nomology, is self-configuring. His no-boundary proposal states that the universe is nomologically self-contained, the laws of physics guiding creation itself. The CTMU is just a more logical treatment of that existential necessity. The brain partakes of this distributed holographic syntax. The technical term is hological, by virtue of its topological embedment in physical space. But through Cons-pansion, this topological embedment is computationally reciprocated by the mind corresponding to the brain. The mind, cognitively, contains the reality that, topologically, contains the brain objectively embodying the mind. RFV, Logically, this comes down to certain CTMU duality principles mentioned in that GMUSR doc file. Evidently I need it. In particular, a form of duality that can be referred to as spacetime object, wave particle, or just plain conspansive defines an alternation in which the mind solipsistically configures reality by a cumulative selective filtration of syntactic potential. During the inner expansion phase of conspansion, the mind builds a set of exhaustive potential future realities by superposition, and in the requantization phase, selects a future reality in which to re-embody itself as a material brain. Just in case this conjures up some kind of bizarre brains in vats scenario, please remember that the mind, just like a photon, is regarded as a configuration of the reality syntax. Indeed, all matter behaves alike in this regard, as does the mind, so do its contents. You have really gone too far too fast for me. Let's get me over the two big hurdles first. Only tautological self-distributed systems possess certainty. The certainty or necessity of such a consistent system would indeed be very convincing, but the only here bothers me. It inheres in the definition of tautology. Tautology, which denotes informational closure, exists wherever stable perception is possible. Is that last obvious to you? It isn't to me. Why is it obvious? CML, because truth is identified with tautology in 2VL, which is a necessary framework of the reality syntax. Otherwise, you could not distinguish which perceptions are real, T, and exclude those which are not, F. I keep explaining this point. Specifically, it must exist in an embedding system of any perceptible non-tautological system precisely because the latter is stable enough to perceive. RFV, we've gone from a perceptible system to one that perceives without even an argument. CML, hypothesis, the universe is a piece of self-executing, self-recognizing, self-processing code. The universe must configure itself so as to interpret its syntax in situ. Proof: there is no external hardware on which reality can run, and no external programmer/executor/recognizer to keep it in touch with itself and running. So the universe must provide its own recognizer, i.e. perceive itself. Now suppose there's a separation between recognizer and syntax. Then the syntax can't recognize its own parts to remain connected, and there must be a remote feedback loop within the U enforcing syntactic coherence. But then how do the components of this loop recognize each other so as to remain connected, and how is the info conveyed by this loop enforced on either end of the loop? This leads to a buck-passing regress in which the remote enforcement of coherence must ultimately close on a level of syntax that is distributive and completely self-recognizing. And since any lesser syntax must be embedded in it, its distributed self-recognition function continues to apply. Closure is what forms the informational boundaries that distinguish and define the percepts. RFV, you seem to be saying that that which is perceptible ipso facto perceives. CML, see last entry. Unfortunately, we seldom know exactly what the embedding system is, for example, because definitive axioms are missing. This, of course, relates to undecidability, which states that axioms are always missing in logico-arithmetic systems of sufficient complexity. But the important thing to realize is that because perceptible informational boundaries exist, because the system has enough distributed structure to be coherent and self-connected, closure is given at various levels of systemic self-reference. It's an existential necessity in the mathematical sense, no informational closure, no stable perceptual invariance. RFV, this looks like a place where the basis of holography, i.e., fields on a boundary could be used in the argument, but I can't put it together and make it work as you envision it. CML, that's because you still aren't imagining the hologram as a self-contained entity. To have certainty at arbitrary levels of specificity, we'd need to know all the axioms of the overall system, i.e., a full description of the global systemic tautology allowing perception. Obviously, any non-tautological subsystem is open to undecidable data and therefore uncertain. In the case of reality at large, this uncertainty, which, by the way, is associated with quantum uncertainty, owes to the fact that increasingly specific axioms are even now being created by sentient agents. That's why reality, aka SCSPL, is said to be self-configuring. That's what intrinsic cosmogony is ultimately all about. RFV? CML, that should read open to undecidable perception for which a T or F distinction can't be made due to the absence of a tautologically defined truth predicate. Sorry if I lost you up there, but explaining this is hard. RFV, yeah. Jesus, if I ever get this, I hope I don't become a CTMU Bible thumper. It could be worse than being a Jehovah's Witness. CML, especially if you're trying to explain it to people who know nothing about the subject matter, or for that matter logic. I still have the problem of not having accepted the ubiquitous nature of 2VL. It's ubiquitous because if it weren't, we'd have a breach in the boundary between 1 and 0, true and false, which would compromise informational boundaries at all orders of predicate logic, in the abstract logical phase of reality, which implies the perceptual inconsistency of reality, which means logical collapse of the entire perceptual system, due to the systemic ubiquity of the truth or systemic inclusion predicate. Inconsistency can't be isolated in logical and perceptual systems. A whole in truth means holes everywhere. Note that undecidability relates two elements of informational closure or perceptual stability, namely consistency, the integrity of the T/F boundary, and completeness, the fact that certain axioms are even now being decided and are therefore missing from our worldview. RFV, Chris, all I get from this is that if I don't accept it, I may be sicker than a dog for another 2 days. CML, yes, by punitive decree of that big logician in the sky. Why would the infusion or exit of a few forms every few billion years mean that there is no information? Because on the basic level of this discussion, the forms of interest are syntactic invariants of perception. If any of these forms were to cross each other, the result would be perceptual inconsistency, loss of closure, and the collapse of perceptual reality, i.e., the formation of a gap between two discrete, mutually disconnected, internally consistent realities in which the inconsistent perceptual invariants are isolated to mutually irrelevant parallel universes. We're only interested in the universe we inhabit. RFV? CML, two conflicting elements of perceptual syntax operating in your mind would by definition produce conflicting perceptions between which there exists an irresolvable paradox. But your own personal helping of 2VL logical syntax will filter that out of your perception. So no such conflict can exist. That's 2VL tautology put into perceptual practice. I already explained why 2VL is an essential ingredient of perceptual syntax. I don't know that I'm ready, I'm not. But please administer the fire hose in accordance with your perception of my readiness. I know. There are a couple of concepts that seem like prerequisites that we need to consider terminological deficits to be worked on as we go. I've been hosing on this for hours now. I hope it helps. RFV, Jesus, I'm glad to hear you say that because it's been coming out my nose, my ears, and eyes for hours. I was afraid you weren't even getting up a sweat. I think we need to cut down the pressure just a little, but proceed as you perceive I'm able to gobble this. Maybe your perceptions will somehow make a perceptible change in my mental state. And distributed means general. I don't buy this, yet. We could have a very widely distributed specific thing for which its wide distribution implies nothing but its wide distribution. You seem to mean distributed in a statistical sense, something sprinkled through a pre-existing metric space. The kind of distribution we're talking about here is logical and refers to the syntax of reality itself, which obviously distributes over that which it governs, otherwise it wouldn't be where it has to be in order to do its job. Your kind of distribution is defined on the metric, mine defines it. RFV, here's a fruitful patch for more picking, I think. A little more on your definition of distributed might stand me in good stead. CML, distributed means without constraint on location. For example, when we say that multiplication distributes over addition in an expression like a, b plus c, we mean that the multiplier, a, is active everywhere in the parentheses, b and c, without constraint. Distribution has slightly different meanings with respect to the actual and potential phases of reality. With regard to the actual, conditions are constraints on location, so saying that something distributes conditionally means that it distributes only where the condition is actually present. When we say that the global reality syntax distributes over reality in an actual context, we mean that it distributes to conditional and unconditional extents according to the quantifiers of its elements and the metric distribution of instantiations. But the situation is different with respect to potentiality, insofar as it is possible in principle for any set of conditions to exist at any location. We can say that even conditional elements of syntax are globally distributed. When we say or imply that the entire reality syntax distributes over all of reality, we mean that the potential for any set of conditions to be actualized exists everywhere. Note that any law L that distributes only where a set of conditions A, B, C, is actually present can be globally distributed by reformulating it like this, where A, B, C, L. This formulation applies everywhere because it is formulated in a meta-language of L in which the conditions A, B, C, may or may not be present. Oops, I meant circular but non-general forms of reasoning that pretend to generality. I sometimes tend to forget that not all scientists are seeking a theory of everything, perhaps because they run into such spectacular problems when they do. Let me explain. RFV, good. And yes, I am one of those extremely skeptical of theories of everything, not because I don't think that is desirable or achievable, but because I believe it is not scientific to leapfrog the scientific process. Once again, the scientific method entails both local distinguishability and replicability, two predicates which become opposed to each other on the syntactic level. To be universally operative or replicable, reality syntax, the laws of science, must be distributed throughout space-time, but since it is, it's not locally distinguishable. The limitations of the scientific method are those of science. But since science doesn't yet realize these limitations, it continues to seek laws with distributed, replicable, formulations by empirical, locally distinguishable, means whether the laws are general or conditional. Where the laws are indeed general, this is a logical impossibility. The only thing that can make a scientific law locally distinguishable is the presence of specific definitive conditions that are elsewhere absent. Science often ends up chasing its own tail when it tries to go too general for its objectivist limitations, as it does in fields like cosmology and consciousness. So what it seems to come down to is this: I'm talking about what science is ultimately trying to do, seek general laws that apply everywhere or at least anywhere in space-time, while you're talking about what it actually can and does do in its current objectivist form, seek non-general laws that are nonetheless distributive in effect, or replicable under more or less specific sets of conditions anywhere in space-time. I guess I tend to view science in terms of trying to make it what it wants to be. RFV, this clarifies a lot. I think it would for most people who look at your theory. It's a distinction well worth making, even though most would agree on at least a desired convergence in the end. CML, good. Now combine the above with my last entry. The difference between a universal formulation of scientific laws and a non-universal one is that the former specifies a complete set of conditions for each law, whereas the latter specifies what may only be a partial set. Unfortunately, undecidability now asserts itself, and we have to admit that even when we have what we think is a consistent universal formulation, it may not be complete below a certain level of generality, i.e., above a certain level of detail. In this sense, the work of science is never quite done, the universe is still in the process of creation at any point in time, and certain axioms may not be expressed. But note also that the CTMU is being formulated as a general framework for the resolution of specific scientific issues, and does not pretend to be complete in the forbidden, specific sense. To this extent, you can stop worrying that the CTMU, like some kind of Krang theory, purports to explain everything in detail. It doesn't. In the CTMU, as in Hume, reality coincides with perception, and also with its cognitive underpinnings as described by Kant. I don't think Hume ever would have conceded the parenthetical statement, would he? Not the Hume whose underscore concerning human understanding underscore I read. Is there a section I should reread? CML, no, you're quite right. Hume said that mind was a mere illusion induced by perception. I'm saying he was wrong. Mind, like objective reality, is a full-blown aspect of perception. That neither Hume nor Kant had the full story is why we need the CTMU. Indeed, science already effectively describes reality as a de facto blend of thought and perception, with theories using rational relationships to weld together our shared perceptions. RFV, that is good. Scientific theories can thus be regarded as common generalizations of those little impressionistic dots you mention. So when we set out to construct scientific theories, which is, after all, what we're doing here, we must first buy into the assumption that there are commonalities among our perceptions. And this isn't really a questionable assumption, because those perceptions, as opposed to our personal interpretations of them, can always be scientifically reconciled. This reflects the fact that reality is logically self-consistent, which in any case can be established by reasoning along the lines described above. Yes, although sometimes people like Dirac think it may not be. CML, although some people think that quantum state superposition violates 2VL, it doesn't, because no law of mutual displacement is in effect among potential states, only actual states. I think that's what you mean here, anyway. If you're right, then Wheeler's title for his thesis, Observer Participation Thesis, would seem to indicate his agreement with me about what constitutes an observer, namely anything able to participate in an irreversible change. That happens also to be mine. It is a good concept that concedes what has to be conceded without selling out altogether. It also is in stark conflict with relativistic concepts. Hoops, let's stay on course here. That's good. Then you're amenable to a formalism in which the universe perceives itself through the objects it contains. That's SCSPL, and that's the CTMU. RFV, perhaps amenable, but at any rate to the notion that it contains irreversible observership changes. It's even simpler than I put it above. Experience entails something that experiences and something that gets experienced. So if reality consists everywhere of experience, it is everywhere self-experiencing, and has everywhere the character of both mind, the subjective experiencer, and objective reality, that which gets experienced. A good notion, but I see this from my background as more of a demonstration of observer/controller equivalence duality. From absorber theory, Wheeler also, there is no significant distinction to be made between emitter and absorber. In tracking technology, the algorithm for tracking many targets to minimize uncertainty is essentially the same, an inverse, as that to situate sensors so as to maximize observability. Two different languages describing precisely the same thing. The main difference, my language has been developed in the direction I've been outlining, resulting in a global reality theory. RFV, of at least secondary significance, is the difference associated with the other dualities involving the inverses of fairly involved mathematical transformations. CML, well, if you're not talking about simple line/plane geometric duality, you're probably talking about VAV equal HOM, V, R, avenue equal HOM, V asterisk, R, duality in multilinear algebra, which is what I'm guessing from your relativity background. That is, the way a basis B of an algebraically reflexive vector space V gives rise to indexed coordinate functionals comprising a dual basis B asterisk of V, and iterating this relationship once more takes you right back to V, i.e., to V, which contains no further non-trivial structure beyond that of V. Yeah, that has an approximate parallel in the CTMU, to wit, V is analogous to syntax, V** is analogous to the set of mappings from syntax to perceptual reality, and V is analogous to the set of metaperceptual mappings from V** back to syntax. It's about self-reference, a basic feature of self-perceptual reality. Incidentally, that's what I mean when I talk about how the theory of metalanguages is embedded in the structure of reality. The analysis of perception involves a metalanguage of object-level perceptual language, and reality employs such a 2VL-based metalanguage in order to enforce self-consistency. In fact, where L is the object language of single percepts, perceptual objects, arranged in time and empty space, and U is the perceptible universe itself, the entire perceptual maplu is distributed over reality, and so is the metalanguage L, referring to it. If this looks a bit like the M2 notation we employed above, that's no accident. The event, multi-particle, IED is the site within which consistency is preserved, control is effected, and every other metalinguistic function is executed. The IED accesses the conditionally distributed metal syntax. So the categorical imperative relating the subjective and objective aspects of reality everywhere coincides with experience. I have always seen the duality as action/observation, both fairly closely associated with a subjective view of reality overlaying a physical level. Not worth pursuing here probably. Maybe so. One of the best ways to achieve understanding is to see the same things in as many different ways as possible. But remember, according to distributed solipsism, which is simply a correlate of yesterday's blue shades analogy, subjective reality overlays physical reality dualizes as physical reality overlays subjective reality. The dual viewpoints are complementary and mutually essential, and this is the point. From this duality, plus a big load of logic, the CTMU follows. RFV, well, actually the duality I was musing on was the action/observation one analogous to the tracking/sensor assignment duality. There is for any set of observations an ideal action of sensor positioning that minimizes uncertainty. CML, sounds very interesting. And I think we're talking about somewhat the same thing, in that reality theory is about finding an optimal syntactic configuration from which to consider multiple observations and interpretations of reality. In this case, action is cognitive and involves the selection of appropriate metalinguistic principles and parametrizations for evaluating object-level syntax, cognition, and semantics, perception. Now, how's that for an earful? By the way, where do I find out more about these observer/tracker algorithms, preferably from a layman's viewpoint? Hope you like this as much. RFV, I have, but to tell you the truth, I'm exhausted. I hope my recently withered IQ isn't embarrassing itself too badly. CML, not at all. You still seem pretty smart to me. If you just think about how points made so far might apply to your further questions, I think we'll be fine. Part 6. RFV, I believe I understand, and am sympathetic with your notion that T reflects all we know with regard to the operation of U, and it makes little sense to blabber about that which is beyond such an understanding. I have very little difficulty with this. This is what seems very scientific to me. On the other hand, what I have extreme difficulty with is my insistence that T is not U in the sense of T being our theory of how U works and not the particulars of the night sky, a child's smile, etc. To say that T is that, i.e., U, is more than I can acknowledge as of yet. I am not going to worry too much about how consistent I'm being, you can identify if and where my positions seem inconsistent to you. But suffice it to say that I think I have less difficulty with your subject, object, perceiving/perceived, dualism than the T/U. The reason for this acceptability derives from my own acknowledgement of transactions being all we can know of what is real in any case. And here we have observer and observed shaking hands as in absorption theory. So in the sense of perception being the operation on U, U is self-perceptual as I now take your meaning. CML, this is promising except for your continuing difficulty with the T/U dualism, which seemingly reflects your desire to have it both ways to admit that mind equals reality, but reject the implications of this admission regarding the nature of theories. In fact, your T/U distinction entails the subject/obj, observer/percept, abstract/concrete, and solipsist/objectivist distinctions, which we have already shown are ultimately illusory. So the T/U distinction must be illusory as well. Your problem is that you insist on viewing T in the ordinary scientific way, as a temporary and unreal abstraction that will inevitably be superseded as real data accumulate. Unfortunately, that amounts to clinging a priori to the objectivist model. What you have to do is forget about T and pay attention to the limit of T, i.e. its syntax sin, T, the part of T that remains invariant as T evolves. For reasons already explained, sin, T, is also the reality syntax sin, U, sin, T, equals sin, U. So T, as opposed to the mapping M, tau, is almost invariably true on the syntactic level, i.e., has a model in sin, U, although perhaps not the one we have in mind. Remember, we've already shown that the abstract dimension of U is real in a general sense, and can therefore be described as the abstract phase of U. Call this phase U_UB. Now, U_UB permits the abstract existence of physically unrealizable relations, i.e., relations that cannot be consistently mapped to the physical phase U_physical as semantically interpreted. Your apparent assumption that everything in U_UB must be realized in U_physical is neither correct nor implied in anything we've discussed so far. Please try harder to lose it. RFV, if you mean this in the sense of Berkeley, whereby our perceptions are all we know of objective reality, I buy it. In his concept, there is some basis for these perceptions and there is little, if any, he thinks it would actually be a negative advantage in accepting matter over spirit. I have no real problem with that. CML, it's good that you have no problem with that, because as Berkeley pointed out in less sophisticated language than we're presently using, the only alternative is to accept that matter is uncreated and eternal, which is totally opposed to what we actually know of temporally finite physical reality and turns out to be logically absurd to boot. What Berkeley called spirit, we call telesis. RFV, the concrete phase means something different to me perhaps. I see a needle on a tree. I perceive it exclusively as a needle and not as an abstract result of a theoretical process whereby it grew and the weight of gravity that brings the limb on which it hangs before my window. There are probably billions of similar needles in my purview, but they are only there in the sense that I would miss them if they were mostly all gone. Perceptions are not very directly supported by theory is what I'm saying. They're just there. They are the given. CML, right, perceptions are given. But so is their consistency with other object-level perceptions, and so is the consistency of the higher-order relations educed from those perceptions. Without those relations, your needle percept is quite meaningless, and in fact, can't even occur. That's because these relations are responsible for your ability to distinguish that one little needle from everything else. In other words, the n-ary relations you educe from the set of perceptions including the pine needle, as included in the variable, evolving part of T, converge on the T syntax sin, T, equals sin, U, which underlies your ability to make the perception in the first place. Please think about this in light of my first entry above. RFV, T equals a global distributed formulation of the reality syntax. Certainty implies a faith in the comprehensibility of the laws of nature, that I don't have much trouble with, but much more than this. It implies that the universe cannot be without such a formalization. This implies that the formalizations we discover have to correlate with an actual a priori formulation. I have some difficulty with this, I think from a scientist's perspective. I tend to see the universe as just being there and about which we discover certain regularities by which we can describe it efficiently. Our descriptions are ours and have little if anything to do with it. CML, now hold on there. Neither faith nor comprehensibility is implied by the phrase you're quoting, at least in the sense you seem to presume. All that's implied is consistency. The logical consistency of perception implies all by itself that a global distributed formulation of sin, U, exists. This formulation need not even be complete, beyond what's necessary for consistency, it may contain all kinds of ambiguity. It can even be a set of consistency-preserving syntactic automorphisms rather than a single formulation. But consistency is a sine qua non of existence, and you cannot exist not now, and not ever without a higher-order logical relationship representing and affecting it. It's important for you to grok this fact. No consistency in higher order, inter- and intraperceptual relations equal contradictory object-level perceptions equal multiple dissociated realities. That's not a negotiable point in reality theory. RFV, I see what you're saying, but I see a humbler scope of such formulations. They do feel necessary in some sense, but at this stage of discovery it seems extremely arrogant to presume such a scope to our rather humble endeavors. CML, well, Fred, we're doing reality theory here, and if your idea is that we shouldn't use existential, as opposed to constructive, reasoning because we don't yet know all the details of what we're reasoning about, then you're not prepared to reason about the nature of reality and you never will be. You see, for reasons already touched on, like undecidability, we're never going to know all the details. But we damned well know enough to work with on a general level right now, and that's what we're doing. RFV, I do not have real perceptions that are true or false, they are merely perceptions, i.e., a photon, seeming to impinge upon the eye, etc. I must make conjectures with regard to these perceptions that then may be true or false. Do you see this differently? If so, there is definitely something more to your perception of 2VL than meets my eye. CML, this is incomprehensible. You have a set of perceptions P_I equal 1, 2, 3, and the truth value of that set is T, otherwise, the exceptions are illusions and not perceptions, which means that others in this reality can't share them. Now, something either is in that set, T, or is not in that set, F, so 2VL rules. Note that we're talking about plain old object-level sense data here, not the higher order interpretations or associations they might have triggered when you received them. The truth or falsity of these is another matter entirely. That's just the way it is. Any two people who won't both admit that the perceptual basis of reality is 2VL have nothing to discuss. RFV, again, I think we have quite a bit to discuss, but I don't see the preceding statement as meaningful. I think I understand the necessity for 2VL in discussion perfectly well, although I may not, but I do not see immediate perceptions as either true nor false, i.e., their type is other than logical. CML, again, this is incomprehensible. Please reread the last entry above. If perceptions were other than logical, then there would be no consistency among the perceptions of various observers. Goodbye, science. In fact, goodbye, reality. Again, this is not a negotiable point. Obviously, perceptions don't consist only of logic, there is plenty of syntactic and semantic variation involved as well. But even that is ultimately governed by logic. The most we can do is differentiate between perceptual qualia and their logical correlates, despite the logical nature of the connection itself. But in that event, math and science would be a useless farce, because what one of us perceives to be true, and even tautologically true, may not be acceptable to the other. RFV, again, I concur other than on the use of the word perceives. I would say conceives or thinks as distinct from a perception. CML, on one level, there is a distinction between conception and perception. On another, there isn't. The set of possible conceptions in U_UB greatly exceeds the number of possible perceptions in U_physical. But every perception in U_physical must conform to a configuration of sin, U, in U_UB, because that's the basis of your accepting syntax, the structured set of mental states in which you are aware of perceiving something. CML, as I've already explained, any isomorphism to whose range and domain you can't assign different qualitative or quantitative coordinates at a given level of discourse is really an identity relation, at that level. RFV, but and I see this as important, U has much more in it because of its actualities. CML, sure it does. If there are actual perceptible distinctions on a given level of discourse or conceptualization, then these will prevent an isomorphism from collapsing to an identity relation on that level, whether or not you can efficiently formulate them. But we've already ascertained that there are no perceptible distinctions between mind and reality on a high level of discourse. So what you see as important actually means nothing to us here. For example, the law of conservation of momentum, and its underlying arithmetic, is everywhere valid, but only active and perceptible in the presence of actual moving bodies. RFV, so the conservation laws of T tell us what will happen from an initial condition, if we accept determinism, but the U includes those conditions. CML, there is always a level on which a theory T is deterministic. Even a probabilistic theory is deterministic in the sense that if it is valid, its probabilities must be realized over many trials. And as you know, the initial conditions provided by U are ambiguous on the quantum scale. This gives U a certain amount of freedom within the boundaries of its deterministic syntax. Similarly, physical reality is merely an evolving set of instantiations of a set of relations that are everywhere valid. These instantiations are metrically separated, but the metric itself is completely characterized by a distributed form that exists in every part of space that could ever be occupied by your brain, even if your brain has only managed to figure a little bit of it out by firing isomorphically to it. The distribution of this form throughout space distributes your mind over reality in the form of general mental syntax. RFV, a distributed form or syntax is not the sentence. CML, no, nor is that implied by my paragraph. However, the sentence must conform to the syntax that distributes over the language in which that sentence is formulated. Otherwise, the sentence will violate syntax and make no sense. CML, I think one of the problems so far is that you haven't really absorbed the fact that the distinction between mental, abstract, and objective, concrete physical, reality is a stratified distinction that gradually disappears as we approach the top stratum, global distribution. RFV, let's assume this is my problem. Then at some level physical reality has been abstracted such that it is in some sense isomorphic with the mental, abstract, description. I would still have problem accepting that, even if this agreement could be reached, at lower levels the isomorphism is preserved. This is counterintuitive to me. CML, what you seem to be saying here is that you don't think object-level perceptions, which comprise the lower levels of the mind-reality isomorphism, need to be logically consistent with each other. Let me repeat, this is not a coherent philosophical or scientific position. An inconsistent reality is no reality at all, but a set of mutually disconnected independent realities. Any contrary assertion makes no sense whatsoever. Less general, more conditional features of reality appear to be localized within their specific instantiations, permitting internal-external distinctions. In this sense, cognitive, or computational, distribution relations are equivalent to topological inclusion relations. That's a CTMU duality principle. RFV, I think you have produced an argument why the isomorphism is preserved at the lower levels, but it escapes me. The new terms don't help me with this. CML, to simplify, space-time is qualitative in the sense that space is like a layered sequence of Venn diagrams, space like hypersurfaces to which cosmic time is normal, in which circles represent predicates defined on physical observables, and time is like logical substitution within those domains according to various rules of implication. The domains or Venn circles are called IEDs and are associated with events from which objects are interpolated. To illustratively adopt an oversimplistic graph-theoretic model, object world lines amount to edges in a space-time graph whose nodes are events. These qualitative IEDs expand at the rate c and then collapse into a new event within their mutual intersects. Inside the IED you have simulative computation or cognition. In the compact output event to which the IED collapses in cosmic time, you have the mutual perception, interaction, of two or more objects. The interior of the IED is wave-like, cognitive, and simulative. The output event is particulate, informational, and objective. That's wave-particle duality, actually a temporal alternation between spatiotemporal and objective states of material being. In this way, space-time is identified with the mathematical and physical laws that govern it. This spares us the absurd necessity of having a non-physical storage space for the laws of physics, or by extension, a non-mathematical storage space for the laws of mathematics. Please reread the above paragraph over and over again until you understand it. Then define Cons-pansion as follows. Cons-pansion consists of two alternating phases of matter and energy, inner expansion as an IED, inner expansional domain, at the rate c, and requantization as an event component. Requantization is just the collapse or decoherence of the quantum wave function, as computed by the simulative computation going on in the coherent IED, with a reduction in scale that follows from the absence of an external metric against which to obtain an objective measurement of the size of the universe. This implies that the size of the universe is for all practical purposes invariant, and its apparent expansion, from an interior vantage, is actually a relative shrinkage of content, from a global vantage. Eddington knew about this global-local duality, even realizing that as objects shrink, time scales would have to shrink apace, i.e., time would have to accelerate or contract. But he didn't know how to do the logical setup for the shrinking atom scenario. The CTMU does the setup, in the process solving problems Eddington could only have dreamt. Down below, you complain that I haven't explained what Cons-pansion is. Please make sure that you carefully consider what I've written here before repeating that complaint. If distribution is general or unconditional, on the other hand, it applies to all things, and the distinctions among these things exist within it in the sense that it resembles a self-executing program instruction that internally simulates them. RFV, you seem to have no conception of the obstacles to accepting this. First of all, you start out with if, but you don't really mean if. You mean that it is that way. But you combine general and unconditional as though they were synonyms. They are not to me in this context. I don't know how familiar you are with computer programming or execute type instructions or the various levels of programmed simulations, but being familiar with all of them myself, the sentence is incomprehensible to me. Am I too hung up on their jargon meanings to allow them to be generalized as you seem to think you have done, or what? They seem like ill-chosen words to throw into this cauldron. CML, we've already been through this, Fred. Just replace if with where, and consider that I'm distinguishing among ways of formulating laws. General means representing a range of possible specifics. These specifics are distinguished by the conditions applying to each. So when something is general, it implicitly represents a whole range of possible conditions. Now, when something represents a whole range of possible conditions, A, B, C, it's unconditional, it doesn't need an if, A, then or if, B, then or if, C, then condition in front of it to be predicated on a given object in the class of objects it represents. For example, let the predicate hard, as used in diamonds are hard, represent the class of diamonds equal, clear diamonds, blue diamonds, big diamonds, little diamonds, and so on. Then hard is general with respect to this class, and if we have a diamond D1, any damned diamond at all, we can say D1 is hard without knowing what kind of diamond D1 is. I.e., we don't have to say if D1 is a blue diamond, then D1 is hard, we know it's hard regardless of specific type. That means that the general predicate hard is an unconditional predicate with respect to the class of diamonds. That's all. Frankly, I have no idea what professional jargon you're talking about here, but if what I've just said makes no sense in light of it, then my advice would be to lose it fast. In other words, general features of simulative space-time include specific aspects as output, which is then uploaded to space-time as further programming, and so on. Topological inclusion follows from computational inclusion because topology is computationally simulated. RFV, Chris, these sentences mean absolutely nothing to me. For example, general features of simulative space-time, all that comes to mind is spatial temporal location of events. What general and simulative add I cannot figure. Then, uploaded to space-time as special programming. Is there someone other than Chris Langan that you envision capable of understanding that phrase? What is it that enables that person to understand it? The words are all in my vocabulary and the grammar is straightforward, so what's wrong? I guess you can say I'm too stupid, but then this 6-word quiz better have a pretty clever answer. What is it? CML, with all due respect, let's get something straight. Did you or did you not read that GMUSR doc file? Or did you just scan and forget? Because if you'd read it closely, you'd know that reality is treated in the CTMU as a self-simulation with a programmatic, simulative computation, phase and an output, perception, phase, and you'd know how these phases are related in the Cons-pansion model of space-time. That file explains how all this logic we've been discussing is physically implemented. Now, if you didn't understand one word in that file, please refer again to the description of Cons-pansion given above. Because I intend to keep writing in a way calculated to trigger meaningful associations for you in light of that knowledge. RFV, yes, I'm trying, both to you and me. If everything is defined as 2VL except for undecidable statements, it is not a very useful concept. Electric currents are 2VL in a trivial sense, like your triangle may be pink. That is not an essential aspect of them. CML, nonsense. 2VL unequivocally governs the macroscopic, and in a more restricted sense, even the quantum, behavior of electrical currents. Nothing at all, is more essential to them. If that weren't true, you couldn't achieve a stable perception or description of what an electrical current is, much less its source, its direction of flow, or anything else about it in any given case. You seem to think that logic can somehow be conveniently in effect without being essential to whatever phenomenon you're considering. But that's utter nonsense, because in that case, you'd need to explain what it is that remotely enforces the effectiveness of logic with respect to that phenomenon, and you can't do that without me then forcing you to explain why logic applies to your remote control mechanism, and so on ad infinitum in an absurd infinite regress. So the bottom line is this: either produce a finite explanation for such a mechanism, or accept the truth, logic is essential to everything we will ever perceive. Because from now on, I'm not going to argue about whether or not various aspects of reality coincide with and obey logic, they damned well do, period. They coincide with and obey it right up to the point at which the consistency of perceptual reality is affected. What they do beyond that, I don't presently care. And at this point of the discussion, neither should you. RFV, naturally, one can do accounting like an accountant where every item must be put in twice, but it's senseless. To say that E&M is a series of statements about which one says each statement is either true or false is ridiculous. Any valid theory is true by definition, but that does not make the theory a 2VL theory. We've got to get past this. CML, we sure do. Try this on for size. M theory is not 2VL with respect to your personal knowledge of it. All you can personally do is formulate a set of subjective probabilities conforming to modal and probabilistic many-valued logics, which are themselves 2VL theories. But given any set of hypothetical non-probabilistically formulated statements regarding M phenomena, each and every one of those statements is either true or false in point of fact, unless it's formulated on the quantum level and obeys the superposition principle, which in any case must yield to T or F actualization. Now, that distinction having been made, consider that what we're talking about is just the distinction between the evolving and invariant phases of T, i.e. T, and sin, T, respectively. RFV, a theory describes the general behavioral rules, not the contingencies of any particular configuration. CML, no, but given any hypothetical set of contingencies, the theory, in conjunction with the 2VL component of its syntax, will impose consistency constraints on them, and these constraints will ultimately be formulated in T or F terms. If the theory imposes no such constraints on sets of objective contingencies, then it's as useless as tits on a boar. It has no predictive value whatsoever. So let's not bother with it, okay? The phrase generalized cognition, actually synonymous with time. RFV, how in hell did we get here? I take a synonym to mean that a dictionary can help me, but it doesn't here. CML, a synonym is a word or phrase that means the same thing as another word or phrase. Dictionaries are great, but we're at the stage of defining terms here, and if they were already in a dictionary, we wouldn't be bothering. We'd just be citing dictionary entries. Unfortunately, constructing a new theory is seldom that easy. Stay awake, Fred, this is a challenge for me too. CML, all you need is your memory, because we've already been through this. RFV, * you're having told me something in the past, and my remembering or not, is not all I need to understand your concept of time/generalized cognition. CML, you've already agreed that mind is ultimately indistinguishable from reality. Minds evolve along a state transition parameter called cognition, reality evolves along a state transition parameter called time. So on the level of generality of the mind equal reality equation, cognition equal time. I.e., given the high level of generality of the M equal R equation, generalized cognition equals time. That's it. Don't keep trying to introduce artificial distinctions where there are none. Although I'm sure you could keep on doing that forever, it would make my task as an expositor impossible. The operative analogy is time, space, cognition, information. RFV, I don't even accept this as a valid analogy, let alone move on from there. CML, here's the problem, Fred. You're not even thinking about how to interpret this analogy, you're just getting visibly impatient with it and putting the load back on me. But as long as you've already done that, consider once more the paragraph just above. Minds evolve along a state transition parameter called cognition, reality evolves along a state transition parameter called time. So on the level of generality of the mind equal reality equation, cognition equal time. I.e., given the high level of generality of the M equal R equation, generalized cognition equals time. Now, where the abstract equals the concrete, matter is abstract information. And so are relations among material objects. But relations among material objects can be factored into spatial and temporal components, the difference being that while the spatial components are perceived in parallel, i.e. simultaneously, the temporal components are perceived as a sequence of spatial components. But time consists of the temporal components, and according to what we just wrote, time equal generalized cognition. So what is space a generalization of? What else but that which is transformed by ordinary cognition, namely information? So we have the following analogy. Time, cognition, space, information, where, means is a generalization of. This obviously transforms to time, space, cognition, information. Please think about this for a while before taking me to task again. This analogy is every bit as clear an analogy on any IQ test you might take, given previous explanations. I.e., time equal info processing equal generalized cognition, where information here refers to the abstract dimensions of real objects and processes, which, as we've already seen, coincide with them. RFV, this does not compute. Info processing requires time, so in what sense can time equal info processing? What are the abstract dimensions of real objects? Space-time coordinates, linear and angular momentum, etc. are all that come to mind. Is that correct? CML, a parameter, Fred, is a general predicate of all the specific things which are parameterized by it. Thus, the parameter called time is a generalization of any physical or mental process. Now, where reality is abstract, reality is information, and time is a generalization of all of the processes undergone by that information. So time equal info processing. The abstract dimensions of real objects are the abstract parameters in which objects are distinguished. Simply extends human cognition to generic information processing. RFV, now that's easy enough, but I sense that you assume that I will be accepting more than that. CML, you're right. Reread the above if necessary. RFV, how does /can time perform this function? CML, time is not a thing, it's a function of space-time. RFV, I could accept it being a dimension or direction of space-time, but not a function. In what sense do you see it as a function of itself? CML, because, as just explained, it's a generalization of all of the processes, functions, it parameterizes. Time is not merely a spatial dimension, even in relativity. It is the function by which space is transformed. Don't be misled by the fact that for certain purposes, time can be conveniently represented as a space-like dimension. It's absolutely not, never was, and never will be. If it were, we could take a walk to ancient Greece and visit Plato. Space-time performs this function because it's full of syntax, and some of this syntax is grammatical as opposed to structural. Grammar governs the evolution or state transition of the language of reality. RFV, you are placing syntax where sentence should be, it seems to me. Space-time must contain what is real, not the form of what is real. CML, do you see what you're doing here, Fred? You're distinguishing between what's form and what's real, and then hanging your distinction on space-time. The implication, of course, is that form gets conveniently crammed back inside the human head, or maybe some Platonic realm of ideals way out there in hyperspace, and reality gets to continue to hang out in objective space-time. Bullshit. We did away with that distinction, what, 50 pages ago? And you agreed that it was done away with. Yet here you are, once again telling me that for some odd reason you can't explain, form and reality can't both reside in space-time. I just don't get it. Please try to get a grip on this. Thus, time is any grammatical implementation of the SCSPL reality syntax. RFV, I think this blows the validity of analogies I'm trying to grasp. CML, I think you better rethink that. CML, nomology must exist up to determinacy, or its absence would show up in the form of irresolvable perceptual paradox. RFV, could you explain why? And then could you relate this to the current non-deterministic theories of QM, etc.? But simply. CML, if nomology, i.e. laws of physics, were not at the very least associated with a deterministic set of constraints assuring the mutual consistency of perceptions, those perceptions would not be consistent. Beyond the degree of determinacy needed to ensure consistency, there exist various degrees of freedom. These degrees of freedom are what show up in non-deterministic theories like QM, etc. Indeed, all these theories are themselves deterministic up to the point needed to ensure consistency, their non-determinacy kicking in only once that need has been met. Simple enough. In general, the universe is a balance between determinacy and freedom, and we can talk about either part without denying its complement. A distributed abstract nomology to which perceptual reality must conform ensures the resolvability of paradox, which is just a way of saying the self-consistency of reality. RFV, are you saying that to be self-consistent, theories of physics must be deterministic? Why? In both senses of why does CTMU require it and why does it make sense from a physics point of view? I hope making a distinction here is acceptable in a conditional sort of way. CML, anything is deterministic with respect to which we can't just as well flip a fair coin. That is, determinacy and randomness are complementary aspects of any theory, the deterministic side remaining invariant with respect to the incidental content that gets fed to the theory, and the non-deterministic side reflecting variety of objective content, and in QM, the behavioral randomness of single objects. Consistency is not an option, but a necessity in both physics and the CTMU. So it is deterministically enforced, either at the object level or among higher-order relations of objects. However, this does not preclude a complementary measure of freedom. The freedom is simply constrained not to violate the determinacy. If you roll a fair die, the freedom, non-determinacy, randomness, of your toss does not violate the deterministic fact that the outcome must be one of the numbers from 1 through 6. Freedom and determinacy consistently coexist. CML, our respective electrons are distinct images of a single distributed syntactic photon consisting of the rules that all photons must obey regardless of where they are. The images reside in different locations, and these differences are significant. But it's like Wheeler said to Feynman, they're all one photon. RFV, do you really mean that leptons are generically speaking photons? Or what sense do you give the above in this regard? Why and in what sense are all photons one photon? CML, they're all one photon because they all have identical structures and behaviors up to the deterministic aspects of their common syntax, excluding degrees of freedom like frequency and location. They can all be regarded as instantiations of a single distributed abstraction. The distribution of syntax is not a replication and scattering, but a multiplexed projection of one underlying unity. Actually, Wheeler was talking about electrons, not photons, but the idea is approximately the same even with regard to exchange forces. CML, because the isomorphism M is a perfect equivalence relation with respect to everything but degree of generality, the abstract is more general than the concrete because one abstraction can possess many concrete actualizations. RFV, I don't think I can accept that an abstraction possesses many concrete actualizations. In fact, so far I think this is my biggest problem, the actual is significantly other than the generalization of its type. CML, no it isn't. Again, you're reverting to your favorite distinction, that between the actual and the abstract, on an a priori basis. I'm simply not gonna let you do that anymore. If you want to do it, the burden of proof is now on you to show where you're getting your distinction and why it's valid on your chosen level of discourse. Hint, you're not going to be able to deliver. So why not just drop it right now and save yourself the trouble? Think about this for a while. On the other hand, unicorns do not exist can be interpreted over an even larger real context, and to that extent is quantifiably truer in a concrete context. RFV, truer, as in bluer. Is this 2VL? CML, this is 2VL predicate logic. When one quantifier embeds or properly contains another, the associated predicate is true for more objects or true over a larger range or has greater scope. So if we feel like it, we can say that it's truer in precisely this sense. Hey, you're the one who brought up unicorns, and I'm just telling you what 2VL predicate logic has to say on the issue. If you like it, great. If not, oh, well. CML, information consists of distinctions in which one thing is syntactically constrained to differ from another. Because concrete reality mirrors the abstract information coinciding with it, it too can be regarded as information, we're information too, and the reason all this info seems concrete is that there's a syntactic displacement principle in effect. RFV? I don't get this. CML, the concreteness of matter is associated with the fact that one piece of matter displaces another, to revert to the terminology up top, that's inherent in sin, U_physical. This is not true of the abstractions to which pieces of matter correspond. If it were, the QM superposition principle wouldn't work. So the question arises, what does this information become when all the binding constraints are removed? The answer is unbound telesis or UBT, the ground state of being. This universe has only arisen within the UBT ground state because it has constrained itself to do so. This is the sense in which it's self-configuring. RFV, the universe has arisen implies the supposed temporal origin of reality. But from your system alone, why would there be an arising as against a stable omnipresent ubiquitous system? CML, I'm using terms like arising mainly for your benefit, not mine. As I use it in this context, it describes a sequence of implications, a logical dependency relation. You just described my system to AT, provided you're not making the error of clinging to an infinite steady-state model of reality in spite of mountains of contrary, Big Bang-style, evidence. In fact, my system is the only system that both conforms to your description and satisfies the cosmological evidence. There's no other way to go. Hear me now, believe me later. Cognition, time. RFV, don't got it. CML, that's okay, we've been through it at least thrice up there. The logic is so simple it hurts. RFV, I know, but I still ain't got it. CML, that's okay, we've been through it at least force up there. Human cognition, assumed to be fundamentally unique by anthropocentrists everywhere, is just the temporal processing that goes on in a brain. Of course, there may be more to it than that, and there is, but for present purposes, that's good enough. The more in question has to do with distributed solipsism, and the consequent fact that there is a sense in which sentient cognition is primary, that what goes on in reality, namely temporal processing of all kinds, really goes on in the minds of sentient observers. RFV, this soothes my mind, but all of this is not just time. CML, sure it is. It's the refined kind of time that passes in a brain. RFV, this concept of time has still not been purchased by me even if we have now reiterated your position 5 or 6 times. CML, too bad. Like I say, I'm done with this one, Fred. The burden of proof is now on you to establish a distinction. Hint, you already agreed with me to discard the distinction, so I don't even know what you're talking about here. If the universe is a mind, then it transforms spatial hypersurfaces in time. This is directly analogous to the way a human mind or any other automaton transforms states. In particular, a form of duality that can be referred to as space-time object, wave-particle, or just plain conspansive defines an alternation in which the mind solipsistically configures reality by a cumulative selective filtration of syntactic potential. During the inner expansion phase of conspansion, the mind builds a set of exhaustive potential future realities by superposition, and in the requantization phase, selects a future reality in which to re-embody itself as a material. Brain. You're going to have to give me the tutorial on conspansion, I think, and define your usage of some of these terms. CML, it's right up there. And may I say that it's a pleasure to find in you such an avid student of the CTMU.